coleslaw. Coleslaw. Nickling. Ready na naman na pala eh.
etiquette. Number 1. If using a laptop, tablet, Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chatbox and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
Good morning, ladies and gentlemen. We would like to request our sponsors and delegates to please settle down as our program is about to start in 5 minutes.
What I want, you got, and it might be hard to handle. But like a flame that burns a candle, the candle feeds the flame. Yeah, yeah, what I got, full stop of thoughts and dreams that scatter. When you pull them all together, and how I can't explain. Oh yeah, well, you make my dreams come true. On a night when bed dreams become a screamer, when the messing with the dreamer, I can laugh it in the face. Twist and shout my way out and wrap yourself around me, 'cause I ain't the way you found me, and I'll never be the same. Oh yeah, well, 'cause you make my dreams come true. I'm down on that daydream. Oh, that sleepwalk should be over by now. I know. You, yeah, yeah. You make my dreams come true. You make my dreams come true. Now listen to this. I'm down on my daydream. Oh, that sleep walk should be over by now. I know. Oh, yeah, yeah. You make my dreams come true. Oh, yeah. I'm waiting for you, girl. Oh, yeah. You make my dreams come true. Me, you, me. I'm waiting for you, girl.
Let's put ourselves in the presence of the Lord.
Praise be the name of the Father Almighty, creator of heaven and earth. Lord God, you are the greatest electrical engineer. He who has all the power in the world, he who created the light for men.
Please inspire us with just the tiny spark of your divine wisdom. So as we do our work and in our everyday lives, it is really your work that is done.
Loving God, make our heart your heart, our minds your mind, and our hands your hands.
Make us your instruments, so that we be always conscious and mindful that our work and everything we do depends on the life, safety, and property of my family and fellow men.
Bless us also with the gift of love and sensitivity to respect the people who use the products of our work and our fellow engineers as well.
All this we pray and we ask in the mighty name of Jesus. Amen.
A pleasant morning to our officers present here with us at our venue, to our exhibitors, to our panelists, and to our delegates from our two virtual venues. Welcome to the third day of our 7th IIEE Metro Manila Regional Conference. So before we start, we would like to remind our delegates that our virtual exhibit is already open. You can visit the booths and no need to worry that you won't get locked out once you click the event hub link. So if you are interested, you can check those links at the chat box. So to start with our technical sessions, allow me to introduce our first resource speaker. He was a Dean's Lister and a product of Far Eastern University, Manila. He is a professional electrical engineer with almost 30 years experience in the field of electrical engineering and has worked in so many countries such as Philippines, Singapore, Malaysia, Japan, South Korea, Venezuela, and Canada. His specialization is electrical system design, power system analysis. He worked as a site engineer at Becca Carter in 1994 to 2003, engineering supervisor of Toyota Philippines Corporation in 2004 to 2010, and he also worked as senior engineer at Dalim Industrial Corporation in 2010 and SNC Lavalin in 2010 to 2014. At present, he works as a department manager at Toyota Philippines Corporation for 6 years now and counting. He is currently the Vice President for Internal Affairs of IIEE Metro North Chapter. Ladies and gentlemen, let us all welcome Engineer Archie F. Balmes.
Okay, good morning to everyone, all the electrical practitioners who are present this morning. So thank you, Ms. Yas, for that kind introduction. Good morning din sa ating mga honorable Board of Electrical Engineers. I'm not sure if they are present early this morning. Anyway, pleasant good morning din sa ating mga national officers na nandito ngayong umaga. Same din sa lahat ng MMR chapter officers, no, who mostly are my close friends. Siyempre sa aking mga co-officer sa aking main chapter, which is Metro North, headed by our President, Engineer Mark. So, and of course, sa lahat ng organizers of this event from top to bottom, no, as early as now, hindi pa tapos yung 7th MMRC natin, pero as early as now, I would already like to extend my congratulations sa lahat, no. It's really a job well done. Okay, so maraming salamat for inviting me this morning. So without further ado, I would start to share my screen now. Okay, nakikita na ba yung screen ko? Okay,
yes, Sir
I think, yeah, I think it's already in your monitor. So, i-off ko lang yung video ko while presenting kasi 5 kaming gumagamit ngayon ng internet, so I'm afraid na magkakaroon ng problem sa bandwidth. So, allow me to unmute my video just while presenting. Can I do that? No.
Yes, sir. You may, sir.
Okay. Let me just. Okay. I'm just going to. Okay. I think nakamute na. Okay, nawala na yung video ko. So let me start with this topic for today. So basically, our topic for today is the power system design fundamentals. Now presented this August 7 for the 7th Metro Manila Regional Conference. I'm your technical speaker this morning. My name is Archie F. Balmes. Okay, so to proceed, meron lang akong konting disclaimer for this morning. This presentation is more geared on the heavy industrial, oil and gas, petrochemical, and petroleum facilities. No? But of course, it's also applicable sa ibang industry. But somehow, dun kasi yung linya ko. So I mostly try to adapt the procedures that we are adopting on that industry. So it doesn't mean it's not applicable sa ibang projects or industry, but I just would like to clarify that. Only an overview will be discussed in this presentation due to time limitation. So high level lang muna tayo at medyo fundamental lang tayo. Kumbaga, it's only an eye-opener. So most sample calculations will be omitted, although I included some of them, but most of them will be omitted. Of course, we only have 1 hour anyway, so we cannot include most of this. A lot of items also will need to be skipped to save time. Each item na madi-discuss this morning will eventually needs further discussion in a more detailed manner, no? Because as you may know, power system design is very broad. No, it's not enough to discuss it even in 1, 2, 3 days. It's very broad. So let's begin. So the main objective of this technical presentation is to highlight the most important things that needs to be considered when designing an electrical power system. Okay, ano ba yung power system? It is defined as a network of electrical components and devices used to supply, transfer, and consume electrical power. Alam naman natin lahat yon. The main source of supply is done through some form of power generation, for example, power plant. Transfer is obviously done through a transmission distribution system, and the consumption can be through different consumers, no, such as industrial, commercial, or even residential. So we have here the power system network in a nutshell, no. So you can see from here you have the generation, power generation, and then you have the transmission line here where the voltage is stepped up para mai-transmit, and then it will be stepped down further, no, papunta sa ating mga sa ating mga consumers, no, like industrial, and this one you have residential. So this is just the nutshell of a power system. So let's begin first. Ano ba yung mga important design consideration that needs to be considered? Of course, number one sa lahat is yung safety. It is the responsibility of the power system engineer to keep the electrical system as safe as possible. No? There will be three fundamental areas to help to build a safe power system design. Number one is to enclose live conductors in a grounded compartment. Protective equipment and switching devices must have adequate interrupting rating or short circuit rating. And of course, design the system so that working on energized conductor will not be an option. Okay, so of course, marami pa yan. Yan lang muna mga sinama natin. Number two is economics. No? Economics obviously is very important. Actually, parang ito nga yung nauuna sometimes. However, economic is supposed by safety and reliability. No? So ibig sabihin, if you want an electrical system which is more safety and reliability, it will be more expensive. No? Gagastos talaga tayo. So yun yung drawback niya if you really want to save. So there will be some things that you need to cut on. Okay, number three is load growth. So we always try to provide extra power system capacity to allow the connection of future plant expansion. So pag magdi-design tayo, lagi nating iniisip yun, no? So items na need to be considered is the reserve in substation KVA. For example, we need to have a 20% future load, and of course, adequate margin in circuit rating, short circuit rating, and device switching device equipment natin. Another items na pwede nating isama for future load is yung extra feeder BCB for every bus section, or spare motor starter sa mga MCC natin, those kind of things. Okay, next is simplicity. We always try to design our electrical system as simple as possible. So most shutdowns are associated with the complexity of the electrical system. So we will try, although sometimes we cannot avoid, to design our electrical system as simple as possible. Mahirap din pagka kasi very complex yung system mo and then nawala yung isa sa mga key persons nyo sa planta, for example. So ang hirap dun para ma-sustain yung maintenance ng electrical system. So flexibility, an electrical system definitely needs to be flexible and respond as the need arises. For example, we need to at least design the uniformity of motor starter NEMA ratings as much as practicable, although sometimes this is not possible, no, to enable hot swapping in case of breakdown in one of the motor starters. Next is reliability. Okay, as mentioned a while ago, electrical power reliability is directly proportional to production. No? So an hour loss of electrical power supply may mean great loss in production and profit. No? Sa oil and gas industry, isang oras lang mawala na supply, it already costs millions. No? So high service reliability can be obtained in two ways. Providing duplicate alternative power supply, pero yun nga, no, you will need to provide extra equipment and so on. And number two is installing only high quality electrical equipment and adopting the best installation method. Okay. So continuing, number 7 is the selection of equipment. Select only the best equipment available as much as practicable uli, kasi economics, as mentioned, plays a very important role dito. So ratings must be adequate in every aspect, voltage rating, current rating, short circuit capability, etc. Okay, so of course, your electrical system should be designed where it can be maintained without dropping any essential loads. For example, we will try to use draw-out equipment wherever possible to enable maintenance on a circuit breaker element. So yung vertical section lang na yon, na kapag ka nagkaroon ng fault, that's the only one that will be affected, and then the rest of the switchboard or the switchgear can continue operating. This is also to keep the electrical equipment operating continuously and effectively for the longest possible service lifetime. Okay, of course, the codes and standard that we normally use, of course, top on the list is Philippine Electrical Code, and where Philippine Electrical Code were basically derived, which is the ANSI IEEE, American National Standard Institute, Institute of Electrical and Electronics Engineers, and of course, the British standard or the European standard, International Electrotechnical Commission. So marami pang standard, no, na ginagamit, but basically we will just zoom in on these three for now. Okay, and when we talk of standard, we also talk of standard voltage level. So sa ANSI IEEE, it's this voltage here are their standard voltages, no? For example, dito 480, 4160, 6900, 13800, and so on and so forth. The sa IEC naman, we have 400, 415, 3300, 6600, and so on. So when we are doing design, we normally, ideally, we do not mix equipment voltages for each standard. For example, yung project nyo is ANSI, we will try to use this, no, these voltages only in selecting our equipment and in designing our system. We don't normally mix this, no. I know what some of you are thinking, but this is just to remind, proper design should follow the correct standard and voltage level. Okay, also what we need to know during initial is to know what kind of system configuration or electrical configuration am I going to use. So let's discuss a few of them. There's so many of them. Of course, we start with radial. So radial system is the simplest electrical distribution equipment, distribution arrangement, and the least expensive, no, pinakamura to in terms of equipment initial cost. It's also the least reliable configuration. Yun ang drawback niya, since it's only used as a single supply source. So madali naman ma-identify ang radial. It's just like an inverted tree, no? Yung sanga niya nasa baba, and then yung root niya or yung pinaka main branch niya is nasa taas. So it's like something like this. It's very cheap, but it's also least reliable. Okay, continuing, we also have the primary loop, no, as the name itself, we have a loop system sa primary side ng supply nyo, no. The failure of one transformer or feeder cable will not cause the other part or the other section to experience a loss of service. So this has higher reliability, obviously, as compared to radial. So it's like these are the normally closed switches or breakers. So kapag ka, for example, nag-fail yung isa rito, this particular main breaker, so you just basically you just switch these the normally open breaker para ma-supplyan yung side na nawalan ng supply. So it works as simple as that. And we also have the primary selective, no? It's a duplicated source from the power supply point using two primary main circuit breakers and a primary tie breaker or disconnect switch. So this has higher reliability as compared dun sa radial again, no? But you will notice, no, once yung reliability is tumataas, parami ng parami yung mga devices. So that's the reason na nagiging mas mahal siya. So it's like this, no? Normally this is open. So once any of the breakers here, for example, this one trips for whatever reason, magko-close lang yung tie sa primary, and then it will eventually supply the dead circuit. Okay. Next is the secondary selective. This system will remain in service even after the failure of one of the component. Normally, it is called the double-ended system. No, this has higher reliability among the first three that we have discussed. This is also much more expensive, obviously. So makikita nyo rito, dumoble na yung transformer niya, dumoble na yung breaker. Obviously, meron din associated cable and protective devices na kaakibat yon. So it's the same, but this time around, ang switches niya is on the secondary side. Pag nawala tong breaker na to, for whatever reason, we will just it will just be closing this tie breaker here, either manually or automatically. Most of them is automatically, to supply the rest of the system. Now, in this kind of system, the sizing of the transformer is slightly different, no? When we do calculate the transformer, we need to load this only maximum of 40%. So, for example, ang load nyo is 400 kVA, just for example, you will need to choose a 1 MVA straight away. So even it's only for two. Of course, the objective of that is to carry the loads on the other bus section, as you may know. Okay, touch a bit on the SLD. It is also referred to as the blueprint of an electrical system. So this is very, very important for us to understand basically how the electrical system is connected and how it works. Okay, I'll proceed now to load schedule data calculation. Preparation of load schedule actually is, para sa akin, is the most important calculation that should be done correctly. We should never mess up in the load schedule calculation. Wrong load schedule calculation means a screwed up electrical system, basically. So the way we calculate, or the way I will present the calculation here in for the load schedule is slightly different, as mentioned. No? So let's begin. Although there's some procedures here that I have skipped, no, just to summarize. So basically, we need to summarize all the loads. In our end, no, we don't normally deal with in sa oil and gas kasi ang pinaka-architect is chemical engineers. No, they are called the process engineers. And then of course hand in hand sila ng mechanical engineers, no. So we summarize all the loads with very close coordination with the chemical and the mechanical engineers, no. So they're the one really saying anong load ang kailangan, anong rating, etc., etc. So this process alone is very tedious already. So I will not really discuss more on that. Item 2 is to determine which loads are vital, which loads are essential, and which loads are not essential. So this is very important para malaman natin ano bang loads na kailangan natin as vital, essential, and non-essential. Specifically sa mga heavy industry at saka sa oil and gas, no? Kasi it's very, very risky sa mga planta na to. We need to know kung anong mga loads ang hindi pwedeng mamatay no matter what the circumstances is. So, and then we assign each of these loads into their respective switchboard, switchgear, and buses. No. Okay, so after that, we determine which loads are continuous, intermittent, and standby. So again, we need to ask or coordinate closely with the chemical engineers and the mechanical engineers in this aspect. Okay. Although, of course, electrical engineers also have their own load list. No, what I'm saying is we do combine all these loads together with the identified loads of the chemical engineers. No, and then eventually it was sized by the mechanical engineers. Okay, continue. So motor loads shall be calculated based on what we call the brake horsepower. No. Hindi natin kinakalculate yung loads sa load schedule with regards to its nameplate rating. So later I have an example of that, and we also calculate the load or the motor as their power input, not power output. There's a lot of difference between power input and power output. So it's wrong. For example, nakita nyo yung motor, halimbawa 100 horsepower, that's the nameplate rating. It's not the load. So again, this is applicable sa oil and gas, no? Because 95% or even more of the loads are all motors. So item 5, we determine the coincidence factor for the loads. This should be as per project specs or standard. No? Below coincidence factors are recommended if not given. Basically, yung mga top clients namin kasi like Shell, Petron, Phoenix, Total, they already have this in their specs, no? But if it's not given for whatever reason, this coincidence factors are good to adopt. Like continuous load should be at 100%, intermittent load should be at 30%, and the standby loads at 10%. So ano yung continuous loads? Yun yung mga loads na possible tumakbo ng 4 hours or more. Okay? Like main pumps, compressors, and tapos yung mga intermittent naman, yun yung mga on and off characteristic such as the motorized operating bulb, the jockey pump, etc. Of course, yung standby, yun yung mga backup ng mga continuous loads natin. Okay, and then item 6, we determine the normal running load and the peak running load. So these are very important, and these are two different animal, same beast, no? Ika nga nila. Yung normal running load is an 8-hour maximum demand. And yung peak running load naman is a 15 minutes maximum demand. So we need to size the equipment based on these two. So that's why it is very, very important. So the formula for, on how we calculate that is as simple as this one, is this X in percent times E, Y percent in F. That's the normal running load. Ang nabago lang sa peak running load, meron tayong Z percent times G. So yung X and Y and Z is represented by the coincidence factors, which is basically these three here. No? And then the E, F, and G, they are the sum of the continuously operating loads, intermittent loads, and the standby loads. Now, merong catch dito. Yung Y percent F or the intermittent load and the standby load, which is say percent G, cannot be less than the largest individual connected load. So we will have an example of that for us to understand it more. So let's have a sample calculation, case 1. Okay, let's basically in this example, the sum of the continuous, intermittent, and standby loads are already summarized, no, para to save time. It's really a lot of time to do this. So in this example, meron na tayong 6,020 kVA na continuous load, 600 kVA na intermittent loads, and 4 MVA standby loads. So applying the formula that we showed a while ago, so we will just calculate this based on this, and then we will get 6,200 kVA as the normal running load. Now sa peak load, sinama lang natin tong standby loads, right? Dun sa formula natin, which is 10%. So we get 6,600 kVA. Now, these are the normal future load that I'm talking about a while ago. So sa normal, we normally apply 20%. Or depende sa project specs nyo kasi may mga client din ang requirement nila is 25%. So you need to be sure with that. This is dynamic, hindi siya laging 20%. So you really need to know the client specs for you to apply this. So we'll be having 7,440 kVA after multiplying it by 1.2. And then 10% the peak load, it will be 7,260 kVA. Now, we need to select whichever is higher among the two ratings. So obviously, higher among these two is still this 7,440. So in this example, we'll be using 7.5 MVA or 8 MVA transformer. But take note that this transformer is the self-cooled rating. Now, of course, yung transformer self-cooled rating capacity should be equal or greater than 110% of the calculated peak load. No, meron ding specs na Ganun. In fact, it's very normal. So sabi niya, yung na-calculate niyo na 110% na peak load, it should be 10% higher yung transformer. So calculating that, 7.5 or MVA are both higher than higher by 10% dito sa 7269. So it's enough to use either of these two transformers. Of course, sabi ko nga kanina, no, yung pag-size ng transformer is dependent sa electrical configuration nyo. No, in this example is just a very basic calculation, which is we assume that this system is connected in radial, so it's a straightforward kind of calculation. Pero kung ang system nyo is secondary selective or a combination of primary and secondary selective, kino-combine yan, no? Lalo na sa oil and gas, ginagawa nila, kino-combine nila lahat yan. It will be a different thing, no, for you to calculate this transformer. So I leave that to you. As mentioned, technically you just need to use 40% of the transformer capacity in that case. So let's go for example case 2. We have the same amount of continuous, intermittent, and standby loads, no? But in this case, there's a motor load rated at, a standby motor load rated at 1,550 kilowatts or 1,813 kVA. Now, if there is a possibility to run this standby load during normal operation, the new maximum demand will now be 8,013 kVA. So it's no longer 744. It's no longer 7440 kVA. Now it's now 8,013 kVA. Kasi even though this is a standby motor loads, no, sa case kasi ng sa oil and gas, no, yung duty and standby, there's always the great possibility na nagsasabay siyang tumakbo kasi nga very strict yung requirement na hindi pwedeng mamatay yung motor. So ang gagawin nila, they will run it in parallel. So let it run, meet the RPM, and then check all the pressures, everything, and that will take 10-15 minutes before they close the other one. So even sa short circuit, no, that's something that we need to consider, those yung pag nagsabay yon. Kasi kapag halimbawa, alam nyo standby yung load, so ginawa nyo sa short circuit, hindi nyo sinama, yung pala almost all of them magsasabay-sabay. So you need to account that into your short circuit calculation as well, not just here in the load schedule. So in this particular example, our load demand now is 8,013 kVA. Sorry. So applying a 20% future load again, we'll be getting 9616 kVA now. So therefore, the new minimum transformer rating to be selected is 10 MVA. Still, this is the self-cooled rating. So loading ng transformer is, as mentioned, dependent sa configuration, kung radial, double-ended, etc. So we need to be aware of that. So for a 10 MVA self-cooled rating, we now can size the busbar rating ng switchgear, yung main switchgear nyo. No? Say the secondary voltage is for 160 volts, so we will get 1,387 ampere. So we can select 1,600 or 2,000 ampere busbar rating for switchgear. No? Of course, there's a note here. Kung ang transformer nyo, as mentioned, 10 MVA is the self-cooled rating. So if it has a fan-cooled rating, you need to size it based on the fan-cooled rating. So yung fan-cooled rating, for example, 10 MVA, and then yung fan-cooled rating niya is 10.25 MVA, you need to size it based on 10.25 MVA. We always use the peak load. That's why peak load is very important, which is the 15-minute maximum demand in sizing of the bus bars and the main circuit breaker ampere rating. So that's very important. Okay, so we have a load schedule data calculation here. This is from the actual project. So ito yung sinasabi ko kanina, no? For this example, pay attention to this number here. This is the motor nameplate rating, which is 45 kilowatt. Now, yung absorbed load or the brake horsepower is only 24.5 kilowatt. Okay, but this 24.5 kilowatt is the power output. So it means what I mentioned a while ago, we need to get the power input, which is obviously higher than motor brake horsepower. So getting the power input, it becomes 26.04. Okay, so we will end up using 26.04 instead in our continuous. These are the continuous, these are the intermittent, and these are the standby. Now, some engineers of mine argued last time, sir, bakit nilang gamitin natin 45? Safe na safe tayo. Yes, safe na safe tayo. And ang problema, yung client natin, baka yan na yung last project natin. Dahil ang mahal ng electrical system natin. We did something that is supposed to be not the correct procedure. So it is very, very important to identify this, at least for the oil and gas industry where the equipments are really expensive, no? So we need to adopt this kind of calculation. So these are the normal running load, which is represented by 433.8 kVA in this particular example. And we have peak running load, ito na EFG, which is 486.7 kVA. Of course, how to get this is the simple power triangle only. Okay. So proceed. Let's now go for the cable sizing calculation, which is very, very important as well. No. So for example, we have this parameters of the power cable: 200 horsepower motor, 3-phase, 460 volts, 90% power factor, 85% efficiency. Just example. So we get the power, the full load current. We will end up having 220.31. Again, this is motor power output. When sizing power cable, we need the power input, no? So we'll need to divide it by the efficiency. So we will be getting 244.79 ampere. So this will be our benchmark current, not this one. Okay, please be very careful with that. Okay. Another consideration that we need to ensure when sizing power cable is this voltage drop, no? As per PEC Article 2.10.2.2, maximum voltage drop from feeder to farthest outlet shall not exceed 5%. So we have 2%, 3%, recommended voltage drop to 2%, 3% sa main feeder. And then sa mga motor feeders, we have 5% during steady state, 15 to 20% during motor starting, 10% sa starting bus, which is directly supplying the motor. And then for motor reacceleration, ito yung mga motor na kapag nagkaroon ng voltage dip, they have the reacceleration relay, and they will start automatically as long as the time permits. So ang setting nito should be based on the contactor dropout value. So you need to know what is the contactor voltage dropout value, so you can set this accordingly. So sa lighting feeders naman, 4% to 5% sa branch circuit ng lighting, generally 2% in average, and then 4% maximum dun sa pinakamalayong ilaw from the supply. So these are the numbers that we normally adopt. Okay, so pag-calculate ng voltage drop formulas, I think we are all aware here. Anyway, I'll discuss it still. So it's just voltage sending minus voltage receiving over voltage sending, or the voltage regulation. Okay, so that is actually the estimated formula. Now we have the exact formula as per IEEE 141. No? So this is the exact formula. Because this ES, or the sending voltage, when you reflect it as a radii, hindi siya actually right triangle. Okay, so this is calculated based on this one. We add this and this one, and then we subtract it based on the power formula of this right triangle. So kumbaga, ang matitira dito is this. Ito, itong maliit na to, ito yung error. So if you want to, if you somehow need to use or need to know the exact voltage drop, this is the formula that needs to be adopted. Okay? Ang difference lang nung una, which is estimate, and this is this tiny thing here. Okay? So depende yan doon sa power factor. Yun doon nagbabase yung ano niyan, difference. Okay, then of course we need to know the cable short circuit withstanding capability. This is the formula for that as per IEEE 242 section 9421. So this formula is already converted from AWG to metric size. No? So this is actually to be applied for all medium voltage power cables and main feeder of low voltage power cable. So sa low voltage, yung main lang normally ang ginagamitan nito sa amin, so sa oil and gas. So this is very important for us to ensure na during short circuit, hindi magka-carbonize yung kable natin. Kaya niyang dalin yung short circuit magnitude that may happen in our electrical system. So the parameters for this is of course yung A, yung area ng conductor. We have the calculated short circuit represented by ISC. We have the T, short circuit duration time in seconds, which is this one. Kinukuha natin to depende dun sa protection coordination TCC natin. Doon natin kukunin yan. And we have the parameter TSC, 234.5 and 228 respectively for copper and aluminum. So ano tong 2SC? This is the temperature where the copper or the aluminum already inhibits zero resistance. Okay, so we have the initial maximum temperature at steady state. Normally, this is at 90 for XLPE, and we have the final temperature during short circuit, which is 250 sa XLPE. And if you are using a PVC cable, it's going to be 75 and 150% respectively. Okay, I'll probably speed up. No, the rating factors. These are the rating factors that we are using. So grouping, ambient depth laying, installation method, and soil resistivity. This is equivalent, no, sa this is base IEC 60502 or sa ISEA, sa ANSI standard. Okay, we have the ampacity here. You take note, no, bawat ampacity table merong base condition. So we need to know the base condition. We cannot just straight away select the ampacity on what is shown in the ampacity table. Meron yan laging base condition, so we need to know that. So these are the table para sa correction factor. This is for directly buried cables. And kung gaano rin siyang kalalim, no, nandito lahat siya. And then we have the soil resistivity, soil thermal resistivity. Nakukuha natin to sa geotechnical report. We need to know that value. So we have that here. And we also have the paano tumatakbo yung kable, paano yung separation niya. Are they touching? Are they 200 mm separated, 400 mm separated, and so on and so forth. So we need to use that. So we have a quick example here. These are the conditions. We have a very simple circuit here. So I just use hand to do this. No, mas mabilis isulat. So we have blah blah blah. We have 140.75 current. So based on that table a while ago, we can choose 35, which is 153 ampere. Pasok. However, 92% loaded na siya. So di ba, ang rule of thumb natin at least 80% loaded. So ayoko siyang gamitin. I'll go for the next one, 50 mm square. So safe na ako, 77.76% loaded. Okay, good. Now we proceed now to validate it against the short circuit capability. As per the information that the formula that I showed a while ago, we directly apply those values. Now we assume this only. Wala na tayong time pakita kung paano ito lumabas. So we assume 30 kA and 5 cycles. So we substitute that eventually, we will get 59.71 mm squared. So this just validates that 50 mm squared, which we choose a while ago dito, is not able to withstand 30 kA in an event of fault. So we cannot choose 50 mm squared. Magka-carbonize yan. So we use 70 mm squared minimum, which is 221 ampere for directly buried cable. Okay, and so we'll validate this 70 mm squared against the rating factor. So we have the rating factors here. You can just look it up. So the total derating factor is just the product of all these derating factors. Lahat to derived from the table that I showed a while ago, which is 0.85. So 221 times 0.85, effective ampacity na lang yung cable na yun is 187.85. So still, it's higher than 140.75. So it's passed. when it comes to the rating. Be careful, sa ibang industry, yung required nila is umaabot ng 40%. So it means kung yung ampacity ng kable nyo is 100 ampere, technically ang ampacity na lang nun is only 40 ampere. So we need to be aware of those of this derating, no? Especially dun sa top 3 oil and gas company natin dito sa Pilipinas. Okay, so we now validate it based on voltage drop. So substituting the formula that we showed a while ago, we'll be having 0.39%. So ang ganda nung ano niya, no? Ang ganda nung voltage drop niya, pasado. Hindi lang itong voltage drop na to is for steady state only. Now, we need to also validate the voltage drop during motor starting. Okay? So it's slightly a different formula, not same as this. I did not show it anymore here kasi medyo mahaba, but I got 15.4%. Now, if your project allows 20% specs in your specs, this is pasado kasi 15.4. Now, if your project is saying 15%, I leave it to your discretion whether you will allow this kasi sumobra siya ng 0.4 or you want to increase again the 70 mm square into the next size kasi medyo babagsak siya during motor starting. You need to evaluate this kasi halimbawa yung motor nyo matagal mag-start, say 10 seconds, 5 seconds, 15 seconds, I don't know. Depende sa capacity niya. You may in your discretion, you may want to increase this to 95 mm square. Okay, so I leave that to you. So again, let's go to the transformer quickly. So it's an electrical equipment to transfer voltage level into another voltage level. We all know that. So there's some types. I'll just discuss the most commonly used, which is dry type, cast resin encapsulated. We also have the oil immersed type, no, which is subdivided into two, seal type and conservator type. Seal type, ginagamit siya normally below 5 MBA. Yung conservator type naman is above 5 MBA. But of course, always refer to your project specification. We need to also to know the vector group. So in this particular example, we have DYN1. So delta represents the high voltage and it's a capital letter. And Y represents the Y side. Kung small letter yan, it means that's the low voltage side. N, susunod dyan, kung yung Y nyo is capital, N should be capital. Kung yung Y nyo small, it should also be small. And 1 represents 1 o'clock notation, which is 30 degrees. So in this particular example, since positive sequence is always counterclockwise in nature, so high voltage leads the low voltage by 30 degrees. Okay, so we need to know also the top changer of the transformers. There's a NLTC, of course, babago lang yung position nito when the transformer is de-energized. And we have the automatic one, which is the on-load top changer without the need to shut down the transformer itself. So it will the position will change automatically depende sa load demand. We also need to know the cooling rating ng transformer natin. Of course, yung pinaka self-cooled niya is yung ONAN rating as we discussed a while ago. And we have the oil natural air force rating. Marami pa yan. I just keep it to these two for now. Okay, and then we have the transformer system grounding. Normally, we're using NGR, NER, and it's subdivided into two. One is low resistance grounding and another one is high resistance grounding. So low resistance normally ginagamit siya sa MB system from 100 to 1,200 ampere at 10 seconds. Yung high resistance naman ginagamit siya sa low voltage with this current rating 5 amp to 10 amp 10 seconds. So we also have solidly grounding. Normally sa low voltage and high voltage siya ginagamit. Ang problem dito, the line to ground fault, as you may know, will be high. We also have the reactor grounding, no, normally used for MB. This kind of grounding actually is used when there's a desire to limit the ground fault relatively close to the magnitude of the three-phase fault. So sa mga oil and gas industry ginagamit yan. And also we have the ungrounded, no, as we all know, delta winding, of course without intentional corner grounding, and the open Y system. Okay, this is the comparison chart for that. I will not really discuss on this. So anyway, ibibigay ko naman tong presentation na to. All right. Tayo gumalaw. Sorry hang on. Ayun. Okay, so now we discuss about switchgear. It's an equipment that includes the combination of ACB, BCB, etc. And we have the, or we're going to use motor control center. Normally, we're using a lot of motor control center because of the property ng planta, which is mostly, as mentioned, mostly motors. So we have two types that we need also to indicate in our data sheet when buying it to the vendor. We need to know to mention if it's metal clad or metal enclosed. So basahin nyo na lang to. So there's a few significant items that needs to be known here. We also have the comparison kung ano ba yung metal enclosed and ano ba yung metal clad, no? As per ANSI standard. Okay, I leave that to you later. And of course, we need to know whether what we are using, AIS, GIS, or hybrid. So I underlined here yung mga advantages and disadvantages, no? So if you have the money, let's go for GIS. If hindi naman ganun ka-reliable ang gusto nyo, you can always go for AIS. And technically, yung hybrid is a combination of both. And in terms of cost also, it will be in the middle of the two. So that we need to know as well. And of course, we also need to represent or to indicate the NEMA rating ng equipment natin, which is shown on this table. This is the NEMA rating here with the equivalent IP rating here, no? So for example, NEMA 4X is equivalent to IP56. So ang ibig lang sabihin niyan, yung first numeral indicates the protection and the second numeral sa liquid naman. Okay, so it means kung IP65 ka, you are dust tight and water jet with water jet protection. Okay, we also need to indicate the diesel engine generator, which is basically to supply the UPS system for the distributed control system or the SCADA, and for the instrument local controls and the emergency shutdown system. For the telecom system, PAGA, telephone, blah, blah, blah. Security system, battery charger ng DC-UPS for switchgear control and protection, fire water pump system at saka yung fire protection system natin, emergency lighting at saka aircraft warning light. Hindi pwedeng mawalan ng supply itong mga to. Okay, let's go now to power system analysis. I think I still have like 10 minutes. I'll try to compress this in 10 minutes. Power system analysis is an essential part of electrical system design, as you may know, no? Calculations need to be performed to verify that the electrical system, including system components, devices, and equipment, are correctly specified and rated. So basically, bago tayo bumili o mag-purchase ng any electrical equipment and devices, power system analysis needs to be done first. Otherwise, we will end up like, oh, 50 kA yung nabili ko, 65 kA pala yung kailangan ko. You got to know it a bit late because sometimes marami akong na-experience, yung power system ginagawa sa late part, which is basically wrong. It should be done as early as the feed stage or during the front-end engineering phase ng project. So, ano-ano itong mga power system analysis na to? Let's discuss this in a nutshell only, no? Kasi very broad itong mga items na to. Of course, load flow analysis, short circuit analysis, motor starting analysis, protected device settings and coordination, grounding grid system analysis, temperature rise analysis, harmonic analysis, transient stability analysis. Now, let's try to discuss this in a nutshell. So, the purpose and objective of load flow is to determine the voltage profile sa mga buses, to determine the voltage drop on each main feeder and sub-feeder, to determine the power flow and power losses. We need to know that as indicated in this picture here, no? We also need to know and validate that the electrical equipment that we selected are within the rated capacities. So this will basically validate na yung equipment sizing natin is correct. Okay, we also need to determine and validate that the selected power cable sizes are correct and adequate. We also need to determine the system power factor at the electrical system point of common coupling, as well as to verify kung ano bang top changer position ang kailangan natin para dun sa mga transformer na naka-NLTC lang. Okay, load flow analysis calculation basis and criteria to must be simulated in 3 scenarios as a minimum. What are those minimum loading, normal loading, and maximum loading? Doon sa mga nakikita ko na normally ginagamit lang nila normal loading. So we need to, because loads in an electrical system is very dynamic. May time na mababa ang loading, may time na mataas, may time na normal. So we need to simulate it at these three conditions to ensure that your electrical system is healthy. No? So minimum utility short circuit data shall be used. Normally kasi pag humihingi tayo ng data sa utility, dalawa kasi dapat yung binibigay nila. Isang minimum at saka isang maximum. Okay, so when doing load flow, dapat ang gagamitin natin diyan yung minimum to yield a more conservative result. And then yung maximum ginagamit yan sa short circuit analysis. So normally under voltage at 95 and over voltage at 105%, target power factor at the point of common coupling is always at 85% minimum as per the Philippine Distribution Code. Okay, now let's go to short circuit analysis. Probably yung short circuit is the most important of all the system analysis para sa akin. So its main purpose and objective are to determine the three-phase symmetrical, asymmetrical short circuit current, RMS peak, to determine the unsymmetrical short circuit current, which is line to ground, double line to ground, and to determine also the short time short circuit withstand, or what we call bus bracing of the switchgear switchboard, to ensure mechanical and thermal capability ng mga buses na to or mga equipment na to. We also need to determine the making, breaking, or the withstanding, interrupting rating of the protected device. By the way, yung making, breaking, ginagamit to sa IEC. At yung withstanding, interrupting, ginagamit yan sa ANSI. So don't mix the two. It depends on your project rating. Project standard. Item E is to determine the closing and latching capability ng ating mga medium voltage circuit breaker. Normally, kinukuha natin yan sa half cycle asymmetrical value. Letter F is to specify the correct short circuit rating of the equipment, of course. Then other important usage of SCA or short circuit analysis is to validate the short circuit withstanding capability of a power cable, kagaya nung pinakita natin kanina. We also use this to design the grounding grid system. So we also use this for the protective device setting and coordination. We need the minimum and the maximum. We also need this to determine the arcing current for the arc flash analysis. We also need this for the temperature rise analysis. We also need it for the harmonic analysis for us to determine the short circuit ratio. We also need it for the transient stability analysis. So kung titingnan nyo, napakaraming gamit ng short circuit analysis. So kapag dito, mali yung nakuha mo, lahat to mali na rin. That's why in my own opinion, short circuit analysis is the most important analysis of all the analysis. Of course, they are all important, but to me, SCA is much more important. So important notes for the SCA, short circuit consideration should be addressed already during feed stage. Ito yung sinasabi ko. Kailangan ginagawa na to as early as feed stage. Yung feed is front-end engineering design stage. As mentioned, we need to use the maximum utility short circuit. Sa first cycle, ginagamit natin to determine the short circuit rating ng LVCB natin at saka sa mga switch fuse combination. Yung asymmetrical value naman na ginagamit natin for the rating ng MV switch fuse combination at saka yung closing and latching rating ng ating MV power circuit breakers. Sa 1.5 to 4 cycles naman, we use it in interrupting rating ng ating medium voltage power circuit breaker. In 30 cycle, we use it for the protection coordination to determine the time delay settings and coordination. So medyo marami siyang gamit. So as you may all know, sources ng short circuit are utilities, generators, synchronous motors, and induction motors. Now, kung I just would like to highlight na kapag yung induction motor nyo is equipped with the BFD, normally short circuit will not pass through. But you need to confirm if your BFD is the regenerative type. If it's regenerative type, then short circuit will pass through. So I will not really discuss on that. It's just an information. So international standard, normally what we use for short circuit, again, ANSI and IEC. It doesn't stop there. Marami yan. At least sa na-experience ko, may 6 na kaming ginamitan nito. Different standard, Australian, Russian, and so on. But I'll just limit it to these two for now. So basically, method of calculation, we have 3 methods: MBA method, ohmic method, and per unit method. Each one has an advantage, but I would prefer per unit method to be the preferred method. So motor starting, to analyze if the motor can successfully start, bilisan ko lang konti during different electrical configuration, we need to do this to confirm that the available bus voltage before, during, and after motor starting is still within the allowable voltage variation limit. And to analyze the overall effect of the entire electrical system during motor starting in the most severe configuration. This is very, very important. May mga cases kasi pagka hindi na-consider to, tapos i-start nyo yung motor, namamatay yung mga ibang tumatakbo ng motor. So this is very, very important. So it's also used to decide on the best starting method to be adopted. Of course, as a start, we use direct online. But if talagang hindi kaya, then we need to adopt a different starting method. And also used to confirm the cable sizing and transformer rating. Kasi we need to validate that during motor starting, voltage drop is still within the limit, allowed limit. So recommended voltage profile during motor starting is 80 to 85% at the motor terminal, 85% is the motor starting bus where the feeder is directly connected, and 90% on all the other buses. This is during motor starting. Kailan natin malalaman kung dapat tayo mag-motor starting analysis? It's summarized in these 5 items here. So if the transformer cooled kVA rating is less than 3 times the largest motor kVA rating, so it's time to do motor starting. If the ratio of the bus short circuit kVA to motor starting kVA is less than 8 times, it is time to do motor starting. If there is a strict voltage drop restriction imposed by utility, so we also need to do that. If there is a presence of high load inertia, and if the machine torque is low, so we need to do that. Okay, otherwise we will not know if the motor can be successfully started. So let's go na for protection coordination. Quick one, dalawa lang naman yung objective niya. If any type of fault occurs, the protected device closest to the fault should operate as quickly as possible to isolate the fault and leave the healthy part of the electrical system to continue operating. If the protected device closest to the fault fails, halimbawa hindi gumana, then the next closest device should operate as quickly as possible while still maintaining selective coordination. This is the reason why we do protection coordination. So protective relaying packs, no protection of power system can prevent the flow of fault current into the electrical system. No matter how good the design, no matter how expensive is your equipment, hindi natin maiiwasan to. It is a phenomena basically. So instead of protective relaying, protective relaying can only prevent the continuous flow of fault current by quickly disconnecting the short circuit path to the faulted bus. Okay, we have the coordination time interval here as indicated or gathered from IEEE 242. You just read this. Highlight ko lang to, no? When protecting a transformer with the delta Y winding, additional 16% current margin over margin should be used between the primary and secondary protection. Nandun yan sa IEEE 242 Article 1522. So the reason is when there's a line-to-line fault at the secondary of a Y part ng transformer nyo, ang binabasa niyan sa taas is 100% three-phase fault. So we need to be, there's a sample calculation here. Due to time limitation, I'm not going to discuss this maybe. Okay, but basically, pinakita ko lang dito na in-apply ko yung 16% margin. Okay, for me to protect this system here. So in-apply natin siya to ensure that that 16% margin is applied. So basically, ito yun. No? Square root of 3 over 2 kasi yung line to line, so 0.86. So 1 unit over 0.86, where 1 unit represents 3-phase fault, is 116%. So you need to have a 116% protection sa primary ng transformer natin in a delta Y winding anyway. So ito na, no, mga too bad I cannot discuss this in detail. So anyway, this is the result of that. You can see that it's properly coordinated. This is the thermal limit of the transformer. This is the inrush current, so the coordination is perfect. Now, this is the table from PEC. This is the recommended overcurrent setting. We have basically two table above 600 volts. So ito yon, no? Basahin nyo lang doon. Anyway, this is maximum, maximum. Okay, and then we have the 600 volts or less, which is represented by these numbers here. So basahin nyo na lang yan. So quickly, arc plus analysis should be performed in association with or as continuation of short circuit analysis and the protective device coordination study. Note, arc plus incident can result in severe injury or even death. No? So primary purpose niya, of course, determine arcing current, incident energy, arc plus boundary, PPE level, etc. So arc plus mitigation, of course, number one is to maintain your equipment as recommended by the vendor, no? Dapat di namimiss yan. Limit the short circuit current. This is quite tricky, so needs for careful evaluation. So properly engineer the protective device setting and coordination. That's why it should be done correctly. We adopt a maintenance switch. So maintenance switch is something like this. I'm not able to discuss this now. So adopt the remote tracking operation, something like this. I experienced this when I was working in Canada. So we normally do that. Walang lumalapit dyan. Use arc resistant switch gear, of course, and wear the appropriate PPE level. And of course, number 8, the mostly best mitigation is to shut down the equipment. Kung kaya, if the facility can afford it. Okay, and we go now quickly to ground grid system analysis. So ano ba yung function nito is to determine the required grounding grid or grounding mesh system design sa substation at saka sa mga transformer yard, no? So to determine what is the minimum size of conductor required for the main grounding grid, including gaano siya dapat kalalim. Determine also the number of X and Y conductors that are required for the grounding grid and the grounding mesh. Ensure that the calculated touch and step potentials are not exceeded and are within the tolerable limit. Also ensuring that the ground potential rise during fault is not exceeded and is still in the tolerable limit. Ensure that the ground resistance is within tolerable limit also, and determine the number of copper rods that needs to be used and how deep it must be bored into the ground. So ito yung example nito is yung grounding grid analysis using finite element method. Meron din ng ano niyan, yung ibang software. So the primary purpose naman ng temperature rise analysis is to ensure that the operating temperature of power cable are not exceeding 90 degrees Celsius during normal operation in the worst loading condition. It is also used to validate the required spacing requirement in trench or separation in duct bank between power cable. So hindi lang tayo basta latag ng latag. We need to validate this temperature rise. So it's also used to determine the actual required power cable sizes. No, it's also used to analyze the effect of external heat source near the cable. No, for example, near the trench or near the duct bank. Sa mga oil and gas, marami yan. Alam mo, yung mga steam pipe, no, sa baba, sa ground din sila tumatakbo. So kapag tinabihan nun ng trench, good luck. So this is very, very important analysis as well. And we also have transient stability analysis. This is used to determine the electrical stability and dynamic performance response of the electrical system in an event of any system disturbance, such as load acceptance, may biglang pumasok na malaking load, load rejection, may biglang nawalang load, loss of generator, nag-islanding yung system, or when starting large motors. This is also used to identify the limitations in motor starting, also used for the identify the electrical configuration that will lead to instability or collapse of an electrical system. So very, very important tong transient stability analysis na ginagawa natin. So primary purpose naman ng harmonic analysis, I think this is the last one, to determine and identify the sources of power system harmonics, which we all know as the linear loads. Ensure that harmonic levels, voltage and current are within the acceptable limit as per IEEE 519 and IEC 61000. So to ensure resonant condition does not exist in the electrical system, and to apply mitigation to ensure that harmonic levels are within acceptable limit. So these are the reference table as per IEEE 519, voltage limits and current limit dito up to 69 kV, ito up to 69 kV and above. Pakita ko lang yung effects ng harmonics, no. Ito yung nag-load flow. This is the same system basically, nag-load flow. We're getting 106.9 amperes primary ng transformer and 926.9 sa secondary. This is supplying a DC system which we know are all non-linear load. Now when we did harmonic analysis, just take note of the increase in current. From 106 naging 110 sa primary, 110.4, and from 926 naging 957. This is the effect of harmonics in our electrical system. No? That's why harmonic analysis is very, very important, as shown on the above figure. One cause of that is your power cable to be more hot and maybe overloaded. So okay, so detailed technical presentation will be conducted in IIE Metro North chapter soon to discuss each of these items in a more detailed manner. So I think that's the end of my presentation, and thank you very much for listening.
That concludes the presentation of Engineer Archie Balmes regarding the questions. Sir Archie will still be here with us at the Zoom to answer to your questions. And at this moment, to award our certificate of appreciation, the host chapter president, Engineer Giovanni F. Tagata. Allow me to read the citation, please. Certificate of appreciation is awarded to Archie F. Balmes in grateful acknowledgement and of his invaluable service and professional thoughts shared as a research speaker on the topic about fundamentals of power system design during the IIEE 7th Metro Manila Regional Conference, a hybrid event with the theme Got One IIE at 46, transcending the challenges in the new normal by embracing resiliency and complementarity, given the 7th day of August 2021, signed by Engineer John Registrosio, Vice President External for Metro West Chapter, Engineer Giovanni F. Tagatak, the President of Metro West Chapter, Engineer Manuel M. De Guzman, Secretary General Metro Manila Region, and Engineer Alwin M. Wagan, Governor Metro Manila Region. Thank you very much, Sir Archie. Okay, so for our next speaker,
Our next speaker is an electronics engineer by profession. He earned his degree at University of San Jose Recoleto, Cebu City. He worked as sales engineer at Jebsen and Jessen Incorporated in 1994 to 2004. He previously worked as senior sales engineer at JJ Lab Cable Philippines from 2004 to 2008 and became the sales manager in 2008 to 2017. He is currently the sales manager of the Electrical Markets Division of 3M Philippines. Together with him, allow me to read the citation. She worked in the wire and cable industry for 3 years, registered electrical engineer and technical engineer of Switch Industrial and Sales Corporation. Our two speakers for today is Engineer Marlo G. Castor and Engineer Don Repollo.
Good morning to all.
Hey, good morning.
Hi. Don?
Sir Marlo, sige po, mauna po ako sa Greta.
Okay. Thanks,
okay, sure. So hi everyone, is my screen already visible?
Yes, ma'am.
Okay. So, good morning, everyone. In behalf of Switch Industrial, we are very thankful for this opportunity to sponsor this event with our principal sponsor, 3M. Sir Marlu, in a while, we'll be discussing his technical presentation. So, our company is Switch Industrial Sales Corporation. We are an authorized partner of 3M for how many years na already? So, ayan po yung company namin. And of course, our team, Switch Industrial team, is composed of electrical engineers who have decades of experience in total sa wire and cable industry. So, ayan po yung specialty talaga namin. It's the wire and cables and of course, ang mga items na ina-offer ni 3M. So about us, about Switch Industrial, we are located in Manila, in the heart of Manila. So if ever you are looking for a specific type of product or you have problems with wires and cables, need of consultation, so ayun po, we offer free technical support, and if ever there are items that you might need, ayan po, you can just freely visit us and see the items in our office. So for 3M, we handle 6 divisions, which are mainly electrical, abrasives, personal safety, tapes and adhesives, traffic safety, and cleaning materials. So anything industrial and electrical related sa 3M, we are authorized to supply. So this is actually Sir Marlo's topic, and he will be discussing this in a few minutes. Ayun po, yung parts of the cable, the skills needed to complete this termination process, and of course, ayun, how a power cable termination should look like. So ayun po, I'm also excited to learn from Sir Marlo in a while. So for the electrical na sector that we offer, ito po yung very popular na items, which are the lugs and connectors. So if you are looking or if you are dealing with standard barrels, long barrels, mga terminal lugs, and if you are connecting wires of 2 different materials like aluminum and copper, mga dual rated na materials and sizes, ayun po, you can also get in touch with us. After this presentation, I will be sending a downloadable Google Drive link so you can download and view our PDF for the technical catalogs. Dun po makikita niyo po yung specifications and applications of the items that Sir Marlo will be talking about. So you can browse this catalog as we go through the presentation. For electrical tapes, ito po yung very popular tapes in the market. I'm sure everyone knows about the Super 30T Plus, the very professional grade na tape for the electrical engineers. We've also had the rubber splicing tape and the Temflex na tape. So these are all readily available with Switch Industrial. So if ever you have emergency na scenario na in need of cable repairs, ayun, we have also the special application tapes. So if ever you have a wire na emergency and in need of repair and you want to ask our team what specific wire or should you use, ayun po, we also do consultations for free. So you are always welcome and we are always readily available for calls. For our safety sector, ayun po, we have protection gears from head to ankle. So from hard hat, earmuffs, respirators, disposable masks, mga reflective vests, ayan pa, for your safety. For abrasives, ayun, if their company is dealing with the manufacturing and the maintenance, ayun, these are the items you will mostly see in your department. So mga grinding discs, sanding discs, and etc. So ayun po, these items are also reflected in the catalog. And for tapes and adhesives, these are the most popular din na items, yung safety marks, VHB tapes. These VHB tapes, some industries are using these to replace screws and welds. So, and we also have the anti-slip resistant tapes. And for commercial solutions, ayan po, sa facilities, cleaning materials, and the mats. Ayan. Switch Industrial and 3M also offers these kinds of products. So, masyadong malaki po yung range ni 3M, and Sir Marlo will also be explaining how big 3M is as a company in a while. So, I'm just doing a quick presentation in behalf of Switch Industrial. So, Switch Industrial is also offering other items or other brands that correlate with 3M. For example, for Balmoral Engineering, we offer the ground mats, and we also offer high voltage gloves from Polyco Healthline. And since medium voltage and termination is the topic, ayun, makikita natin na there is really a need for a good cable preparation. So, good cable preparation means that we need to have good quality cable strippers and procedures to ensure na maganda po yung ating termination. So, ayun, these are other brands that we are partnered with like Locknight, QP, Phelps Lodge, DeWalt, ayan po, Balmoral Engineering, Giant Lock. So, ayun, you can just tap Switch Industrial if ever there are items that you are finding it hard to procure. So, maybe we can offer something. And here, ito po yung ano namin, mga representatives. These are usually the persons you get in touch with. So Sir Kevin Carlos is our technical services manager. So he was supposed to be the one presenting here. Pero ayun, napaka-busy ni Sir Kevin. There are emergency situations lang. So ayun, for very technical questions, ayan, yan po yung number niya, Sir 9667-615-100. You can call him anytime. So ayan po. Miss Vilma Wee, who is, I think most of you know Miss V since she's the one who's been attending the exhibits. Ayan po, siya po yung namu-meet niyo lagi if you've already met Switch Industrial. So ayan po si Madam V namin. Soon, siguro in the future and also in the IIENC, ayan, makikita niyo po kami and also Ma'am V. And here I am. Ayan po yung picture ko. And I'm actually assigned in Visayas and Mindanao. So that's my area. But you can just reach me anytime lang din po. I'm also always available to answer any of your inquiries. So, ayan po, you can reach us faster through our Facebook page. Everyone these days is doing Facebook. So, kung may naalala kayo or just a question you want to ask, ayun, we are just a quick chat away. And this is what we offer as part of our programs in relation with 3M Philippines. Ayun, if your company is in need of your own webinar, so ayun, we can arrange that. Just email and reach Sir Marlo or me to request a free webinar of kung gusto niyo yung more in-depth yung discussion of the medium voltage. Ito kasi yung presentation namin, we could just take an hour. So kung gusto niyo more comprehensive type of discussions, so we are also doing this. So that's it on my end. So I'm not going to take too much of Sir Marlo's time. Thank you.
Okay, Don. Thank you very much. Don?
Yes, Sir Marlo. I'm handing the floor to you na po. Thank you.
Okay, so just assist me down along the line, ha? Magandang umaga po sa lahat na attendees natin, 484 yung sa participants natin. Anyway, we will just make this a very quick one kasi yung next natin na speaker is one of my favorite speaker. I think si Sir Jules yun. And then correlated naman lahat na topic natin ngayon. Since yesterday, ang ganda ng topic natin. So we will talk about the medium voltage splicing and terminations. Okay? So, nakikita na yung slides ko, Don? Hi, Don? Don?
Wala pa, sir.
Okay, sandali lang, ha? Share ko siya. This one is share the screen. And share the screen. Ayan, kikita na ba?
Yes, sir. We can see your screen, sir.
So thank you TMC and Monique, paki-assist na lang ako kasi I try to share the screen rather than the presentations kasi I found out that this is a better way of sharing the presentations. Medyo mas mabilis siya kaysa doon sa presentation na i-share mo, no? So the topic is about the medium voltage cable splicings and terminations. The agenda for today is all about basic power cable. So kanina medyo in-depth yung kay Sir Archie, no? And then the next is splicings and terminations. Sa splicing, konti lang din ang papasadahan natin. We will dwell more on the terminations. This termination subject matter will be more exciting doon sa mga registered master electrician natin diyan na gustong mag-sideline. Okay? Watching it for me. Bibigyan ko kayo niyan mamaya. Okay? That is on terminations. The objective normally when we share this knowledge is for us to know, of course, to learn, and for those participants, sana ma-share ninyo ito sa mga PEE natin, RME, and or the RE. The objective is only to share. So we're not here to contest or magpapagalingan tayo. Sharing is the bottom line of here, no? So 3M, sino ba si 3M? 3M is a century-old company starting in Minnesota, mining manufacturing corporations. Sa Pilipinas, ang first office namin is Manila Hotel. So can you imagine yourself, opisina mo sa Manila Hotel? That was 5 decades ago. Currently, nasa kami sa TFC, no, the Finance Center sa BGC, malapit yan sa SM Aura. So nasa 10th at saka 11th floor kami. So the 3M Philippines is being headed by our Mark Anthony Ang. Siya po yung leader namin. Napapansin niyo, wala na manager sa mga multinational ngayon. No? Tinatanggal na. Bakit kaya? So leadership na ngayon ang nire-recognize. So I'm reporting to him. But then if you go internationally, ayan, familiar sa inyo yan, si Glenn. Glenn, magandang umaga. Sabi niya kasi participant lang daw siya ngayon. Glenn used to deliver this subject matter, fortunately or unfortunately man para sa atin, Glenn is now taking the bigger role sa buong Asia. Okay? So, kaya naubos ang panahon niya. But pusong Pinoy pa rin yan. For those who would like to contact us, lalo na sa 3M, please take note of our email and addresses. And viewing us today is also my colleague from Indonesia, si Ampre kung tawagin. And then nandyan din si Nubem, si Katrina, and so on and so forth. So marami ngayon taga 3M nanonood internationally. So yung program natin, when nasa birth pain pa yung Metro Manila chapters, the challenge of that is doing the activity and the fund itself. So 3M is one of the supporters of the IAEE. No? So ang culmination nito, yung si Rod pa yung leadership noon, nagkaroon kami ng Olympic bago mag-MMR that time. So, pa-contest namin, yung sa left side yung winner natin sa medium voltage, splicings, and terminations. Yan. And then, of course, since wala pa naman tayong fund during that time, yung 15,000, don't worry, kinuha yan na sa sariling bulsa ng mga officers natin. Ambag-ambag, dukot nga sila ng bulsa. So that is the success of the fund during the birth pain of the chapter. Bakit ko pala nga pa hina-highlight mga ganoon? Dahil in every successful event or chapters, conferences, there are people behind the scene working 24/7, 7 days a week. No? Libre po yung trabaho nila. Those are the officers. No? Kagaya ngayon, in the leadership ni Gov Alvin, and then nasa national kay Sir Alan naman. Of course, nandun yung mga backbone natin, yung mga BEE natin, nandun po sila. So for the people who are paying, no, yung mga participants, sabi, mahal naman ng registrations. So behind the scene, ang dami pong ginagawa niyan. So huwag kayong mag-alala doon sa mga registration fee ninyo. Ang mura po niyan. Kasi yung course po ng, for example, this course, no, kung i-avail ninyo to sa ibang institution, it will cost you around 30,000. Yan. Dito, libre lang yan. Parang libre na rin. Oh. So that was me, and this was the early birth ng natin, ng chapters natin. No? Halo-halo na dyan. Medyo bata pa tayo dyan lahat. So that is the conference room of the 3M. For those who are in chapter having sana, kung wala na tayo sa new normal natin, pwede tayo mag face-to-face, you can share the conference room of 3M located at BGC. We can handle around 100 personnel. Yan, seating capacity yan. Si Alvin nasa gitna ka pala dyan, no, katabi ni Glenmar. Okay? So, let's go to the topic. Ano ba yung accountability ng isang electrical practitioner that transcend for all those people who are working on the electrical industry, no? From the people blue collar hanggang sa may white collar dyan. So ano yung responsibility natin? So from generations, transmissions, and then bababa sa DU o distribution utilities, meron tayong dalawa, normally the private sectors and the cooperative. From them, ibibigay natin sa customers. Sino ba yung mga customers natin? Ito yung mga residential, commercial, and then ang pinakamabigat, yung taga-industrial. So napapansin mo kahapon, the talk by the presenter, si Sir Lad, si Juan, and so on, makikita mo as you go to the ladder of your Juan, no, sa tuktok nga, kasi nga ang ladder papunta sa taas, but then pagdating mo doon, mapapansin mo ang nagiging sentro. Ang sentro ng ating practice is now the customer's need. You have to discover and you have to deliver that needs, no? So, example, paano na lang pag hindi tayo nakadeliver ng kuryente doon sa customer mo? Okay? So, new normal. Ang frontliner natin is the medical people, nurses and doctors, but behind the scene, okay? Merong practitioner 24/7, 7 days a week, tuloy-tuloy nagbibigay ng energy sa kanila. So may imagine ba nila na pupunta ka ng hospital tapos brand out, no? So yung instead na may defibrillator ka, 300 joules, hindi na magbibigay sa iyo yon. So can they imagine that one? So in the spirit of gratitude, sana mag-type kayo ng thanks, no? Pasalamat naman kayo sa mga colleagues natin, lalo na yung malapit sa puso nyo. Libre lang po yun sa chat box. Say thank you to our colleagues. Okay? So this is the BGC and then the underground system. It is increasing. For the management type of people behind the scene, ito yung pinaka-concern. The repair cost is maliit lang po yon, 100,000, 500,000, maliit lang ba? But the consequential cost, tandaan niyo yan. Death, injuries, property damage, ang laki ng portions icebergs. Ang laki ng impact po niyan. At lalo na yung nasa baba, no? Na itong nasa baba. Okay? Change ko lang yung pointer ko ha into laser para makikita natin. Yan, itong legal cost. Okay? Ito, familiar si Sir Alwin nito. Pag nag-failure ang isang system, lalo na sa submersible, no? Na kuryente ang kliyente, pwede ba siyang magsampa ng kaso sa iyo? Yan. Huwag nating antayin yan. Ano? Pag mangyari, take note, lisensyado ka, ikaw ang nag-sign and seal, responsibility mo po yon, yung system natin. So, ang laki pala ng impact ng consequential cost. For this reason, yung chain natin, kanina, from generation down to the end users natin, miles of media, o tawagin natin, medium of transmissions, power cable. At the weakest link niyaan is the splice and terminations. So kung mananalo ka ng bike, mamaya mananalo ka ng bike. So imagine mo, yung bike na yan, putol ang kadena. Ha? Ang laki ng impact. So terminations and splices, ang laki ng impact niyan sa systems natin. Okay? So today we are going to share to you, all about the science behind the terminations and the splicing. Hopefully we can end in 10 o'clock. Yan, 10 o'clock. I-end natin to. So, cable theory. Tatlong topic yan. Cable, splice, and termination. So, let us review kung ano yung power cable natin. Bibigyan ka ng tao mo, Sir, ano to siya? Medium voltage o low voltage? Power cable yan. So, paano natin ma-determine if we don't know the basic component of that power cable? Time immemorial, itong basic natin, hindi yan nagbabago. Okay? Parang ohms law lang natin yan, no? B is equal to I times R. Hindi nagbabago. Nagiging komplikado pa lang siya. Okay? So ano yon? Ito yung 5. Conductors, strand shield, insulation, and then the insulation shield. The insulation shield may dalawa tayong component, the semiconductor, metallic, at ang panglima is jacket. Yan, during the exam, kudigo ko na to. So time immemorial, yung basic na yan, yung first 5 natin, tandaan nyo lang po. Okay? So habang natatandaan natin, we can address that one by one. Bakit natin ina-address yan? Because meron siyang main function. Bawat isa dyan, meron siyang main job, main function. Ano yan? When you talk about the conductor, we are talking about current. Kanina si Sir Archie, no? Sir Archie, si Ding at saka si Ging, Turalba, regards daw from Canada. Current ang pag-usapan natin. Kung mataba ang conductor natin, then malaki ang ampacity natin. Paano nang pumasok ang aluminum? No, according to the computations delivered by our sponsor also, dodoblehan natin. No? Kumbaga, mas malaki yung aluminum to satisfy the ampacity of the copper. So matotal, straightforward, pag nagdudugtog ka ng copper at aluminum, patabain mong aluminum. Kung gaano kataba, let's go to the table of computations. Okay? So hindi natin kaya this time. The next component, ang main function, Faraday's cage. Nako, ito, ano ba yung Faraday's cage na yan? Ganito kasi yan, okay? Yung conductor mo, and then itong dilaw is, we assume this is an insulative material or insulation. In between sa kanila, meron tayong air gap o void kung tawagin natin. Pag nag-energize ka dyan, mabibreakdown mong air, no? So if you're going to recall the breakdown point of or the dielectric strength of air, no? Kaya na natin basagin yan at 2.7 kV. Ganun pala, at 2.7 pa lang is sinusunog na natin yung air, we call it ionization. How much more kung 5 kV, 5,000 volts ang in-inject mo dyan? Di sabog na sabog. No? Partial discharge, corona effect, and then favorite keyword namin ni Glenn, Merry Christmas. Bakit? Puputok na yan, kuya. So in order to address, okay, to solve the phenomenon, si Mr. Faraday, kinulong po niya yung may hangin, no? Kaya yung may hangin sa ulo, ingat-ingat kayo tumabi dyan. Ikukulong natin, no? So by using a semi-conducting material. So with that, yung ionization nag-o-occur dito, or the partial discharge does not occur anymore using a semi-conducting layer. O kung tawagin natin ngayon is the strand shield. Kung minsan tinatawag nila conductor shield. So anong function? Faraday's cage. Period. Yan. The next component is the insulations. The insulations, discuss kanina din, meron tayong operating temperature. Let's go down to the XLPE, 90 degrees. Ano ibig sabihin yan, sir? Pag 90 degrees ka lang, operating mo, then forever. Para kang sigardo, forever. Diba? Kung ang kable mo is 40 years na tinatarget mo, at dyan ka lang nag-ooperate, forever. Unfortunately, the real world is hindi ganon. So pag lumagpas ka dyan, bawas buhay. So papasok na yung calculus natin dito. Habang lumalagpas ka per degree per seconds, bawas-bawas ang buhay. Okay? So maximum 130 degrees C. Pag wala na yan, yung insulative material mo malamang Merry Christmas ka ulit. So main function, voltage. Contain the voltage. So proportional pala to, itong insulative material natin doon sa kakayanan niya to contain the voltage. Kung mas malaki ang voltahe mo, dapat mas malaki din yung, o mas makapal din ang insulation mo. Okay, to address or to contain the voltage na nandoon. Kasi by relative or analogy lang, ang voltage is like the pressure. Okay, so ngayon, in real life, no? Topic mamaya ni Sir George, harmonics, lalo na yung voltage harmonics, no? Voltage harmonics, so the variations of the voltage natin, no? Yung amplitude natin, akyat baba. So ang effect nito sa insulative material mo, mag-i-expand, magko-contract, expand, contract. Habang nandyan si harmonics, tatawid-tawid yan. Okay? Kung na-address mo man yung building mo, yung harmonics mo, tatawiran ka ng kapitbahay mo. That is the harmonics of today. So in termination, kailangan, pag sinisild natin to, yung material na gagamitin natin is kayang sumabay sa expansion, saka sa contraction ng material natin. Okay? So, tandaan nyo, anong gusto mong protection? Plastic material or yung rubber material? Mamaya, sasagutin natin. Ha? So, the next is the insulation shield. The insulation shield has several functions. No? ang the most relevant function today for this topic is the symmetrical radial distributions of the voltage stress within the dielectric. Ito, mahilig ang electrical ng shortcut stress. Stress ng kable mo. So he is referring to the voltage stress. Kung minsan, pag na-stress na daw ang kable, umiinit. Okay? That is the byproduct of the partial discharge. Okay? So, ano yung radial distribution? Kasi ang function pala ng metallic shield natin is to address that stress na evenly distributed siya. Okay, paano yan? Ganito lang yan. Kung ang conductor mo is meron siyang insulations, polymeric kung tawagin nila, no? Polymeric, ang daming kan, malalim na English. Sa atin is insulations. So, dapat pag nag-energize ka, yung equipotential lines natin is equally distributed dito. Okay? Forget the words, no? Kung ma-off-centered tong conductor mo, halimbawa, natabingi siya, mas makapal sa kanan mo ngayon. So, ibig sabihin, yung sa left side mo, kung saan manipis na ang insulation mo, kukonti ang voltahe, lower voltage than the other side. So, kung 15 kV to, and then off-centered siya, so malamang sa kabila, 25, malamang dito 5 kV ka na lang. O pag pinatakbo ang sistema mo at 15, nako, Merry Christmas ka. Okay? So kaya nga doon sa mga quality control natin, sa production natin, periodically tinitingnan nila kung nasa sentro ba yung conductive material natin sa insulative material natin. Kung magtutour kayo doon sa mga cable manufacturing, try to go to the quality control. Makikita mo paano nila tinitingnan yan. Okay? So that is the main function. Okay, bakit kung hindi siya naka-off-centered? Ito kasi nangyayari, no? Yung voltahe natin, energize siya, and then by nature, shortcut yung energy natin. Yan, mahilig sa shortcut. Okay, walang social distancing. Welcome to the tiny bubbles ulit, no? So walang social distancing, ang dami ng energy dito, iinit na to. This is now the voltage stress. Kung tawagin natin, sir, high stress na po yan, umiinit na yan dyan. So kung nare-reach mo ng 130, Merry Christmas ka na. So in order yung electric flux natin is evenly distributed, we are using the shielded cable. Okay? Yung metallic shield, yun po ang trabaho niya. So kung tinatanong tayo ni BE, si Sir Jimmy, Sir, ang function niya, sir, is to even out the stress distributions of the kwan. Okay? Pag mo sagutin ng kwan yun, baka mamaya babawiin ang license natin. Okay? The semiconductor, we have discussed this one. This is the Faraday's cage, ang main function niya. So, sa industry, ang daming design. No? Yung mga shield natin, meron siyang tape, meron siyang wire shield. Meron din siyang uni-shield. These are proprietary. Ibig sabihin, patent po yan ng isang kumpanya. So, meron din sa unang panahon, we have the lead. No? Paper insulated, tapos lead ang ginamit nila. Okay? So, distribution natin, madalamang lagi itong sikat. Yung mga taga-Meralco boys natin. Very prominent sa GCN at saka CN. For the commoners, anong pinagkakaiba? Ang isa meron jacket, ang isa walang jacket. But the functionality is the same. Okay? So, beddings. 1, 2, 3, 4. Mabilis lang tayo. So, tapos na natin yung 4. And then, ang dinadagdag doon, we call that the beddings or the filler. Anything na dinadagdag doon. Ang main function nila is to add the mechanical strength. That's it. So, kung naghihila ka ng kable, hilain mo dyan. Huwag mong hilain sa insulative material mo. Okay? Baka mahihila mo and then ninipis. So there are the beddings and the filler. So hopefully, yung first 4, if you are going to take note, yung 4 na component natin, the basic component, ang main job nila is to address the electrical parameters. Yung pang-5 natin, yung jacket natin, kung tawagin ng European, sheet, no? American, North American, for those who are climbing the ladder, ayan, this is the terminology na ginagamit natin. No? European kaharap mo, sheet ang gamitin mo. North American, jacket ang gamitin mo. They same ang functionality nila. Ano function? Ang function is to keep the moisture and physical protection. So pag napunit mo yan, moisture, paano mo i-address? Using the tape, rubber tape. Physical, address ng PVC tape. We call that in the Philippine National Standard 79, EVAT, kung tawagin natin sa batas natin, electrical vinyl adhesive tape. Yan. Ibig sabihin yan, ito yung karamihan pag sinasabi nila, electrical tape. So, ang mean nila, yung PVC tape or vinyl tape kung tawagin natin. So, that is how to repair the jacket. So, to identify These are for mga gumagawa ng design o gumagawa ng requisitions. So paano natin isusulat, no? From innermost papunta ng outermost. Ganun pong sequence. Pero pag multi-cable na siya, no, down right, no, down right sa screen ko, lalagyan mo lang ng 3. So magiging 3 conductor and so on and so forth na siya. Okay? So sir, paano paghahaluan ko ng control? Pwede. Pwede yan. No? This is a typical example of a 5 kb, may halo siyang control. So ginagamit to lalo na doon sa mga port natin, ano, yung tumatakbo na gantry crane. So this is the power and this is the one that control. Iga-grab mo yung 20-footer container van mo, ililipat mo, bibitawan mo. So this is the control, this is the power. This is a 5 kb. Ito naman, may sa Camarines, tumawid ang isang sistema natin into isang barangay, isang beautiful island. So this is a 15 kb and then pagtawid niya, sinabay na nila yung fiber optic. So how to write this one? 3 conductors and so on and so forth plus ang sign mo, fiber optic. This job was done by, the termination job was done by kina Sir Jovi, taga-TAC. Yan, 15 kb siya. So napaka-komplikado. But if you are going to recall, yung basic termination natin remains the same. Dito din, komplikado siya, but the termination at ang basic component is the same. Okay? So pag naging IoT, no, Internet of Things naman, ito yung mukha ng mga kable natin. Hinalo na natin yung power cable, control cable, instrumentation cable, mga taga Siemens dyan, this is the Profinet, Ethernet cable. Hinahalo-halo na sila. So tatawid yan from one system to another system. Industry 4.0. Okay, collection ko sana to when I trained in France. Kaya lang nang hiniram, hindi na nakabalik dito sa atin. Good luck sa kanya, sana bumalik siya. No? So kaya ko pinapakita to just to show off na meron talagang ganong technology ngayon. Okay? Kahapon nakikita natin yung 3D ng isa ng presenter, no? Ang ganda. So that is for the basic power cable. Hopefully you recall, no? So sa splice. So sa splice naman, we have a guidelines and then ano ba yung pinaka bottom line? You just rebuilding the cable. Paano mo i-rebuild ang cable? So if you're going to read this one, these are the component of the cable. Kung hindi mo alam ang component mo, malamang hindi mo marunong kan dyan. Hindi mo kailangang masusupervise yan. Kasi kung ano isusupervise mo, dapat kahit pa paano, you know the science behind those job, no? So rebuilding lang palang ginagawa natin doon. So when you are trying to manage, anong hanapin ko? Number 1, yung terminator bomba is may knowledge yan. Nag-a-attend ba yan ng IIEE para ma-update yung knowledge niya? Pina-practice ba niya? So we are talking about the skills, knowledge, skills, and then meron ba siyang proper tools? So 75% ng failure nito is on the workmanship and majority ng failure because of the improper tools na ginagamit nila. Okay? Biro mo, sisingil sa'yo ng 10,000. Okay? 10,000 ang splice, 5 kb. Yan, sa registered master electrician natin, sir. Ganun ang pa natin, ha? Labor cost na yon, ha? Labor cost pa lang yon. And then, gagamit siya. No? Gagamit siya ng tools pang bahay. So that's not the way to do it. No? So if you're in the management, supervisions of the splice and termination, make it sure may proper tools, knowledge, and the skills. Okay? Maraming type ng splices, i-shortcut na lang natin. We go direct to the inline. The challenge of the branch in the letter T is the connector itself. Ikutom ang buong Pilipinas, na highlights nyo kahapon, ang hirap maghanap ng connector niyan. So let's go to the inline. And then, yung technology natin. No? So magko-concentrate lang ako sa tapes kasi in the advent of that time. So meron tayong tape, push-on, heat shrink, at saka cold shrink. Tape na lang. Kasi, lalo na ngayong pandemic, yung mga first medic natin, meron silang emergency kit. Question is, kung nasa building ka, management, nasa maintenance, repair, operation ka, ano ang laman ng emergency kit mo bilang electrical practitioner? Okay? Minimum requirement ng electrical tapes na dapat nandyan sa emergency kit mo as electrical person, semiconducting tape, rubber splicing tape, metallic shielding tape, at saka itong dalawa. Question is, meron ba yan sa opisina mo? Okay? So more often than not, Meron tayong splicing tape siguro, rubber at PVC. But itong metallic shield at saka semiconducting tape, umikot ka sa lahat ng mall sa Pilipinas, hindi mo mabibili yan. Binibili lang natin yan sa mga qualified partners. These are specialty tape. So dapat nakapondo ka na. Okay? Just today, shout out daw kay Governor Loca. Sir Gov, pasensya ka na, gagawin kitang example. Kaya absent yung isang speaker natin, si Kevin. Ngayon, ina-address niya ngayon. So take note, doon sa consequential cost natin, isa doon is yung outage cost. So imagine, ongoing to ngayon, o kaya kahapon, sana natapos mo. 16 hours, isa-shutdown mo ang 100 plus megawatt na kumpanya. That is a generating plant, no? Isa-shutdown mo because of this trouble. So, ganun kalaki yon. So what if, paano mo isusupervise yan? Very challenging. So sa management, alam natin, lalo na yung mga malls, sila ka Sir Charles, very keen dito. Pag nag-shutdown ako, per hora, per minuto, milyones ang nawawala sa revenue. Yan. So, ingatan natin. Kaya dapat, lagi nandyan. So taping method, connect mo lang siya and then copper to copper, copper ang connector. Pag ibang gagamitin mo, mag-u-occur ang GC natin, galvanic corrosion. Iinit yan, then Merry Christmas. So, kaya yan. Mali-mali ang tools natin ginamit. Okay? So, transition splice. Ibig sabihin, ang splice ko is from one metal to another metal. So, may mga transition connector tayo. Shear bolt kung tawagin natin sa field. Ngayon, yung shear bolt mo, iikutin yan, mapuputol yung dulo. Mag-shear off. And then, sa design niyaan, ito may friction plate siya. So mas maganda to pag malalaki yung mga conductor natin. Kasi pag nag-energize ka ng malaking conductor, kaya nga may reschedule ka ng retightening kasi lumuluwang ang iba. Lalo na yung mga compression type, no? Lumuluwang yon. Ito, mas mataas ang qualifying niya. So kaya na, bento yung shear bolt natin. Pag malaking cable, at saka transition splicing, transition from one metal to another, transition from one size to another, so you should use the shear bolt. Okay, reshielding. This is a semiconductor tape. Please use Scotch number 13. Ito yung special kuha namin. May mention ko ng Scotch number 13 kasi that is a semiconductor material. Huwag niyong iuwi yan sa bahay. Mamaya, iuwi mo yan at gumawa ng extension cord si kumpare. Binigay natin yan sa kanila at hindi niya alam pala yon. This is a rubber type, no? Pag energize yan, sigurado ako si kumpare may kalalagyan. So this is a case also of one of the power plant yan sa Laguna. Okay? Hindi nila nakilala na yung rubber tape pala is tape number 13 functioning as a semiconductor material. Okay? Paradise cage. Re-insulate. Alam na natin yan, namingit na natin. And then ito, ang reshielding tape. Dapat nandyan yan sa'yo. This is qualified as electrical kasi meron siyang electrical property, pumapasa yan. Huwag niyong lagyan kung ano-ano yan, ha? So rejacketing and so on and so forth. So 1, 2, 3, 4, 5 dapat doon sa maintenance repair operation team, those who are managing this team, make it sure na meron kang minimum of 5 electrical tapes, types of electrical tapes na nandyan dyan. Kung kumpleto ka yan, low voltage kaya mong i-splice, medium voltage kaya mong i-splice. Sir, my favorite number is 69. 69 kV, yes, you can. Okay, paano? Then you can send request to Glenmar and us, no? So splice, may cold shrink din, mabilis lang yan. And then the most question na nalalaman namin dito, ang challenge dito daw, ang cold shrink ba daw is pwede sa masasubmerge sa tubig? Okay, kaya nag-craft ako ng isang picture. This is the cold shrink and this is the manhole. Okay, not unless may manhole tayo na sa second floor natin, sumama doon sa transformer natin, ibang usapan yan. So most of manhole na ginagawa natin, lulubog talaga yan. Lalo na sa Metro Manila, no? Tag-ulan na naman, imposible hindi tatakpan ng natin yan. So this is a very picture working na sa Metro Manila. Okay? So again, if you have questions and kung gusto nyo mas deeper pa, you can send to any one of us in the Philippines. Okay? Kahit si Glenmar, nasa kwan yan, willing yan, eager beaver. Okay? So normally we have the hands-on, but this is So, yung question nyo, sasagutin ko na lang dyan sa chat box natin. So, let's go to the termination directly. This is the termination, galing sa taas hanggang sa loob. Same principle ang gagamitin natin. When you say terminations, okay, ang ibig sabihin lang yan, nako, nag-alarm na, I have 10 minutes na lang. 10 minutes to go. Termination means to say discontinue the insulation shield. Pupusta ako, pag hindi natin pinapasadahan yung component nito, ituturo mo yung 1, 2, 3, 4, and 5 na component. Ano po yung insulation shield? Ito yung pong fourth component niya. Okay? Pag pinutol yan, our term is terminations. Okay? Pag pinutol mo yon, magkaroon ka ng stress. This is the area kung saan naghihiwala yung semicon mo, saka yung screen mo. Very stressful area yan. So this is the theoretical aspect. No? So para i-address natin ang stress na yan, meron tayong batayan. So this is IEEE 48, 1990. Basahin na lang natin yung detalye niyaan. So this is the basis for the terminations. So and according to that guidelines, meron tayong class 1, class 2, and class 3 terminations. If you are doing the termination of class 3, ang in-address mo lang o ang minanage o supervise mo lang is the stress control. But if you are doing the class 1 termination, you should look for anong klaseng stress control ang nilagay mo, anong klaseng insulator ang nilagay mo, at anong klaseng silyo ang nilagay ni contractor. So if you are the designer, make it sure. Sa design mo, if you are the owner, make it sure. Ilalagay mo, IEEE Standard 48, 1990, Class 1 termination. Kasi pag hindi mo inilagay ito, gagawin yan ng contractor natin Class 3 termination. Magdidebate kayong dalawa. Magdidebate kayo. Sabi niya, dapat ko ay AAA. Oh, AAA. That is a Class 3 terminations. Okay? So ito yung pinakamagandang ilagay natin. Class 1 termination, IEEE Standard 48. So ano yon? Papasadahan din natin. Stress control, may dalawang technology. This is the geometric. Ito yung part na ito, pinaugbo lang nila. No? Medyo maugbok. So that is a geometric type. And then, meron din siyang high capacity. Okay? Ngayon, this is the computations. We are talking about the refraction index. Papasadahan na lang yan. Sitting side by side, yung geometric mo at saka yung capacitive mo, mas mahaba ang preparation ng geometric kaysa high capacity. Preparation means tatanggalin mo yung ibang component, na-expose ang ibang component, and then that is the cable preparation in accordance to the measurement of the manufacturer. Okay. Go Lucas, sa inyo din to. Meron tayong participant dati na instead of sundin yung cutback, yung measurement ng cable preparations ng 3M, sinunod niya yung iba. So yun, nagkaroon ng Merry Christmas siya. Yan. So, insulator. Pipili ka lang kung anong klaseng insulator. Dati, ceramic. Nawawala na to. So, ang pinakasikat ngayon, silicone rubber na ang ginagamit. Bakit kaya? Kasi, pag pumili ka na doon, ang ilalaban mo, this will work against the UV, electrical discharge, chemical. Okay? Let's concentrate on the silicone. Ang silicone, bakit siya current? Kasi, by inherent, ang silicone is hydrophobic. No? Electrical practitioner, habang palalim yung pagiging electrical natin, takot tayo sa tubig. Bakit kaya? Okay? So, hydrophobic. Okay? Insulative material, hydrophobic ang gusto natin. Kasi ganito yung hydrophobic. No? Yung saturation point. Ibig sabihin, idudugtong. Okay? Idudugtong ng tubig natin mula live, papunta ng zero. So, kung hydrophilic, yung material mo, ang lapad na. So, madali niyang idudugtong. We call it, madali niyang masaturate. No? That is hydrophilic. Yung una nating mga technology, which is the ceramic and the glass, nung una, makintab siya. So hydrophobic siya. Through times, through abrasion, natanggal ang pagiging hydrophobic niya. Nagiging, I love water. Yan. So, nagiging balimbing siya. So, ang maintenance noon, papahiran mo to retain the hydrophobicity of the material. This is in the laboratory of Glenmar when Glenmar is still in the Philippines, age acceleration. Pasok mo, tatakbo yung makina, 4 na buwan, 24/7 ang takbuhan nun, so equivalent, 40-year-old na siya. So after 40 years, yung insulated material natin, it retains the hydrophobicity material niya na component. So kaya pala, karamihan ngayon ng insulative material natin is gearing to the silicon 1. Okay? So, science is, this is the angle. So, takbuhan na lang natin. And then, heat shrink versus the cold shrink. if and only if meron tayong concrete study. This is a study done by the 3M. We have a factory of cold string termination in India. So comparing both, no, yung may 1600 hours, yung typical to fail ng heat shrink natin, and then yung cold string is doble. So that is the reason we are migrating into the quick terminations, which is using the silicon. So this is not a study of other company. For those who are very interested on the sciences, no, sabi nga namin, science applied to life, we highly encourage you to join 3M. So 3M is investing 5 billion US dollar year in year out para lang to sustain the research and development. Ganun siya karami. So 30% of the total sales ng 3M is coming in from the technology which was na pala, no, innovated, no, o invented man, yung lumang term, innovated for the last 5 years. So ibig sabihin yan, yung ginagawa ngayon, okay, so that is the depth of the 3M group, science and technology. Okay, so silicon is hydrophobic, UV resistant, or UV stable. So the beauty of the engineering science is we talk about exact, no, numbers. So when you are using the silicon oxide, you are using 445 kilojoules per mole band energy. Pag UV mo, 398. Pag ilalaban natin dawan, wala kang chance na mananalo sa silicon oxide. So ano yung material na gumagamit ng silicon oxide based material? This is the silicon rubber. Yung heat shrink natin using this one material, no, majority. And then, anong strength? 348. Anong strength ng UV natin? Pag nagbanggaan, 398. So, 50 kilojoules less than. So, anong mukha niyan? Ganito. Sira-sira talaga siya, no? So, maaagnas. O tawagin natin, nag-degrade. Okay? Or, kung tawagin natin, pag termination job, sir, nagtatrack na yung termination mo. Okay, so this is a typical example. The person, I believe, who address this one, nandyan po sa mga crowd natin, sa members natin. Ito yung isa sa mga problema nila. So makikita mo, after a certain period of time, this is less than yata 10 years old, no? Naagnas. Okay, nagdi-discolor na siya. So, alam na natin kung bakit yan. Okay? So, nagdi-degrade na siya o nagtatrack na siya. Okay, natatanggal na, nalalaglag ng skirt. So hydrophobic, inherently stable, and then does not form a carbon path. Bakit? Kung carbon to carbon ka, heat shrink ka, so pag naghihiwalay ang carbon at saka carbon, so ma-imagine mo, live ang taas, ground zero, gagapang dito, this is the creepage distance, habang gumagapang siya, naghiwalay ang carbon material. So magkaroon ka ng ayuda, which is the carbon. And carbon is a very good conducting material o element, no? So habang gumagapang siya, nagkaroon siya ng ayuda kasi nagkahiwalay. Ang bilis niyan. So napakarami na nila, nag-flash over na siya. So unang tirikuan yan, hihising yan, hindi mo narinig, kikidlatan ka. Flash over. Ngayon, termination talaga yan ang kailangan, no? Either ikaw ma-terminate o yung contractor mo ang ma-determinate pag malaman ng management. So that's how critical termination is. Question is, gaano kahaba ang buhay na pinag-uusapan nito? Kung gaano kahaba ang iniisip mo, ang kable mo, kanina may mga derating factors si Sir Archie. So dapat mamimit mo yun. Okay? Mamimit mo yung buhay na tinatarget nila. Kung 30 years, dapat buhay ang termination. Anything happen to that, tawagin mo ang terminator mo or the engineer who supervised that one. For that reason, yung jointing o termination job is a special license abroad. Sa Indonesia, nandiyan si Ampri, this is a special license. So hindi na lang, okay? Basta-basta terminate yan. Taga Singapore, yan, kailangan mo ng special license. Sa Pilipinas, walang lisensya lahat. So what we do, okay, mabait ang IIEE. Tinutulungan natin magkaroon tayo ng self-regulation by sharing the science behind this one. This is the activity that we are doing, okay? So kasi wala pa naman tayong batas, kung sabi nga ni Sir June Lopez during our Bicol Regional Conference doon, bakit hindi regulated? Sir, kung antayin natin yung regulation, nako, mahaba-habang lobbying ang gagawin dyan. Habang wala pang nangyayari dyan, we share the science behind. Okay? So, the third job na gagawin mo, nakapili ka na ng una, Nakapili na ako ng stress control. Anong gagamitin ko? Nakapili na ako ng insulation. Nakapili na rin ako ng silyo. This is the third na bantayan mo, na i-supervise. Anong klaseng seal ang ginawa niya? Nilagyan niya yung baba o nilagyan niya yung taas? Okay? Completing the three, we have now the type class 1 terminations. Okay? Class 1 terminations, and then this is the reality. Anything na tinakpan mo, this is the dead end termination, the principle stands to. Anong hanapin mo? Anong klaseng stress control? Anong insulative material ang ginamit niya? At anong silyo ang ginamit niya? Okay? So we have a lot of technology, and then lagi nating babantayan. Si Sir Jojo pala to. So during the face-to-face value pa natin, so the IIEE of Luzon, nag-sponsored sila. So ganun kadali ang termination. This is a 15,000 volts, tiniterminate ng young practitioners natin. Okay? That was 2 years ago. Sergio. So ito, babantayan natin. And bakit? Sabi nila, pagkausap natin is linis. So by principle, ang stand natin dito, it will act like a lightning rod. No? Pag napapansin yung mga lightning pa natin, lahat matulis. Bakit kaya? So ang density kasi, so when you talk about equipotential, pareho lang yan, but the density is greater dito. So yung charge, yung Q natin, nakatambay dito. So the moment nagkaroon ka ng ionization dito, nagkaroon ng ibang charge, tatalon ka agad yan. So para siyang meron kang kidlat. So kung hindi nalinis yun. So nililinis mo yon in order to prevent this phenomenon. Okay? So mga tools, and then the technology, porcelain, and then heat shrink, we have the technology also. Anong hanap? Stress control, meron ba siyang silyo? Okay? Meron ba siyang insulator? So that is a class 1 terminations. May skirt, walang skirt. Okay? So cold shrink, sandali lang yan. Kahit babae, kayang-kayang gawin. So behind the model, no, this is a 69 kV and this is a 15 kV. Okay? Madaling gawin. The same principle will apply to. Ang image na lang. So cold shrink termination developed, pinaka-latest na technology, 1968, was a patent of 3M. Bagong-bago 1968 yung gumagamit ng cold shrink. Okay. So kagable prep, insulator ang silyo. Class 1 termination according to IEEE, hindi sir, kasi kulang ng stress control. Don't worry. Paglagay mo rito ng insulator, nandoon na po yung stress control mo. So that is a class 1 termination, generation 2. So, yung may skirt sa loob, sa labas, pwede din. Pero pag walang skirt, huwag ilabas. Bakit? Ganito yan, no? Live, papunta ka sa baba, sandali lang. Pero pag meron skirt, akyat, bababa, ang layo ng creepage distance mo. Kaya pag pumunta ka dyan, ngayon, pag binaliktad yan, okay? Pag binaliktad yan, tama ba o hindi? Ngayon, merong maraming gumagawa, payong kung minsan tawagin to, no? Baliktad. This will act like a shield, no? Pag umulan, wet band, dry band, wet band, dry band. So added protection. Ngayon, kung binaliktad mo yan, sahog ulan, pwede ba? Okay? Sabi nga ni Sir Archie, I leave to your discretion. So gentlemen, if and only if I'm going to leave you yung punchline natin, bakit we are trying to migrate into the modern, no, silicon base o cold shrink termination. This is it. So if you're going to recall, cold shrink natin is made of rubber, and then the living cell is continuously working towards you. Yung silyo natin continuously doing its job. Kahit labas-pasok pa diyang harmonics mo, fully addressed na yan. Okay, so this is it. I think I need to stop from this point. We are 2 minutes ahead of my time. Miss MC, I think that is my last slide. In the interest of Sir Jules, this is one of my favorite speakers kasi this is Sir Jules. Sir Jules, it's your time. Thank you very much, and please send your email or query to us. Hello.
Thank you very much, Engineer Castor. And of course, due to time constraint, as much as we love to answer all your queries right now, we will be asking or requesting Engineer Castor to answer the Q&A chat box, please.
Yes, Monique, we are going to the chat back na lang and then we will try to address. And for those who cannot answer, please send it through our email. Huh? We are happy to answer you.
All right, sir. Thank you very much. So we will now proceed to the awarding of the Certificate of Appreciation. So let me read the citation, please. Certificate of Appreciation is awarded to Engineer Marlo G. Castor in grateful acknowledgement and appreciation of his invaluable service and professional thought shared as the resource speaker for a sponsored technical presentation on the topic entitled Medium Voltage Termination and Splicing during the IIEE 7th Metro Manila Regional Conference, a hybrid event with the theme Got One IIEE at 4 to 6, transcending the challenges in the new normal by embracing resiliency and complementarity, given the 17th of August 2021 at IIEE Building, Cabal, Quezon City, and via Zoom cloud meetings. Signed by Engineer John Reyes Estrosa, the Vice President for External Affairs of Metro West Chapter, Engineer Giovanni F. Tagatak, the President for Metro West Chapter, Engineer Manuel M. de Guzman, the Secretary General of Metro Manila Region, and Engineer Alwin M. Wagan, the Governor for Metro Manila Region.
Thank you, Monique, and thank you to the team. Stay safe to all.
There you have it. Awarded by the Governor, the Secretary General, and the Chapter President. Congratulations once again, Engineer Marlo Chica Store, together with Engineer Esther Don Rebon.
Allow me to introduce our next speaker. He is a life member of the Institute of Integrated Electrical Engineers of the Philippines, INC, and a registered professional engineer of the Association of Professional Electrical Engineers and Geoscientists of Alberta, Canada. He took his electrical engineering degree at Mariano Marcos State University, Batak City. He has conducted numerous webinars for short circuit calculations and applications part 1 to 3. He was awarded by Alpha Phi Omega Alumni Association of Alberta a Certificate of Appreciation for Leadership in 2015 and a Certificate of Appreciation for Exemplary Contribution by Sayhati, Otman, and Patani Consulting Company in 2005. He was a former lead electrical engineer at Worley Parsons Canada Services Limited in 2007 to 2012 and Wood Canada in 2012 to 2018. He also worked as Senior Field Technical QA Engineer at Suncor Energy in 2019 to 2020. At present, he works as Principal or Lead Electrical Engineer at Worley Canada and a Senior Electrical Engineer at Bepica, Canada. Let us all welcome Engineer Primo G. Beltran Jr.
Hello, good morning po sa lahat. I think I can start. Before I start, I would like to extend my appreciation to IIEE Metro Manila region, specifically also to IIEE Metro West. And yes, I've been here in Canada for quite some time. So, pero I'm able to connect to people now using our communication technology or our social platforms. And The topic for today is about, let me share my screen first. Okay, okay. Okay. So, time check. What time in hanggang what time in Philippines now? I think it's 10:30, right? Okay. So, let me
It's
start.
10:25, sir.
Okay, and I'm supposed to finish at what time? I just want to make it sure my time is going to be followed, or
1 hour po, sir.
1 hour. So I have until 11:30. Is that what it is?
Yes, sir.
Okay. So anyway, the topic right now is about the direct application of multiple motors into medium voltage variable frequency drives. So hindi po tayo limited sa medium voltage, but anyway, I'm going to present a medium voltage application because it has more stringent requirements than that of a low voltage. However, applicable din po ito sa mga low voltage motors, okay? So basically, I'm not here to conduct a full-blown instruction on what is a VFD and what are the different types of VFD, because napakalawak po nun and it is very broad. Okay, so in an on 1 hour time frame, the topic is limited to how we are applying multiple motor application into one single VFD. Okay, so here's a basic topology ng isang medium voltage VFD. Normally, because it is medium voltage, then the capacity and the type of motor, hindi naman po tayo gumagamit ng maliliit na motors sa medium voltage application. So normally, in our industry practice, if hindi po siya variable frequency drive, the maximum motor horsepower rating to be able to have a practical design in terms of the current rating of your equipment is basically hanggang 200 horsepower. Okay? Beyond that, if it is across the line or direct online started, mataas na po masyado yung current niya in such a way that it may eat up a lot of current, like it will require you to use high current distribution equipment, or magkakaroon po kayo ng motor starting problems. And that's why when we say more than 200 horsepower, sometimes depending po sa application at kung meron po kayong magandang business case, let's say there's a process reasons kung bakit po kayo gagamit ng variable frequency drive, then you are okay to use a variable frequency drive. Now, up to how much current rate horsepower rating kapag ang motor natin is low voltage and gagamitan natin ng VFD? Because of the soft starting feature of the VFD, pwede na po kayong gumamit hanggang 600 horsepower na motor. And you can use that into a low voltage application because yung motor starting issues po natin na-offset na siya ng VFD. Okay? However, you have to determine what is your maximum load current. Because if we are talking about 600 horsepower, mataas po yung load current natin. So again, it boils down to the fact na dahil sa current rating natin, kailangan nating igawin na lang na medium voltage. Okay? So there's the pros and cons to that. Now, when we are talking about medium voltage application for VFDs, we're talking about a minimum of 600 horsepower. Okay? And beyond. So in our application na i-present ko dito is more of a 3 pieces of 400 horsepower application, which is basically the VFD will be suitably rated to be able to operate a 12,000 horsepower motor. So if I say 12,000, it's because I got 3 pieces of 400 horsepower motor. Okay. Now, in the typical application, you normally have a switching device on the source. So nandito po yung motor natin sa pinakadulo, and ang nasa gitna po rito is our variable frequency drive. Now, yung input switching po natin dito, ito po yung source natin. So ito po yung ating switch gear. Maaari pong ito yung medium voltage MCC natin. That means if we are controlling if we are switching on and off the BFD using a motor starter, which is basically ginagamit po yan kapag ang voltage rating natin is 4.16. So, imbes na bumili kayo ng 5 kV switchgear, mas mura na bumili kayo ng 4.16 kV na motor starter, which is a class E2. Okay? So, fuse contactor arrangement. Ngayon, kapag ang motors po natin is exceeding 4.16 at aabot kayo, let's say, sa 13.2 kV application, then hindi nyo na po magagamit yung mga motor starters, so gagamit kayo ng switchgear. Okay? So in this particular application, maari po yung tatlong motors natin is 400 times 3, let's say 3 motors connected to one BFD, then you have a 12,000 horsepower. But your motor will not be a 13.2, it will be either a 4.16 kV or a 6.6 kV. Kasi po yung VFD, siya na po yung magi-step down. Okay? Kasi pag ganun po ang situation natin, then we will need a voltage source inverter. That means magkakaroon po tayo ng isolation input transformer to step down the voltage into a lower level. And that means for us to be able to optimize the current in the primary, gagamit po tayo ng mas mataas na voltage, taking advantage of the input transformer. Okay? So those are the optimization techniques. Okay? Kapag maliit naman po yung motor nyo, maaring wala na pong input transformer. Pwede po kayong mag-active front end na tinatawag. If we're using an input isolation transformer, it has the advantage that it will eliminate common voltage mode problems. Okay? So ang switching device po natin is yung switchgear, yung ating MCC contactor. And then, papasok na po tayo sa input ng VFD. So ang VFD po natin, hindi ko lang nalagyan ng block ito, it will start from here and then it will end on the output of the filter. So mayroon po tayong harmonic filter on the input. Okay? So ito po yung magkakaroon tayo ng power factor correction also there kasi filter, so may capacitor siya. At the same time, there is also what we call a saturable reactors too kasi filter siya, right? So this is for harmonic mitigation to comply with the IEEE requirements, or if it is an IEC BFD, then it will comply with the IEC requirements. And most of the time, the requirement is thou shall not exceed 5% or 3%. So basically, yung mga manufacturers, they'll try to make it sure that their unit itself is able to mitigate the voltage harmonics. Okay? Sometimes, dahil po yung configuration is may input transformer, gagamit sila ng tinatawag na phase cancellation. In that way, hindi po sila gagamit ng malaking filter. Okay? Ano po itong input impedance? Ito na po yung tinatawag nating transformer. Okay? Ito yung isolation transformer po natin. And normally, if this is a voltage source inverter type, na marami po kasing klase ng VFDs. Okay? So, but we're not gonna tackle that. We will only use a VSI pulse width modulation example here. Pero, ang sinasabi dito, maaari din pong reactor po ito. Okay? And then we will have our converter. And the converter is going to convert AC into DC. In that way, magkakaroon po kayo ng DC bus or DC section dun sa BFD ninyo. And from that DC, it will get converted again into an AC. So in between this, magkakaroon kayo ng tinatawag nating mga rectifier, mga bridge diodes and everything. Meron kayong either they're operating on a pulse width modulation or any other arrangement, or mayroon tayong mga thyristors. Okay? It's almost like UPS. Di ba sa UPS, may converter kayo, may inverter din kayo. Sa VFD, ganun din po. So meron kayong AC to DC conversion and DC to AC conversion at the end because your motor is still an AC. And why we are converting this to AC, so that we are able to control the frequency. Okay? By gating it. Okay? Itong DC link na to, ito yung dito na rin kukuha yung control system. Okay? So meron tayong process controller dito, or we will have a controller board that is going to operate the electronic components inside. Kaya po tayo may harmonics, okay? Because this is a nonlinear equipment. And this is why we always mitigate the harmonics on the input side, because basically the harmonics is going to feed the supply. Ang load current papunta siya sa load. Ang harmonic current naman po pabaliktad. Pupunta po siya sa source. And that's why we are trying to mitigate that, because if you have several VFDs operating in one bus or other buses, then mag-accumulate po sila. Although magkakaroon po ng dumping sa system, we have to minimize it from the source itself. And that's why manufacturers has to comply with the IEEE requirements. After it gets converted into AC, then we will still have an output filter. Depende po kung sa laki, kung malayo yung kable natin and the capacitance is high, then we need to have a filter on the output para hindi po tayo magkaroon ng over voltage. Okay? So this is a typical arrangement of a medium voltage BFD. You have an isolation transformer here to provide electrical isolation, and it is going to be used to step down the voltage if you have a big motor here. So ano po yung VFD in a dumb terminology? Kasi I always use this slide, and I think a lot of speakers also use this slide. Parang sa electrical may beer concept tayo dati, right? Just to dumbly present a point. Now, imagine the VFD like your car. So, yung source natin is meron tayong gasolina, of course, yan yung electricity, may power source tayo, and then meron tayong control equipment. So, either we can accelerate or decelerate the car, right? Meron din tayong brake. And then yung power conversion natin happens on the engine. So ito po yung VFD. It's like this is a mechanical way of showing it, okay? So it burns gas, and then kinokontrol nyo, meron kayong cambio, may primera kayo, may segunda kayo, or meron kayong automatic let's say shifter, okay? And then from there, kinokontrol natin yung speed. Okay? Pag may emergency, magbe-brake tayo. Although gusto nating mag-elevate ng mas mataas na speed, mag-switch tayo ng gear. So same thing with the VFD. The VFD is controlling the speed of the motor by regulating its voltage and frequency. Basically the frequency, okay? So ang frequency po is equal to speed, is directly proportional to the speed. So if you're able to vary the frequency, then you're able to vary the speed of the motor. So ang tanong naman natin, why do we need to vary the voltage along with it? You have to remember that the motor has what, kaya po umiikot yung motor natin dahil may tinatawag na flux. And that flux is directly proportional to the torque. And yung torque, and yung flux din po is proportional din po sa voltage divided by the frequency. Kaya tinatawag na volts per hertz. Now, pag mag-over voltage po kayo, ano mangyayari sa motor ninyo? Mag-over flux. That means magkakaroon kayo ng torque limitation. Okay? So if we are going to go to the basic concepts, nasa basic concepts pa lang po tayo, it means you control your speed by this equation. Ito na po yung Motor Basics 101 natin, right? Nung university. 120 times F over the number of poles. Dito po natin na-determine yung synchronous speed ng motor. If we are having an induction motor, nagkakaroon tayo ng slip. Bakit? Kasi self-excited yung induction motor. Hindi po siya katulad ng synchronous motor na separate yung excitation system niya. And that's why you are able to operate it at synchronous speed. However, for an induction motor to operate, kailangan may lag lagi yung rotor at saka yung stator fluxes in order to turn it. Why? Because it's getting its own excitation from the source, from the utility. Yung ating source voltage, yan po yung kanyang excitation. So laging may lag po yan. And that's why we have what we call slip. Okay? Now, if we control the frequency, ano pong mangyayari? If I decrease the frequency by 50%, that means my motor speed will decrease by 50% as well. Correct? Now, if I do that, ano pong mangyayari sa aking flux? Kailangan, pag naka-fix yung voltage nyo at binaba nyo yung frequency, that means yung volts per hertz ratio ninyo tataas. That means mag-overflux yung motor nyo. Mag-iinit po siya. Okay? Hindi lang po siya mag-iinit dahil bumagal yung fan niya na sa likod, bumagal din. So hindi na masyadong malakas ang buga ng hangin niya. At the same time, mag-overflux din yung core ninyo. Iinit po yung core. In that way, it's not able to deliver the rated torque anymore. Okay? Ay mag-over, parang nag-over voltage po yung core natin. And that's why when you decrease the speed, you have to maintain the torque para hindi po hindi mag-iinit yung motor, kailangan ibaba rin ninyo yung voltage on the same ratio. So if your motor is rated for say 460 volts at 60 hertz, yung ratio po ng 460 divided by 60 is basically 7.6. Yan po yung volts per hertz flux nyo. Pag binabaan nyo po yung frequency ninyo from 60 hertz to 30 hertz, which is binabaan nyo ng 50%, then your 460 divided by 30 hertz will be 15. Nagdoble na po yung ratio ninyo. So that means, anong mangyayari? Mag-overflux yung motor nyo. Mag-iinit yung core. Masusunog yung motor nyo. And at the same time, para po hindi siya masunog, babaan nyo yung torque requirement. Pero hindi nyo magagawa po yun dahil umaandar na yung bomba, right? So for you to do that na hindi mag-iinit yung motor, babaan din nyo yung voltage. And the VFD is the only equipment that is capable of doing that at the same time. Yung mga soft starter po natin, binababaan lang po natin yung voltage, nakapix pa rin yung frequency. So baliktad naman sa solid state starters, right? Yung 60 hertz nyo naka-fix, yung voltage ang binababaan nyo. So anong mangyayari? Pag binabaan ko yung voltage ko para ang aking starting current ay bumaba, anong mangyayari? Binabaan ko ng kunwari yung 460 ko, binabaan ko ng 50%. So anong mangyayari to? Magiging 230. 230 divided by 60, magiging 3.8 na lang. Hindi na siya 7.6. So ano pong mangyayari sa motor ninyo? Hindi na po niya madideliver yung torque. Yung ano naman nyo, yung bomba naman ninyo of it. So yung inyong process system maapektuhan. Okay? So this is how a BFD works. It operates to adjust the voltage and frequency to maintain a certain torque, operating torque. Okay? And here's another basic concept. It shows here na ito yung original torque curve ninyo, right? So yung breakdown torque nyo nandito and yung operating point ninyo is nandito sa right side. Itong left side, ito yung starting region. And ano po yung intersection na to? Itong intersection na to between this curve and that curve is your operating point at that particular speed. So ito pong speed dito, ito po yung tinatawag na synchronous, and the intersection of your mechanical load torque and the torque of your motor will be your operating torque. So between the difference of that is the slip. Okay? So ang ginagawa po ng VFD, kapag binababaan po natin yung speed niya dahil yun ang kailangan ng process system, ina-adjust natin kunwari to 330 Hz. In that way, we have to adjust the voltage to 230 volts in order to maintain the same torque. Because if you don't do that and you decrease this without decreasing the voltage, then what will happen? Iinit po yung core. Mag-overfluxing po siya. Okay? And that's how the BFD operates. Now, this is just one operation. There is also what, depending on actually lahat po ng load, halos lahat variable torque. Okay? The notion of constant torque is only because of the operation wise that you want for the motor. Okay? So I use them. It matches the speed drive and the motor to the process requirement. So you cannot just use BFD on any application. You should have a business case. Kapag ang process operation po ninyo is required siya na i-variable yung flow rate by varying the speed, then your best bet is to use a variable frequency drive. Kasi ang normal po na ginagawa noon is throttle nila yung valve. So kung meron kayong pipe and meron kayong pump, at naka-fix yung speed ng pump ninyo at gusto niyo i-regulate yung flow, anong gagawin niyo nung wala pang BFD? Meron kayong valve. So it's either i-100% open nyo o i-regulate nyo, i-close nyo ng 50%, i-close nyo ng 30% para lang po yung flow sa kabila ng valve is magbago. Right? Yun yung tinatawag nating valve throttling. However, the VFD operates differently. So I'm gonna show that later. And of course, the VFD has the capability to variably match the torque of of the motor against the process. So mangyayari magkakaroon kayo ng energy savings. Kasi yung operating point na po ng system na minamatch natin yung operating point ng pump. In that way, kung hindi nyo kailangan ng ganung kalaki dahil binabari nyo lang yung flow at yung ang magiging kilowatt requirement niya or horsepower or kilowatt, they're the same, is hindi niya kailangan yon para lang sa speed para lang sa particular flow rate na yon. Ang mangyayari, hindi na kailangan mag-operate yung pump on a fixed speed. Mababari po ninyo siya in a way makaka-save kayo. So here's a typical one. You cut the pump curve, and normally if the mechanical engineer size a pump, meron pong tinatawag na fan curves yung mechanical. And there is also what we call the system curve, which is this is your head in combination of the flow rate. Okay? More of a process system po ito. So mechanical engineering wise, they're going to select a pump rating that will give them the that is capable of giving them the variable the optimized operating point. So yung intersection po ng system curve, which is ito yung process, and yung actual pump natin, yung capability niya, ito po yung operating point. Okay? Now, if you don't use a BFD and you're going to control the line using a valve, ang mangyayari po, yung ating pag nag-decide tayo, assuming this yellow line is your pump curve, and naka-fix po siya dahil wala naman kayong variable frequency drive, for example. And you wanna, at first you're operating at a certain RPM. Let's say ito yung 1,200 RPM natin, naka-fix siya dahil hindi siya variable frequency, right? Naka-fix yung speed ng pump. And then ito yung namimit niya na flow rate. If you're going to decrease that flow rate from this flow rate to that flow rate, papunta sa kaliwa, itong red line, hindi po nagbabago itong yellow curve na to. Kasi naka-fix yung speed. So for you to vary that flow rate, you have to put a valve and you have to partially close it para magbago. So malilimitahan, that means magkakaroon po tayo ng limitation sa flow sa other side ng valve in a manner na hindi po magdi-decrease yung speed ng bomba natin, ganun pa rin ang speed pero nagbabago yung flow rate sa kabila. So if you throttle that valve, what will happen? Magdi-decrease nga po yung flow rate dahil yung speed po natin sa pump, yung operating curve niya is hindi nagbago, what will happen? Magkakaroon ng increase ng pressure across the valve. Magkakaroon ka ng pressure drop, not increase in pressure, but it will increase the pressure on the pipe itself, but there you will have a pressure drop across the valve. Okay? Kasi nga humina na yung flow sa kabila, pero nakapix ang speed mo dito sa source, right? So if you throttle that valve, then what will happen is magkakaroon kayo ng tinatawag na pressure drop across the valve. And that pressure drop is equivalent to mechanical loss in the system. So ang nangyayari po, hindi nyo kailangan yung ganong kalaking power to meet that flow rate. They'll decrease nyo yung flow rate, but what will happen is, anong mangyayari po? Magkakaroon ka ng pressure drop, which means ino-operate ko pa rin yung pump in a way na parang yun pa rin ang flow rate, pero binago ko lang sa dulo, ang mangyayari, nasasayang yung energy. Whereas if you use a VFD, if you're able to decrease the speed of the pump itself and not throttle the line, ang mangyayari po, magkakaroon po kayo, magbabago po yung operating point ng pump. That means you don't need that much of horsepower anymore. It will also variably decrease with the required torque that you na binago ninyo. So doon po nanggaling yung salitang variable torque application, kaya nagkakaroon ng energy savings. At the same time, if there is an increase in pressure in the line dahil tinotrottle nyo, wala po kayong problema sa electrical. Pero magkakaroon ng cavitation yung pipe. So ma-overstress yung pipe sa throttle ninyo. So kung may mga impeller, may mga bulbs pa kayo doon at may mga nakaseries na bomba pa, magkakabitate yung mga impellers nila. Dahil nag-i-increase ng pressure dahil linilimitahan nyo yung flow. Okay? So that's the disadvantage of it. There is a mechanical impact. And that's why in medium voltage applications, where ang pinag-uusapan natin is malalaking head, malalaking speed, or malalaking flow rate, or minsan, minsan may tinatawag din tayo na application na dahil sobrang laki nung capacity and sobrang laki nung pressure, so for us to use mechanical throttling through it, may disadvantages yon. Magkakaroon ng wear and tear yung system. And that means if you have constant wear and tear, that means you have shorter time na magkaroon kayo ng maintenance na palitan nyo sila lagi. That means it's gonna add more cost to your operational expense, OPEX, right? But if you use a BFD, your operational expense decreases. However, when you apply a BFD, you have to make it sure you have a business case that you really need because operate yung mode of operation nyo sa process is ganon. So hindi po ito yung malaking advantage ng BFD, may savings pero wala naman kayong business case. So it's not worth na magbayad kayo ng malaki kung hindi nyo ma-prove na ito yung equivalent na expense natin kapag di tayo gumamit ng ganito, ito magpapalit tayo ng bomba every ganito, magpapalit tayo ng linya every ganito, i-total niyo yung expense, tignan niyo yung savings niyo naman pag gumamit kayo ng BFD. Okay? Because if there's any energy savings compared to the operational cost of changing mechanical equipment, mas mahal po yon. Okay? Another advantage of the BFD is that it acts as a soft starter. So kanina sinabi ko, 'di ba, na pag binabaan natin yung frequency with an equivalent na pagbaba with the same proportion na pagbaba ng voltage through the BFD operation, anong mangyayari po? Yung torque na may maintain. So on a particular speed where your torque is not this much, or I just need to explain something about torque. Torque is dependent on your load. Hindi po ang kinontrol po natin yung speed with an equivalent voltage to maintain the torque capacity. However, your actual operating torque is still dependent doon sa bomba ninyo, doon sa line ninyo sa system. Okay? It's still dependent on that. Parang generator po. Pag nag-increase kayo ng voltage and everything, sasabihin nyo 10 megawatt yung generator ninyo. Ang yung 10 megawatt na yon, nagdedepende siya sa load, kung ano yung drino-draw ng load, right? Hindi ko mo nag-adjust 10 megawatt siya, 10 megawatt kayo. No. Kapag ang load nyo 5 megawatt, 5 megawatt kayo, hindi kayo 10 megawatt. Ganun din po dito. The torque is highly dependent on the system requirements. What is being drawn by the system. Okay? But when you vary it, hindi po mag-iinit yung motor nyo. Hindi po siya mababawasan ng capacity. Kasi kapag ang voltage ninyo bumaba at nag-fix ang frequency niyo, lumiliit yung capacity ng torque nyo. So kapag ang system requirement nyo lumaki, mag-o-overload yung motor nyo. At the same time, kapag binabaan nyo naman yung speed at naka-fix yung voltage nyo, ano pong mangyayari? Mag-o-overflux naman yung motor nyo. That means mag-iinit yung core. Okay? So you are able to variably adjust all the time and still maintain the capacity. Now, starting current is directly proportional to the voltage. Why? Because during motor starting, your motor is acting as a constant impedance. When your motor is running, it's operating as a constant kVA. Okay? So in that way, if you're starting your motor, you are able to soft start it because now you're able to decrease the voltage during starting and then decrease the frequency. That means your torque will not change. It will have the same torque capacity to start the motor. However, you're able to decrease the current itself. So in that way, naso-soft start yung motor nyo. So ano ang epekto niyan? Bumaba ang current nyo sa starting, it's able to accelerate. However, the acceleration time mas babagal. Bakit po mas mabagal yung acceleration time? Kasi sinop start nyo. Ibig sabihin, nagsimula kayo sa maliit, palaki ng palaki yung voltage gradually habang nag-i-speed up yung motor, right? Whereas kung wala kayong BFD at in-apply nyo agad yung full voltage sa motor, akyat agad yung current ninyo, that means mabilis mag-start yung motor nyo dahil full voltage yung in-apply sa kanya. Bam, right? But your starting current is high. And this is one of the advantages of having a BFD. But you cannot use this as a business case kasi mahal po ang medium voltage BFD. Para sabihin ninyo sa management na bibili kayo ng BFD pa na pang soft start, hindi papayag ang management. Because after you successfully soft start, in 10 seconds, wala nang silbi yung BFD nyo, right? So you should have a process requirement. Okay? So again, you're able to, and then ang maganda pa po sa BFD is that you're able to start your motor in an X number of starts. In a NEMA world, if you're direct online, you're only allowed 2 consecutive starts. And then you have to allow the motor to cool down, right? I think it's 2 or 3. I think it's industry practice. We are only allowed to start twice, and then we have to wait for the motor to cool down bago namin i-start ulit para hindi siya mainit na i-start ninyo, masusunog yung winding, right? When you use a VFD, you don't have that problem anymore because you're able to soft start. That means if you're able to soft start, you're able to start the motor more than 2 times. However, there's also the limit. Kasi kung consecutive na 3 beses, siguro umabot kayo ng 5, mag-iinit pa rin yung motor nyo. However, you are not limited to 2 starts per 2 consecutive starts anymore, right? And of course, when you have a VFD, because your horsepower is directly proportional to the torque and speed, that means you're able to operate that beyond its operating speed as well. However, you have to be mindful that when you do that, your torque requirement decreases. So if your system torque requires more or has to keep it the same below 60 hertz, then that means i-dederate nyo yung operation. But you're able to increase the speed beyond it. And when you increase the speed, what will happen? Your horsepower also increases. However, your torque will have a negative impact to it. So this is, may case po kami sa planta na existing yung pump, yung VFD existing din. And imbes na palitan namin yung pump, in-upgrade lang namin yung impeller niya para sa mas malaki. In that way, yung motor horsepower namin parehas pa rin. And ang ginawa na lang po namin, inoperate namin siya at a slightly higher speed to attain the horsepower that we require. However, you have to coordinate with your motor manufacturer if you want to do that because normally, lahat po ng design ng motor sa manufacturer, lagi pong may contingency factor. Hindi po nila sinasabi sa nameplate yon. Although, let's face it, kapag nagde-design kayo ng motor, laging oversized. Right? I mean, if you size for a particular motor design. Hindi ko sinasabi yung mechanical, yung brake horsepower nyo, i-oversize nyo yung motor to have that margin of torque, right? The motor design itself may sarili siyang contingency. And in our application where we had a 400 horsepower motor, we were able to operate that at around 4,450 horsepower by using the BFD. Okay, by increasing the speed. So of course, we did tests. Nagkaroon kami ng run test and everything. Mineasure namin yung temperature to make it sure that the motor will not overheat continuously. So it was able to withstand it by testing. So pinadala namin, dumating yung mga taga-Tico Westinghouse and they tested it and we were able to re-rate the nameplate. So the nameplate original is still there. We just have an additional nameplate for the re-rate. Okay. And again, you should have a good business case, especially when you're talking about medium voltage BFDs. Okay? Kasi mahal po ang mga equipment na to. So these are the other amenities you can call. It will reduce pump cavitation problems. Why? Because you're not throttling the line anymore. you're able to regulate the flow by regulating the speed itself. Okay. Of course, if you're not able to, if you're not throttling it, there is no pressure drop. You have energy savings there. But the main point there is the mechanical impact. Hindi po nagkakaroon ng water hammering effects. Hindi kayo nagkakaroon ng pump cavitation dahil mahal ang impellers ng pump na malalaki. Reduce and preventive maintenance costs by eliminating mechanical equipment. Like wala na kayong additional throttling valves and everything. By the way, if you have a throttling valve, you still have to maintain that. Okay. It reduces motor stress. You will have you are also able to do forward and reverse operation because the BFD has the functionality to do that. And normally yung BFD, kaya nga yung elevator natin, akyat baba, you're able to do a bidirectional control to it, right? Regenerative braking, okay? And you have other, so you're able to maintain the life of your mechanical equipment longer, okay? Ang pinakamahal po sa isang medium voltage BFD application is yung mismong dinadrive niya ng equipment. And that involves pumps, involves pipes, and valves. Or if you're talking about conveyor, then ang ino-operate naman niya is conveyor belts and all these things, right? So, mahalaga po na magkaroon po tayo ng magandang understanding when and when not to apply them. Okay? I got 30 minutes. So, typical VFD voltage power ranges, okay? I don't need to expand this further because may catalogs naman po. And normally, you can go up to 15 kV. And basically, kaya po 15 kV is may input isolation transformer kayo to step it down. Okay? Yung power range natin, in my particular case, gumamit kami ng 3 piraso in our up to 12,000. And you can go up to 20,000 horsepower, I think, nowadays. This is not updated. It says here 35 megawatt, but you can go up to 35 megawatt. Okay? Here's one configuration where we are calling it a synchronized transfer configuration. Okay? So in this case, yung isang VFD natin, let's say sa case na to, isa lang yung pump. So you don't need 2 VFDs or you don't need a transfer. Okay? Pwede mong i-operate lalo na po kung nagbabarya yung load ninyo lagi. Yung process requirement nyo, sinasabi niya, bariin natin. Okay? Pwede na ngayon kung naka-fix naman kayo, pwede kayong magkaroon ng transfer scheme. That means ginagamit niyo lang yung VFD niyo as a soft starter. Dahil hindi niyo magawa yan sa solid state na soft starter where naka-fix yung frequency at binababaan niyo yung voltage, so hindi niyo ma-attain yung torque. Okay? So minsan gagamitin niyo lang siya, gagamit kayo ng VFD just to soft start it, and then after that, kapag umiikot na po yung pump, then i-shift ninyo siya sa bypass. Okay? Para po hindi nag-ooperate yung BFD. So ginagamit lang po siya as a standby. So in this particular case, ginagamit ito hindi practical kapag isang motor ka lang. Okay? O sabihin na lang natin, okay, pag mine-maintain ko tong BFD, pwede kong i-operate direct online yung motor, right? So you're still able to operate. That was the concept originally. However, if you have already justified that you need this for variable operations at hindi ka makapag-fix operation dahil mapipilitan kang mag-valve throttling, which is may mechanical impact, then ano po mangyayari? So, ang sasabihin natin is, imbes na gumawa ka ng isang line, gumawa ka na ng redundant line, then maglagay ka ng 2 BFD. Right? The other item here, ginamit ito sa isang remote pumping system dito sa Canada. Meron silang 3 malalaking motor. So may justification na ini-start nila yung 3 motor na yon individually. So ginamit nila yung BFD bus to alternately start the 3 motors. So after they successfully start, then they ship everything to bypass. Okay? Minsan gusto nilang mag-ramp down dahil ayaw nilang magkaroon ng impact dun, water hammering or negative torque impact dun sa kanilang lines, pipelines. Ang ginagawa nila, ginagamit naman nila itong BFD to ramp down para yung hindi siya abrupt na mawawala. Ira-ramp down niya ng paunti-unti kung gusto nilang i-stop. So gagamitin na naman nila itong BFD during that purpose. And this is our cross-country pipelines. Okay? There is also an application where magkakaroon ka ng stepper. Let's say you have one pump 1 and then later on i-energize mo yung pump 2 dahil yung process requirement sinabi niya na oh itong particular process ko na to ito muna yung pump na gagamitin ko. Yung susunod na pump is para sa ibang process requirement. So nagkakaroon ng stepper operation, right? So ginagamit nila itong VFD so that magkakaroon ng synchronized transfer from napapasok si pump number 2. Kasi kung papasok si pump number 2, hindi mo naman pwedeng isize yung VFD para para ipasok si pump number 2 kasi nakasize lang siya para sa isa. At hindi naman practical na kapag one pump operation ka lang, i-size mo para sa 2 pumps. That means 50% lang ang loading ng VFD mo, which is not a good idea because it's not going to give you any cost. Your cost of buying it doesn't give you any value, right? So ang ginagawa nila, para magkaroon ng smooth transition when the second pump enters in a cascaded pumping system, what will happen is they will start the other BFD but these two BFD on this particular bus has to synchronize para magkaroon po ng bump magkakaroon pa rin siya ng fluctuation pero hindi na po siya masyadong spiky para magkaroon ng abrupt na transient yung torque ninyo sa line kasi nagpasok kayo ng isang pump. So they use this transfer configuration in order to have a near bumpless transition pag pumasok yung isang pump or kung nawala yung isang pump. Okay? Now, here's our topic created by one VFD. Okay? So, in this particular case, sa case namin, we have 2 motors. In our case, in the plant, tatlo yung motor namin na 400 horsepower. In this example, I'm using 2 pieces of 1,000 and there's one variable frequency drive. And of course, it's either operated by a circuit breaker with a protection relay or you will have a NEMA class E2 medium voltage starter. And this VFD will be controlling these 2 motors. If I say controlling those 2 motors, they're controlling them at the same time. Sa mata po ng VFD, iisa lang po yung nakikita niyang motor. Okay? Kahit po mag-trip yung isang motor natin dito, iisa lang ang nakikita niya. Kahit mawala po itong isa. Okay? Let's say may switch ako dito, in-isolate ko to, pinaandar ko tong VFD at 1,000 horsepower, isa lang po yung nakikita niyang motor. Kasi isa lang yung nakikita ng VFD is yung dinodraw na current dito. Hindi niya na-distinguish po kung iisa, dalawa o tatlo yung motor niya, right? So, in this particular case, pag nagkaroon po kayo ng isa pang motor dito, then ang nakikita ng VFD is 2,000 horsepower na motor. Kasi ang nadodraw din, we are assuming that both are operating at full load amps, right? Now, the problem is, paano mo normally kapag iisa lang po yung pump natin or yung motor natin, the VFD is protecting the motor itself. Kasi meron siyang protection system dito that it's able to see if there's a fault and then from there it will go into high current limiting effect. And what will happen is malilimit lang yung fault ninyo sa output to the overload capability ng VFD. Why? Because it's able to abruptly or reduce the voltage so fast that your fault will never, it will current limit your fault. Okay. Now, the reason why we are having, this is for the fault condition. So if you have 2 motor arrangement or 3, if you have a fault here, the VFD will see a high current. What the VFD doesn't know is yung temperature ng motor. Pag nag-overload na kayo, okay? Let's say nagkaroon kayo ng mechanical jam or yung process operator niyo pinataas yung flow rate to a point na to a breaking point. So nag-increase yung temperature ng motor, then in that case, we need to provide relays to it so that we would be able to distinguish kung aling motor ang nagkakaproblema. Kasi kung wala kayong relay, hindi sasabihan ng BFD kung aling motor ang nag-iinit or nagkakaroon ng overload. Okay? And that's why we need to have a relay here that will communicate with the VFD And at the same time, in this particular example, tripping the contactor. Sometimes we also have an arrangement where the VFD is going to command the contactor. For me, this is an older version of the protection system because what the VFD is able to regulate the fault. It's able to control the motor. So kung nagiinit na yung motor, mag-a-alarm na siya, yung operator magde-decide na siya to do action to it, to make an action, to bring down the motor to a level na hindi siya magiinit. That means I don't need to trip the system immediately because the VFD is able to do that and I can communicate with the VFD itself. So in that way, pagbibigyan ko muna yung VFD na gawin namin dalawa yung trabaho namin bago ko i-decide na i-trip yon. Of course, pag bagal kaming mag-act and umabot na sa tripping point yung temperature, then wala na tayong choice kundi mag-trip na yung contactor natin. Okay? So in applications, we also have the it's supplied on a conveyor system. So in this particular case, we have a common belt and meron tayong motor A and motor B sa conveyor. If the flow or the speed of this conveyor belt is the same, obviously they're all coupled in one belt, right? So magkaroon kayo ng isa pang conveyor ulit dito. Kunwari nasa planta kayo ng semento, right? In that way, you don't need individual BFDs to operate them, but you can operate them in one single BFD. Bakit? Kasi isa lang ang ibabato niyang voltage and frequency sa kanila. But it has to be designed kasi kung let's say 500 meters ito, they are 500 meters apart, or sabi wala naman sigurong isang kilometrong conveyor, right? So normally pinakamahaba yata nakita ko is around 100 to 200 meters. Yun yung malalaking ore plant sa Brazil, okay? So in this particular case, with proper design in terms of cabling, with the voltage drop and everything, you are able to control them with one single BFD. Of course, the rating of your BFD will be the additive or the sum of your total capacity. In that way, kapag nagbato ako ng flow rate na kailangan ko, at that flow rate, it has to maintain that speed or it has to attain that speed, then it will send a common signal and speed control to all the motors. Okay? In our application here, which is basically pumps, kasi nasa oil and gas extraction facility po kami, we have what we call, so in this is just an oversimplified of the plant, but pero malaki po ito, maraming process system po ito. However, if you see these lines, some of them, because of the malalayo po yung pinagbabatuhan nila, naglalagay po kami ng mga pumping systems. And those pumps are couple of pumps cascaded, operating in cascade conditions. Okay? So ito po yung ganito po kalalaki yung mga impeller ng pumps namin. Ito po nagbabato ng putik doon sa pan. Kasi yung process system po namin, may waste po siya in the form of a slurry. Kasi po yung ore namin dito, hinahaluan, tinitreat ng mainit na tubig with chemicals so that maka-extract kami ng bitumen. And that bitumen will be filtered into big funnel-like equipment, and then yung magse-settle po sa taas yung bitumen, and yung slurry and waste po magse-settle sa baba, and this is being pumped to a pound. Okay? In that, yung pan po namin malayo and malalaki po sila. Ang process po namin, yung footprint ng process system namin malaki, yung pan ang mas malaki. It will be like 10 times of it. And that's why the lines are so long that the head is so high. In that way, we need to put booster pumping station. And we are not talking about one pump here. We're talking about 3 or 4 pumps in series in the line. In that way, we are operating them in one single VFD. So here's like a flow diagram. So makikita nyo itong funnel like ito, teeny-weeny portion lang. And ito po yung pumupunta sa pan, itong pipe na to. If you see here, we got cascaded pumps. Why? Because probably this pump 1 and 2, and that pump there is like probably 2 kilometers apart or 1 kilometer apart. And the other two would be like another 8 kilometers or 4 kilometers apart. They are pumping into a pond where the pipes are distributed across it para po even po yung pag-dump ng slurry, para po yung beaching niya is maging even po. So in this way, we are operating these two in one VFD. This will be operated in one VFD dahil nasa malayong location siya. And this other two magkatabi lang, and nag-ooperate po sila ng isang VFD. In this particular case, we got 3 redundant lines, and that's why we don't need a bypass. In this particular case, kapag wala naman po kayong redundancy, ang nangyayari po, naglalagay sila ng bypass valve dito. Para kapag in-off ko to, dahil i-maintain ko, then iba-bypass ko siya. In that way, I have to oversize these pumps if I'm going to maintain the flow rate, or if process will say that we can curtail the process operation dahil i-maintain natin itong isang pump, then we can do that. You can put a bypass line here. Now, in my particular case, wala po kaming bypass kasi redundant po. Tatlo po yung system namin. Tatlo po yung pipes. So in that way, the redundancy is operating on a 3 by 33%. Or sometimes they even operate on 3 by 1 by 50. That means may isang line na laging naka-standby dahil nag-ooperate 2 out of 3 lines, right? So in this particular case, this is one example where we applied multiple pumping systems. One BFD to multiple pump motors. So this is just one example of an area. Ito po malayo sa planta at ito po yung boosting station po namin. If you see, these are the 2 slurry pumps. They are right in this particular location. I think these are 2 pieces of 500 horsepower. In the location that we just designed, actually TAR ko po siya, that was 400 horsepower, 3 pieces naman. If you see here, these pumps are in series. And these 2 motors are operated by one single BFD. Okay? So imbes na individual, isang BFD lang. Bakit? Kasi iisa lang naman ang control point ko sa kanilang dalawa. Okay? Here's a single line of one installation that we did. We designed here, and then we got that supervised installation in the plant. Na-commission na po siya. And we got 3 pieces of 4,000 horsepower. So I had a VFD with a capacity to run 3 pieces of 4,000 horsepower pumps, and they are rated, the VFD is higher than 12,000 horsepower in capacity. In this, because of their 4,000 horsepower, we are forced to use 13.8 kV. And we are taking advantage of the input isolation transformer here, so we can step it down. And each individual pumps here are 6.6 kV. Oh no, they are 6.6 kV because my output here is 7.2 kV. Okay. Ito po yung actual arrangement niya as per vendor print. And makikita nyo, meron tayong, ito po yung input, meron tayong isolation transformers, and makikita ninyo dito, multiple po yung windings. It's a special type of transformer where it is an 18 pulse BFD. That means 18 yung kanilang power cells, which is basically they are operating on a pulse width modulation, IGBTs. And ang ginawa po ng manufacturer is bawat power cell may isang winding sila sa transformer. And that's why for an 18 pulse divided by 3, kasi 3 phase, you got 6 power cells per phase. And each of those power cells are connected to one winding in the secondary. That means this transformer is an 18 winding secondary. 18 kasi ABC, 6 per phase. And each of these power cells are connected to those phases. In some design, they already employed this because they are able to individually isolate each power cells. That's the advantage. Kapag may nasirang power cell, mag-ooperate pa rin. Kasi ibabypass lang siya ng yung faulty cell, mababypass lang dahil kanya-kanyang winding yung mga cell. So ang isang failure ng isang cell, hindi magfe-fail yung buong BFD. So it adds to the reliability of the equipment. Kung 2 winding lang po siya, may isang power cell na pumalya, magsha-shutdown yung BFD. In this case, dahil hiwa-hiwalay ang winding, 1 winding per power cell, pag may isang bad cell, mababypass lang siya. May bypass contactor po yon. So this is the advantage of this design as well. Okay. At the same time, this transformer is doing a phase shifting. So nakakatulong sa harmonics. And if you see here, this is the inverter. This is the inverter N. And makikita nyo, mayroon tayong output bus section. And may isolation switches tayo, of course. And may mga CTs tayo dito. And going to individual relays that will communicate with the VFD controller. So these currents here will be measured for measurements to determine a current overload condition of any. And this way, dahil isa-isa silang nalagyan, kapag may nag-actuate, nag-alarm, malalaman namin kung aling motor yon. And then we will be able to adjust the process system in such a way that we will be able to operate this at say 60% para po itong isang motor na to may tendency po kami na pwede namin siyang i-isolate. Okay? The other thing is there's also resistance temperature detectors on each motor measuring the temperature, operating temperature of the winding of the motor and the bearing. Connected din po sila sa relays. And this will provide the thermal modeling for the BFD protection. Pag sinabi kong thermal modeling, it is trying to replicate the actual motor operating condition by its own algorithm. Okay? So parang minomodel na niya yung motor at minomodel niya yung thermal model ng motor. Kasi dalawa, ang kalaban po ng motor natin is hindi current. Ang kalaban po niya is heat. So mas magandang i-protect nyo yung motor in terms of heating. Kasi heating ang kalaban ng insulation, di po ba? Okay? So if I'm going to, and here's the single line diagram. So in this particular application, galing po siya sa isang switchgear. Meron po kaming protection relay doon. Okay? In this case, we were using GE F35. Okay? And ito po yung BFD namin. Tatlo yung output niya. Ito po yung BFD mismo. So makikita nyo, ito po yung input section. Andito yung control section natin. Kasama na yung mga relays. Kaya tatlo kasi tatlo yung motor. And ito po yung input section. Itong malaking section na po dito na may malaking door, ito po yung sa transformer. Okay? Ito yung dry type transformer. And then the power cell sections and then the output section. Pero yung mga controllers po niya, nandito sa isang nakahiwalay po siya. So lahat mo ng low voltage controller nandito, lahat po yung mga power, high, medium voltage conduct or equipment nandito po sa left side. So mahaba po itong lineup na to. Okay? So in this particular case, we also have a feature that we employ Kirk key switching. And the reason why we apply this, kasi imagine ninyo na maraming doors yan. And for you to access them, you need to follow certain isolation procedures. And due to human error, the tendency of human error, we have provided key interlocking system facility so that we want to make it sure that everything is isolated and before we start opening the doors. Okay? Ito po yung Kirk key switching namin. So kung makikita nyo, yung pinaka-input breaker, so I would like to explain this because when you know about this, then you can apply this to anything. Pwede nyong gamitin sa bahay nyo. Okay? Okay. So if we have this circuit breaker, it's feeding this. So what do we do first? We need to open if we want to access this BFD, what we will do first, we will de-energize. And for you to de-energize, you have to open this breaker, right? Main breaker. Well, it shows here low voltage. Mali po ito. Ang medium is square. Okay? Anyway, kapag inopen ko po itong breaker, magre-release po yung susi dito. Yung susi na yon, dadalhin ko po dito sa BFD at may sususihan ako dito dahil may pre-charging circuit po yung BFD. That means may 600 volts po kaming pumasok pa. And from there, para kailangan i-isolate din namin yung pre-charging circuit. And that's why we have to go here, isolate the pre-charging circuit, get the key here to access the pre-charging key interlock. And then if we switch this, what time is it? I think it's already 11:23 in the Philippines. So let's say we're close. So if we go here, we release that key and go to the other key that will allow us to open this breaker. Once this breaker is open, another key is released. And then, once we go here, we release this key. We go to this key in box here, and then from there, we're able to isolate the pre-charged circuit. We release another key to go to the input isolation, output isolation switches ng mga motors natin. We isolate that. Once we insert that key, we're able to operate the switch. And once we open the switch, it will release another set of keys that will go to this main key system. Kapag na-insert ko na po tong key na to na na-release ko dito dahil na-isolate ko na po yung power, na-isolate ko po yung pre-charge, and na-isolate ko na po yung motor na gusto kong i-isolate, and then I'm able to release all these keys. And these keys will give you access to all the compartments in the BFD. In that way, you're pretty sure that there is no positive voltage inside. Okay? Then all you need to do is operate the grounding switch para i-bleed po ninyo lahat ng capacitance doon sa switchgear. Dito sa BFD, sorry. So, key interlocking is very essential if you have a multi-compartmentalized equipment. Okay? So makikita nyo dito, marami kaming mga susi dito. So makikita nyo yung pinakadulo doon. Ito yung malaking box na makukuha ko to para ma-isolate ko. And then pag binalik ko yung, makuha ko yung lock doon sa output switches, ilalagay ko dito, magre-release na lahat yung mga susi dito. In that way, ma-open ko na lahat ang compartments. Ganon din po kapag binalik nyo sa dati. Kailangan ibalik, reverse naman yung paglagay nyo ng mga switch. So that means you cannot operate your breaker upstream unless lahat ng switch may sauli mo lahat. Okay? And that means, ibig sabihin, na-close mo na yung mga doors. Ibig sabihin, na i-close mo na yung mga output switches mo. That means, yung input switch mo na i-close mo na rin bago mo pa i-energize yung breaker. Okay? So these are the topologies that I mentioned a while ago, those multiple windings. And the good thing about these multiple windings is that we are able to continue operation kahit magkaroon kayo ng isang failure dito sa power cells. Okay? Yung mga IGBTs nyo. Kasi kung hindi po ganito, dalawa lang yung winding, yung failure ng isang power cell, magsha-shutdown yung buong BFD. Okay? And this is a single line. So we got the output, a vendor single line. Okay, kung makikita nyo, may relay pa rin tayo dito. Ito, isang motor lang to. But just imagine, ang kaibahan lang, magkakaroon kayo ng tatlong motor, tatlo yung GE relay ninyo dito. So this will provide the RTD sensing. It's the same time, it gives you also the current inputs so that pag may isang motor na mag-overload na on current, mag-a-alarm. And then you're able to distinguish which one. Okay? So you still need that. The VFDs look at it as one single motor, but your protection system is able to tell you as an operator kung alin ang na-overload. So these are single unit VFDs. So meron kang input isolation switch, meron kang input transformers, dry type, ito yung nasa baba. Of course, yung mabigat nasa baba, yung mas magana, ito yung power cells nyo. And then this is your output switch. If you see, there's also the relay there. And then ito yung cooling system nyo. And this is the configuration. Okay? So ito yung sinasabi ko, kapag nawala yung isang cell, anong mangyayari ang gagawin ng BFD? Magkakaroon ka ng unbalance kasi nawala yung, let's say, nawalan ka ng tatlong phase A cells. Anong gagawin ng VFD? I-isolate niya ngayon yung dalawang cells dito. Madederate ng konti yung BFD mo, magsesend ng alarm, it gives the operator, titignan ng operator kung ibababaan ba niya yung ng konti yung process flow or i-maintain niya dahil oversized naman yung BFD. Okay? Same thing here. These are the power cells. Again, this is the thermal modeling. And ito yung I will provide this the PDF copy of this because this is also an information that I added. So ano ba yung mga considerations na kailangan yung your VFD going to be the right choice or not? Okay? So ito yung mga consideration nyo. May standard muna po tayo, IEEE 1566 to discuss VFD requirements and specifications. This 1566 is not published yet, I think. It's still ongoing. And then there's the safety of having the BFD. Ito po yung mga justifications nyo na kailangan yung i-check to justify buying a BFD for your particular application. Yung topology, yung BFD performance, input tolerances, these are requirements on the BFD that you need to follow, that you need to consider. Yung withstand niya sa voltage transients, voltage sags conditions, noise and harmonics, controls, bypass operation if you need it. Normally, in my particular case, I don't need it, but I need power cell bypasses. Your input isolation, which serves as your input impedance, your cooling system requirements, and whatever is your interlocking scheme with the upstream switch gears. And of course, your driven motor. Okay? Somebody asked me before, pwede bang gumamit ng non-inverter duty na motor sa BFD? Yes, you can use it, but you have to make it sure you're gonna oversize it a bit. Dahil pag nag-decrease po yung speed, magdi-decrease yung cooling system ng motor nyo. Okay? Sa likod ng motor nyo, may fan. Pag umina yon, iinit lalo yung motor nyo. So you have to somehow design your motor, you oversize it a bit. So, maganda ba na i-oversize nyo? Or lagyan nyo ng forced air cooling? Or are you going to buy an inverter duty instead? Then you keep the same horsepower, mas matalaki lang ang size niya, frame size niya, dahil kakapal yung insulation niya and mas lalaki yung ventilation system niya. And of course, the factory testing, you need to be mindful when you're doing your specs for the medium voltage motors, medium voltage BFDs, you have to consider all these things, especially the documentation part. Hindi yung binentahan lang kayo, tinakbuhan na kayo, bahala na kayo sa buhay nyo. No, you have to ask everything. And that everything is embedded into this presentation that I did. So ito po yung mga suggestion na kailangan ninyong i-consider sa material requisitions ninyo to make it sure that when you buy a sucker like this na napakamahal, napakahirap i-transport, pag pumalpak, ang hirap palitan, you have to make it sure that you have everything in your disposal. Documentation, warranty, service. O maganda bumili ng BFDA na to. Kaso ang service niya nasa Italy. Right? So, bibiyahe pa yung mga yon papunta diyan. Samantalang, let's say, kung may base na sila sa Philippines, then konti lang ang gastos, di ba? Kasi nandyan lang yung services. So you have to consider all these things. Hindi lang po yung application and everything goes to your purchase orders. You have to make it sure that you are considering all these points, not only technical, but also the non-technical requirements, which is what? Documentation, services, warranty, spare parts, all these things. Training ng gagamit sa BFD. Napakamahal po na manghihila pa kayo ng vendor representative para lang i-troubleshoot yung BFD nyo. You have to get your people trained. And how do you do that? You have to include that in your purchase order. Or you can make an agreement with the vendor na in this X number of months, they're gonna train your personnel, parang i-operate muna nila, and then from there, they're gonna switch over later. Parang build, operate, transfer scheme, right? So you need to consider all these things when you are dealing with very expensive equipment. Yung mga malilit na equipment, madali lang, nagkamali kayo, takbo lang kayo sa warehouse. This is not something you can just go and run into the warehouse. And by the way, these guys are very heavy because of the dry type transformer. So strategically, you have to ask your question. Somebody asked me before, paano sir pag nasira yung transformer? Mas mabigat pa yung transformer yata kesa sa building, right? How are you gonna take it out? Well, historically, the transformer is the most reliable equipment in the BFD. The less reliable are those power cells, and they are magagaan lang. So yung transformer nyo, baka masunog na yung BFD, yung transformer nyo nandun pa, dry type. Kasi yun ang pinaka heavy, but it is the most reliable piece of equipment in your BFD. Okay? Thank you very much. I know I exceeded 3 minutes. Sorry about that. And yeah, I think I should conclude my presentation now. So if you have any questions on the application, and by the way, but before I will entertain question is, somebody asked me, bakit tatlo yung motor ko? Okay, yung case po ng line namin kasi, ito, yung pipe namin, iisang pipe lang yan. Yan yung nagtatapon ng dumi doon sa pan, galing sa process system. yung aming process system is such a way na minimina, and then from there, hahaluan ng tubig. Kaya nagkakaroon kami ng iba't ibang waste. May coarse, may fine, may medium. So yung mga bato-bato namin doon sa pump box, minsan malalaki, minsan maliliit. So depende po sa process system. Kapag nataon na malalaki, mas malaki yung bumping requirements na kailangan namin dahil mabigat yung slurry. Kapag maliliit naman, dahil yun ang gusto nang i-produce ng process, then mas maninipis yung slurry. That means hindi namin kailangan ng tatlong line na nag-ooperate, baka dalawa lang. And that's why, because of those highly variable process systems namin, and this is just one example, doon po rini-require yung BFD. Okay? Sa case po ng conveyor, kung iba-ibang laki ng bato ang kinakrush ninyo, isang araw ito yung gustong bilhin ni China sa inyo, ganito kalalaking bato ang ibabagsak nyo sa conveyor, right? And then the next day, si client niyo naman sa US gusto niya yung ganitong kaliliit na bato naman. So mag-iiba yung flow rate ninyo, mag-iiba yung torque requirements nyo, and this is the way you justify the process business. Thank you, and magandang umaga po sa inyong lahat.
Thank you very much, Engineer Beltran, straight from Canada. So, sir, due to our time restrictions, may we request if you can just reply to all the inquiries and questions through the chat box, sir?
Is this the one on the Q&A chat box?
Yes, sir.
Tatatlo lang ah.
Okay. Yes, sir. And
okay.
some are found on the chat box, sir.
Oh, no. 71. Oh, my goodness. Is
yes,
this 71
sir.
since the beginning or sa akin lang?
Since
okay.
the beginning po yan, sir.
Oh, thank you. Okay, kung thank you lang nang naka-post doon, but you can extract those, can you extract those questions? Send it to me and I'll try to answer them
yes,
in an
sir.
email.
Yes, sir.
I will answer these three now. Sir Primo, operating motor is constant kVA. It can contribute short circuit. Does the motor running in BFD considered a static load, as this not will be lesser than short circuit contribution? Okay, thank you. Okay, to answer this question, yes, the motor is a constant kVA when it is running. Okay, now does it contribute short circuit? Yes, if you are going to connect it direct online, it will contribute because there is nothing that's stopping the current to go into your system. In a BFD condition, you have a separately derived system. Bakit? Because your AC is being converted to DC, and then from DC, it converts back to AC. That means because of the power cell and the power conversion within the BFD itself, it's able to current limit your fault. So, is there a fault on your input on the BFD? I would say you don't even need to consider it. It is actually zero. Or kung meron lang po, it will be very, very small. Especially if your fault is on the input, kung saan siya pumasok, nag-terminate, yes. May fault na ma-generate, but it will not be a contribution from your motor. It will be coming from your utility. Okay. Now, if you have a fault on the motor itself, on the output side of the BFD, the current that you generate, the fault that you generate there is only limited to the overload capability of your BFD. Why? Because once there is a fault, your BFD will switch the current and voltage will adjust them. It will be current limiting. So what will happen is, kung ang overload capability niyo is 200%, then your current maximum at the output is going to be 200% of your full load, of your BFD full load current rating. Okay, not the motor, but your BFD full load current. There is no contribution on the input. Okay, the only exception, if you are going to operate the BFD as a regenerative drive, which is what you use when you are using an active front end current configuration, current source, hindi po siya voltage source. So this is a BFD that you use on your elevators. Pag may regenerative braking, pag may regenerative control po kayo sa BFD na nakaset, then that means your BFD will have the capability to contribute to the fault. But is it going to be the total fault current coming from the motor? No, it will be a bit less than that, but it will contribute. Next, since intensive BFD operation can produce harmonics, is there a product that you can recommend to control these harmonics that can adversely affect the electrical system, or the input isolation transformer is enough? Okay, let me tell you this. It depends on how many pulses. So mostly in a harmonic order, the most offending one are the odd harmonics. And within the odd harmonics, the most offending one in terms of magnitude is the third, the fifth, the seventh, all the way to say 15. Okay? Kasi pag tumaas po kayo more than that, lumiliit na po yung harmonic content. Ang malalaking harmonic content is nandun po sa mga third, fifth, 7, 13, and 15, or probably 17 as well. Okay? Now, pag nagkaroon po kayo ng resonance, na-amplify po yun. Kaya yun ang problema pag nagkaroon ng resonance. But if you don't have any large capacitors in the system, wala pong bihira po magkaroon ng resonance. Nagkakaroon lang po ng resonance kapag meron kayong malaking capacitor na mag-equal siya sa inductive impedance, and magkakaroon kayo ng parang short circuit like na harmonics. Ma-amplify siya. Parang current, pag nagkaroon kayo ng fault, ma-amplify yung current, right? Because yung impedance nyo biglang bumagsak. Sa isang resonance condition, yung inductive reactance nyo saka yung capacitive reactance nyo nag-equal kasi umabot siya sa resonance point, mag-amplify. Now, to answer your question directly, each BFD will already have a harmonic mitigation because each BFD has to comply with the industry standards. And the industry standards, I think, is saying thou shall not exceed 5%. So the manufacturer will try to design better than that. So normally, nagde-design sila ng 3% or less. Now, is it going to make a problem? I don't think so. Kung isa lang ang BFD nyo. Imagine if you got 3% and you got like 10 of them. Magkakaroon ba ng problema sa harmonics? Probably yes. And this is where you have to conduct a harmonic study. You have to calculate, right? And I think there is a rule of thumb in IEEE that says na kapag ang rating na ang capacity ng nonlinear loads nyo is around more than 30% ng transformer rating nyo, you have to conduct harmonic assessment. Okay? So that's what I'm trying to say here is the BFD has already an inherent harmonic limitation to comply with standards. Now, let's go to the pulses. Kapag sinabi natin na 6 pulse, ano ang maka-cancel niya? Anything plus 1 and minus 1. Right? So that means anything one step higher and one step lower. So that means pag may 6 pulse kayo, maka-cancel niya yung 7th and 5th harmonics. And by the way, sinabi ko kanina, 5th and 7 ang pinaka-offending, and then 3rd, and then so on. So anything 3rd harmonic and 5th harmonic will be mitigated by the 6 pulse BFD. Now, mamimitigate ba niya yung 13th order or 15th? No. That's why when you put an 18 pulse or a 12 pulse, then anything below 12 will get mitigated and 13 will get mitigated as well. Can it mitigate 15? No. Then you need 18 pulse. Habang lumalaki po yung pulse nyo, nagmamahal po yung BFD ninyo. Okay? Kasi dumadami yung inyong mga power cells. Okay? So when you have in our application in the plant, gumamit kami ng 12,000 horsepower BFD, which is the output is 7.2. We use 6.6 kV motors and 13.8 sa primary. Gumamit po kami ng 18 pulse. In that way, anything below 18 order is already canceled. Plus, we are able to cancel 19. And based on the harmonic spectrum na natanggap namin sa vendor, lumalabas yung aming 19 and above, maliliit na current na lang. So, mag-resonate man sila on any of those harmonic order, hindi po siya mag-amplify ng malaki kasi maliliit na lang po na value sila. Okay? That's why you need to create, you have to do a study. You have to request the harmonic content of your BFD, yung spectrum mismo. Wag niyong kunin yung curve kasi magtatrabaho pa kayo doon, ipla-plot niyo pa. Kunin niyo na naka-table. Sabihin nyo sa vendor, bigyan mo ako ng tabulated harmonic order nitong BFD na in-order ko from 1 to 30 or 1 to 60 or 1 to 90. Okay? In that way, kapag 6 pulse kayo, then kunin nyo yung harmonic spectrum. Pag 18, kunin nyo pa rin, pero I don't see any problem. However, like I said, kung isang BFD kayo, walang problema. Paano kung may 10 piraso kayong ganung kalalaki? So, i-add mo lahat yon, baka magkaroon ng problema, right? So that's why in those cases, you need to conduct a study. Hello, sir. What brand of BFD you will recommend? I cannot recommend any brand, sir. I'm not in the position to do so. Okay? Magiging unfair po sa mga manufacturers. Okay? Hindi po ako makakapag-recommend. It's not ethical. Okay? It's not ethical for me to do it. And unfortunately, you have to find that out yourself. You talk to the manufacturers. And honestly, marami kayo makikita sa mga planta. And I think we're going into that direction now. Kasi nung una kasi, yung BFD, mga 70s, nung nagsisimula pa lang sila, malalaki sila, mahal, and syempre, nung nag-uuna pa silang lumalabas, trial and error, right? Parang software. Lumabas yung Windows, ang daming kapalpakan. Kailan naayos? After a couple of years, right? Ganon din yung BFD. Pero nag-evolve na po ang mga VFDs. And that's why the acceptance of BFD in terms of cost against the loss of production, against the tear and wear of mechanical equipment is already justified. Thank you.
Hello, Sir Prime.
Oh, may isa pa.
Hello, Sir Prime.
Yeah.
Yes, as much as we also would like to hear all your answers, but due to time restrictions, can we request that you answer the questions through chat, sir?
Yeah, sure.
Okay, thank you very much, sir.
And can you filter out the thank you portion? Okay? Yung
Yes,
question na
sir.
lang i-extract ninyo.
Okay, thank you very much, sir. Now to proceed with our awarding of our Certificate of Appreciation, may we call on stage our Secretary General of Metro Manila Region, our Governor for Metro Manila Region, and our Chapter President of Metro West. The Certificate of Appreciation is awarded to Primo G. Beltran Jr. in grateful acknowledgement and appreciation of his invaluable service and professional thoughts shared as a research speaker on the topic about multi-motor MVVFE application during the IIEE 7th Metro Manila Regional Conference, a hybrid event with the theme Got One IIEE at 46, transcending the challenges in the new normal by embracing resiliency and complementarity. Signed by Engineer John Regis Estrosio, Engineer Giovanni F. Tagata, Engineer Manuel M. De Guzman, and Engineer Alwin M. Wagan. Once again, thank you very much, and let's give Engineer Primo Beltran a round of applause. Sir, one IIEE daw.
Oh, paano ba yung
Okay. Thank you very much, sir.
Once again, thank you very much, Engineer Beltran, and we will now proceed to our next presenter. So we have from Schneider Electric, the Digital Service Leader, Services Business of Schneider Electric, and the Offer Marketing Manager, the Digital Energy of Schneider Electric, Engineer Joshua Luzon, and Engineer Ian Torres. And we also have today as well, Tanya Tioseco, the Senior Marketing Communications Officer for Power Products Home, Distribution, Industrial Automation, and Digital Energy from Schneider Electric Philippines. So please watch this video.
Rick. I'm the Offer Marketing Manager of Digital Energy portfolio of products. So we are going to share with you today the EcoStructure Power solutions of Schneider Electric. This pandemic accelerated the shift to more digital solutions, and we, as electrical practitioners, have to keep up with this trend. Our agenda in this session, we will start with the power monitoring expert, or shall we call PME. We were going to discuss its value proposition, some of its applications, and sample system design to give you an idea on how you can implement such a system in your site. Then we will also cover advisory services like Power Advisor and Asset Advisor to be discussed by my colleague Joshua later. So let's proceed. So what is power management? You can think of it just like a dashboard in your car. So when you drive, you can see your speed, fuel, indication and temperature, and for some of us, they have GPS. These parameters give you feedback whether you have to slow down or change gear, turn right or turn left. A power management system is like that. It gives you an ongoing measurement or feedback about your power distribution system. So it can help you analyze what is going on, and eventually it will help you decide on what to do with your electrical system. Power Monitoring Expert is a solution that integrates electrical equipment, which we call in Schneider as connected products, and it is connected to the PME, which is the software layer we call Edge Control. It is complemented by apps and analytics services like the Power Advisor and Asset Advisor, which will be discussed later. The integration makes our power system safe while ensuring power availability and business continuity. And the same solution also allows us to maximize the efficiency of our operation and simplify regulatory compliance. And talking about compliance, so PME can help you to be RA 11285 compliant. So this is very relevant to those considered as designated establishments who consumes at least 500,000 kilowatt hour of electricity per year. So PME, as an ISO 50001 certified energy management data, can simplify baselining and even benchmarking of your facilities energy use. And as an ISO 50001 certified software, you are assured that the energy data is accurate and can pass any internal or external audit. The intuitive dashboards and reports can also simplify your energy review. And there's no need now for PowerPoint because with PME, it simplifies reporting to the management. So PME has various applications to ensure safe and reliable operation of electrical distribution system. You can use the application depending on an installed hardware. So due to the limited time, let's focus on power quality monitoring and energy usage analysis. For power quality monitoring, a PME can help you track harmonics in your electrical system in order to prevent and avoid electrical fires and even unwanted disturbances. With the right PQ meter, like a PM8000, it can help you detect the direction of power disturbances. It can tell you if the fault happens outside the facility due to the utility, or if it happens within your site, which is a big help whenever you have to do root cause analysis during a power quality event. When it comes to energy management and under the RA 11285, facilities are required to implement energy efficiency measures. PME can easily track the performance of your energy efficiency projects because of its reporting capabilities that are not usually readily available with the typical SCADA or even a BMS system. So now I'm going to share with you sample implementations on how you can do it in your facility. You can start simple and build from there. The minimum you need would be the power meters with Modbus communication capability and a gateway that can also act as a data logger. From there, you can get the data using either your laptop or even your office computer if you're on site. When you are ready, you can even centralize your monitoring system by adding the software layer, the PME, and depending on your size, you might even need an SQL server. In some installations, we can also do this in the cloud, depending on the IT requirements for your facility. As an energy management system, we can integrate other parameters like water, air, or compressed air, gas, and even steam using a PLC that is connected to our power monitoring system. In this way, you will be able to monitor your whole energy management consumption, and it will help you manage your monitoring and regulatory compliance easily. Now let's move to the power advisory solution. In a recent market survey that we conducted, Schneider found out that about 25% power management systems are outdated. And the electrical equipment like circuit breakers, meters that are connected to those systems are about almost obsolete. This is where power advisory comes in. It is meant to help facility managers, maintenance and engineering team to ensure power reliability by using advanced analytics and the services of the experts. So how does it work? First thing we have to assume is that you have a working power monitoring expert because that is where all the data comes from. So the advisory process works this way. First thing, all the data will be reviewed. So the system, the analytics will check if there are gaps, if there are errors with the data, and from there it will generate and identify problem points and come up with a report. And with this report, this is the time where the advisory and the analytic services will provide solutions which can be presented to the customer in order to allow the customer to act and improve the whole system. This is the overview of the power monitoring expert with power advisory services. Now, I'm going to shift the presentation to Joshua, who will discuss the asset advisory services.
Thanks, Ian, for that overview on how we help our customers manage their power using power monitoring expert and power advisor. So good day, everyone. I'm Joshua Reginald Luzon, the digital services leader for Schneider Electric Philippines, and I'm here to talk to you about condition-based monitoring and maintenance via EcoStruxure Asset Advisor. So Ian has presented how to effectively manage power inside a critical facility using PME and Power Advisor. And now I'm going to present how Schneider Electric can help you maintain your assets and adapt a condition-based type of maintenance. With all the technologies that are emerging today, it enables us how to move into condition-based maintenance from the traditional reactive and preventive maintenance. But what exactly is reactive maintenance? So as the name suggests, it's a type of practice that you only react when failures happen inside your facility. So it's more of a break fix type of intervention, whereas preventive is the maintenance that we do every year, like a periodic checkup or a periodic medical checkup. All right. So condition-based maintenance, on the other hand, is very prescriptive in terms of its approach, and it's actually predictive in a sense that we can predict when failures will happen, what will be the cause of the failure, and how we can mitigate the failure. So we don't have to go for a periodic checkup since we have monitoring of our real-time status through monitoring and analytics. All right. And this brings about a lot of peace of mind and of course cost savings through optimization of the maintenance scheduling. So instead of having a preventive maintenance every year, we can move it to 3 to 5 years periodicity, right? So just some case in point, take the case of a cell site or a bank branch, for example, with many electrical and mechanical assets. The usual process is that if there are alarms on the units, the facility manager will call the maintenance provider. And then the maintenance provider will do at least two site interventions. So the first site intervention is for the initial checkup of the facility, and the second visit is for the resolution. And sometimes it takes more if the problem persists. So just to highlight some of the pain points with the current maintenance practice that I have just shown. So of course, on-site examination requires a lot of power shutdown, as well as it's very time consuming. Of course, the data that you have is very static. So the on-site maintenance team have a limited view of the data, which can increase the failure risk. And number three is that it's a very periodic inspection and it's not based on the actual existing conditions of the actual asset, which can result in extra costs over time. So now let's take the case of a condition-based digital maintenance practice in which we're going to install sensors on site and make the equipment communicable. Aside from that, we can enable remote expertise and monitoring from Schneider Electric so that when there's an alarm on site, the Schneider Electric team will be notified, all right? And since the provider now knows the alarm, he can prepare ahead the needed spares or kits to solve the issue, and he will be bringing them on site to solve the issue on one visit only. So of course, this optimizes deployment cost, which is related to the cost to maintain. And of course, it provides a quick mean time to repair or MTTR for quick issue resolution. So the scenario I just presented is actually how EcoStruxure Power is empowering our customers to do condition-based maintenance. So at the heart of EcoStruxure solution, of course, as Ian mentioned, are connected products, which just means that all of the products that are produced or manufactured by Schneider Electric are actually communication ready. And of course, Ian mentioned about the edge control device that we have, one of the example, power monitoring expert, which actually manages the data that we get from the connected products and create those dashboards and reports. But the value of the EcoStruxure brand, which is the IoT platform of Schneider, is on the third layer, in which we take advantage of the data that we get from edge control and connected products and transform them into actionable insights using our advisor layer. So Ian has mentioned about Power Advisor, and now I'm going to talk about Asset Advisor. Okay, so one example of the connected product from Schneider Electric is the real-time thermal monitoring device that could be used as a great substitute to thermal IR scanning that we usually do on site. This device is called ESERG TH110. It's a wireless temperature sensor that can be integrated to bus bars and wires to measure both thermal data in real time. So since it's wireless Zigbee communication, it's also approved by the NTC for operation in electrical distribution sites and withstand 150 degrees Celsius of temperature. So this sensor is applicable up to 52 kilovolts and up to 6300 amperes. So most of the explosions inside an electrical distribution equipment usually begin with an increase of temperature. So it's very important for us to monitor this parameter using this sensor and put it on our critical equipment and take advantage of that data to make decisions ahead of time. Another technology that we're using is for rotating equipment. It's called motor current signature analysis. And this is what we use to actually predict failures in motors. And it's quite different from vibration analysis. And we selected the solution because MCSA is more accurate compared to vibration analysis method. Of course, it's also easier to install because you only install it on the motor control cabinet. So it's very useful in harsh environments and ATIC zones like in oil and gas. And of course, it's one solution that identifies both electrical and mechanical problems. So it can definitely help lower down also your energy usage. So MCSA consists in capturing the current and voltage measurements from the motor and translate them from the time domain to the frequency domain using Fourier transform. And this actually breaks down the incoming signal into its component frequencies. And from that, we can detect the deviations from the normal conditions using our machine learning platform. So the result of all of these machine learning is, of course, the detection of issues up to months before it happens, giving you peace of mind and enough time to react before any incident happens. So this is an example of how we can integrate both electrical and mechanical equipment to the platform. All of the sensor data can be gathered by our cloud platform, all right, as shown here. And we will do the analysis for you. And you can also have the option to have a local monitoring for yourself. But with EcoStruxure as advisor, you will have 24/7 access to our equipment and system experts, our data analytics platform, and our multi-product and multi-year expertise in electrical distribution through your fingertips. And of course, our end goal is to mitigate issues and prevent downtime to provide you operational and financial efficiency by lowering cost. And of course, safety, which is the number one priority of Schneider Electric. And this is the end of my presentation. For any questions, don't hesitate to raise them on the chat or visit our virtual booth today. Thank you.
Once again, thank you very much to Engineer Joshua Luzon and Engineer Ian Torres for the topic Innovation Talk, EcoStruxure Power. So we will now proceed to the awarding of the Certificate of Appreciation. Certificate of Appreciation is awarded to Engineer Ian Torres and Engineer Joshua Luzon in grateful acknowledgement and appreciation of his invaluable service and professional thought shared as the resource speakers for sponsored technical presentations on the topic entitled Innovation Talk EcoStruxure Power during the IIEE 7th Metro Manila Regional Conference, a hybrid event with the team Got One IIEE at 4 to 6, transcending the challenges in the new normal by embracing resiliency and complementarity. Given the 7th day of August 2021 at the IIEE building, Cubao, Quezon City, and via Zoom cloud meetings. Signed by Engineer John Regis Estrosio, Engineer Giovanni F. Tagatak, Engineer Manuel M. de Guzman, and Engineer Alvin M. Walton. Present here with us is Engineer John Regis Estrosio, Engineer Manuel de Guzman, and Engineer Giovanni F. Tagatak. Congratulations to our resource speaker.
Okay, so to all our delegates, if you have any question, you may visit the booth of our last sponsored technical presenters. And now moving forward to our next technical speaker. He graduated Bachelor of Science in Electrical Engineering at Mapua Institute of Technology. He has also been granted of Level 1 and Level 2 Institute of Infrared Thermography certification in 2016 and 2021. He has been known for his topics of expertise such as electrical thermography, thermal scanning, power transformer maintenance, and standard and comprehensive transformer testing. He was a former design engineer at Hyder Consulting in 2013 and 2014 and a former test and applications engineer of Wesco Electrical at 2014 to 2016. He is currently the professional consultant of LM Power Engineering Corporation and MCEI and the operations manager of XQ Electrical Services and Supplies Corporation. He is also the vice president for technical affairs of IIEE Metro Central Chapter. Ladies and gentlemen, let us welcome Engineer Juan Paulo M. Tolentino.
Wait lang. Ay, yan ma'am. Hello? Hello ma'am? Malinaw ba ma'am?
Yes,
Yes, sir, we can hear
Okay,
you.
yan,
And
sige.
a reminder to our delegates before you start, sir, that we will be having a 15-minute break after the presentation of Engineer Tolentino.
Sige. Yan. Ma'am, nakita niyo naman yan, yung presentation.
Yes, sir, we can see the presentation.
Shall I start na ba ma'am? Okay na. Okay. Sige. Yun. No. So, good afternoon, everyone. So, again, I am Paolo Tolentino. Your next speaker for today. No? Okay. So, I'll talk about infrared thermography. So, a full scope application in an electrical system. Actually, for some, no, I know you've seen me already with this talk or with this topic. So, isa kasi talaga to sa mga lagi nating tinutok. Because yung importance kasi niya, especially sa electrical system natin, is for me it's very important, and I really need to share things like this, no, para sa ating mga taga-IIE and of course sa electrical industry natin, no. So I have a 45-minute talk with this one. So actually ginawa ko yung presentation na to more or less parang I have yung mga basic questions na laging natatanong sa akin. So yun yung mga sasagutin natin, no. So technically we have yung parang mga facts lang, no. So mga frequently asked questions. So let's try to answer those things, no. Okay. So to start lang siguro, wait, answer ha. Sige. So to start, no, so again, I am Paolo Tolentino. I'm a PEE, no, by profession and by heart. Wala pong pumilit sa akin. So hindi po ako napilit ng aking magulang or ng aking kung sino man. So yun talaga ang kagustuhan ko. I'm also a level 2 certified thermographer. It's actually, my certificate is based from IRT Canada. So yung mga mentors ko sila Sir Ron Newport, Sir Jim Seferin. Yeah. So if you want to email me, that is my work email or my personal email. Okay lang din naman. Yeah. So I am the manager for XK Engineering and Empower and consultant from MC Engineering. Sige. So work history, no, since 2007 actually sumasama na talaga ako sa mga maintenance, no. So that is one of my forte talaga. So sa testing and commissioning side kasi ako more on sa preventive maintenance. And after a while, mga 2015, 2016, doon ako nag-expand ko ng sarili ko for thermal scanning naman. So nakita ko yung importance niya and nakita ko yung yung mga basic na nagagawa niya sa not just for preventive maintenance but syempre yung sa everyday usage natin, no. Okay. So how important is infrared thermography? Now, to answer this question, ito yung mga basic questions lang natin, yung 4 questions na to. So what is infrared thermography first, no? So what is infrared thermography? Technically, ito yung tinatawag nating basically, no, ito yung kumbaga measurement of our temperature. So ano ba yung temperature? So lahat naman tayo, no, may temperature tayo, no. Yung mga basic temperature natin, if it's the hotness or coldness of a specific object. Okay, so technically that is what we're trying to do in thermography, no. So kung thermography man to infrared, we can do spot measurements, we can do yung sa camera naman, so we can see the thermal the thermal patterns of each na tinitingnan natin palagi. Okay? So, kung sa basic lang din, no? So, when do we need this? Okay, actually everyday lagi naman nating nakikita tong thermography naman, no? So, kahit hindi electrical application, nakikita naman natin to kahit pagpasok pa lang ng office, pagpasok pa lang ng isang establishment, may mga nakatutok na baril agad sa atin, no? So, those are infrared equipment. Okay, so they measure our temperature. Okay, so kung mainit ba tayo, malamig ba tayo. So yun yung mga, kasi yun yung parameters na gusto nating makita. Okay, so especially ngayon sa pandemic, no, we always do check our temperature para makita natin kung nilalagnat bang isang tao or whatsoever. So why do we do this? Okay, so technically, infrared thermography, sabi ko nga kanina, the most basic parameter na pwede nating masukat is temperature. Lahat ng bagay, no, may temperature, and on that note, meron tayong mga standards kasi talaga. For a specific temperature, merong nangyayari, no? So kung sa atin sa atin sa tao, no? So if we exceed at such temperature, ibig sabihin may nangyayari sa loob ng katawan natin internally, no? So ganun din sa mga bagay-bagay na tinitingnan natin. So when we have standard temperature, so ito na yung mga parameters na laging nating nakikita, and at that point, so kung umangat man or bumaba man yung temperature na nakikita natin dun sa object na mini-measure natin, we know na ano ba, may problema ba to or meron bang something na nangyayari, no? So technically sa mga pag-aaral naman natin palagi, no. So yun yung isa sa mga lagi nating tinitingnan. Okay? So parang ano lang, no, parang sa school, we have this yung sa mga laboratory natin, diba? Lagi natin ginagawa yan. So how do we do this? Well, technically, kung depende sa equipment na meron tayo, no. So we have what we call non-contact imager. So ito na yung mga lagi nga natin nakita sa mga mall, yung mga baril or yung mga camera na tinitingnan natin, no? Or na hinahawakan natin. So application, one of the applications of infrared thermography is of course electrical thermography. So ito yung talk natin talaga ngayon. So electrical thermography, the application na makikita mo kasi talaga dito, no, is it's more, sabi ko nga, limitless din eh. So lahat ng bagay na nakikita natin sa facilities natin, sa operations natin, so pwede nating sukatan talaga yun ng temperature. Okay. So what is electrical thermography? No, I would like to answer this by this slide. No? So actually kung titingnan mo to, may mga date yan and yung mga specific na pangalan na naming na ginawa ko or na ginawa namin sa operations. Okay, actually ito yung mga everyday na lagi ko rin talagang tinitignan. No? So once nag-activities yung mga engineer natin, no, nagpupunta yan sa facilities, nagpupunta yan sa site or kung saan man yung specific day niya. Yan yung mga sinusukatan nila, no? So ranging from upstream to downstream, kinukuhanan nila ng temperature lahat yan. So kung titingnan yung mga folders na yan, once binuksan niyo yan, punong-puno yan ng mga image files, no? So yan yung mga raw file na lagi, for me personally, yan yung tinitingnan ko kasi every time na pinapasa nila sa akin yung mga reports nila and yung mga kinuhanan nila that day and there, no? So kita ko kunwari yan si 2106, so 30. So nasa GE3 sila. So yung location nila, sasabihin naman nila sa akin. So kung ano yung mga kinuhanan nila, no? So technically, yun yung mga araw-araw kong nakikita. So for the past years na, so since 2016, 2017, kumbaga parang araw-araw na natin ginagawa yan. Okay. So who can conduct thermal scanning naman? So technically, alam na natin, no? So what, when, why, how. So who can conduct naman na thermal scanning? Okay. Actually, kung titingnan nyo talaga dito sa sinasabi nga nila, ito lagi nating naririnig, diba? Certified thermographer. Level 1, level 2, level 3. Technically, yan yung lagi nating naririnig, ano? From our clients, from the scope na binibigay sa atin, from the TOR itself. Yan yung mga lagi nating nakikita. Okay. So, let's try to define these three lang, no? Para at least magka-idea tayong lahat. Sir, question sa akin. Minsan may mga tanong din naman sa akin. No? Sir, okay lang ba? I am trained na kumuha. Pwede ba kumuha? I'm not a level 1 thermographer talaga per se, no? So, pwede ba? Well, ang mangyayari kasi dito, no? So sa per client din naman kasi talaga natin. Of course, may sinusunod kasi silang standard din talaga. No? Yung mga developer na client namin, syempre meron din silang standards, especially yung mga ISO talaga. Meron silang tinitignan na certification at their side din kasi talaga. No? So hindi ko naman pwedeng baliwalain yun. Okay, but if you are capable talaga, if you're capable and you know what you're doing, especially tong electrical system natin to, hindi naman to basta-basta, di ba? So hindi naman basta-basta magbubukas ka ng panel, titingin ka, magka-camera ka, or point and shoot, hindi naman ganyan yan eh. Of course, meron pa rin tayong hazards, no? So sabi ko nga sa mga engineer ko rin or sa mga thermographer natin, when you are going or when you are conducting this, submit muna kayo ng yung mga job hazard analysis talaga. So ito yung mga important din na kailangan yung malaman. So even if you're sabi natin technician ka na marunong ka rin talagang kumuha. Of course, meron pa rin talaga tayong mga kailangang isipin na nakadikit doon sa activities kasi natin. No? So for this level 1, level 2, level 3, so technically for level 1, ito yung tinatawag natin qualitative analysis. So what do we mean by qualitative analysis? Technically, when we say qualitative analysis, ito kasi yung thermal pattern. Okay. So when we have thermal pattern, ito yung once. Okay. So pag sinabi natin thermal pattern pala, no? So we are using infrared thermal camera. No? Hindi tayo pwedeng gumamit ng mga spot measurement na or yung mga radiometer na ginagamit natin, yung mga infrared lang na nakatutok. No? So no, we have to use our infrared camera para at least makita na natin yung digital image natin at yung thermal image natin. From there, magkakaroon kasi ng mga thermal pattern na kung tawagin. Okay, now ako for a level 2 thermographer, actually nagtuturo kasi ako ng mga level 1 din talaga. So ang tinuturo talaga dito kasi is yung thermal pattern. When we say thermal pattern, dito mo kasi makikita kung meron talagang thermal abnormalities na nangyayari sa isang system. So what do I mean by that? So ibig sabihin, once meron kang heat source sa isang bagay, tandaan natin syempre, thermodynamics, di ba? So what's going to happen kung merong heat source at some point? Syempre, lalakad yan. No? So kumbaga, gagapang ang usual term natin. No? Gumagapang yung init. So at such point, merong sobrang init and then gumagapang. So meron tayong thermal conduction na nangyayari. Okay. So for some naman, so yun yung mga heat pattern natin, di ba? Thermal conduction. Yung isa naman ay yung nangyayari for liquid naman, convection, di ba? So convection. Wala ako masyadong nakitang convection na nangyayari sa system, especially sa electrical. Ang usual nakikita kasi talaga natin dito is yung more or less conduction. Since resistance, di ba? Yung mga usual naman na hinahanap natin, yung mga loose connection or yung mga corroded terminals, technically mangyayari kasi doon conduction. Since the higher the resistance, the more power it generates or the more power as heat. No? So mas umiinit yung isang bagay, and at that same time, nakita natin siya during the thermal scanning natin. One of the heat transfer naman na tinitingnan din natin is yung sa transformer, for example, is yung mga transformer fins, di ba? So nagre-radiate naman yung init. Okay, so that's another thing na tinitingnan din natin na thermal pattern. Okay. For level 2 naman, what we actually ang naka-focus naman tayo what we call quantitative analysis. For quantitative analysis naman, ang ibig naman sabihin ng quantitative analysis is we are looking at the numbers. No? So hindi lang tayo tumitingin doon sa thermal pattern, but we are also looking at the temperature itself. So yung temperature mismo by the numbers na yung tinitingnan natin. So we are trying to judge our equipment. For example, mataas na ba yung delta T nito compared sa mga sister components niya. So yun yung mga bagay-bagay na tinitingnan natin sa quantitative analysis naman. For level 3, so ito naman yung medyo advanced topics naman na rin to. No? So more on calculation, more on simulation, more on software na rin yung ginagamit natin for level 3. So hopefully, ako naman personally, yun din naman yung goal ko. No? So maging level 3 pa tayo dito. And paramihin naman natin yung level 1 in terms of dito sa industry natin. No? So hopefully makapag-certify din tayo ng mga level 1 thermographer sa engineering or sa electrical facilities natin. Okay. So what camera do I need? So ito naman yung mga basic questions din na laging natatanong sa akin. So ano ba yung mga camera ang kailangan natin gamitin dito sa kapag magko-conduct tayo ng thermal scanning in our electrical facilities? Okay. So when we are selecting a camera, ito yung mga basic na nakikita natin or yung mga basic na makikita natin, no, tong sinulat ko, tong 10 queries na to. Okay. So first and foremost, you have to know your objective. Okay. Dito sa ating sa electrical thermography kasi, of course, ang objective naman natin is to find find loose connections, to find abnormalities sa mga equipment natin. Okay. We are not we are not that sensitive to the temperature. Hindi naman tayo yung talagang nakadiin or nakafocus dun sa tinitignan natin eh. Okay? Sometimes nga 'di ba, pag makita mo lang sa thermal pattern or dun sa thermal pattern mo, sir, hotspot agad to or may abnormality agad to. So, kita agad natin. Okay? So, what do I mean by that? Ibig sabihin, kapag sa objective mo pa lang, sir, is kailangan alam natin yung specs ng camera natin. Okay? When we are here in the temperature range, kunwari for example na lang, temperature range, sige. Ang usual temperature range ng isang camera ng thermal camera is range from sabihin natin from down from negative 200 ata, from 0 to 500 degrees Celsius or pwede namang umangat ng 1,000 degrees Celsius. So depending on your application, yung temperature range na kailangan mo. Of course, the higher or the lower, the higher na yung range na mas mataas, syempre mas mahal naman din talaga, no? So technically, kung yung range mo sobrang ganda or sobrang taas, sobrang baba, is mas mahal. Okay? So mas mahal yung bibili mo. But basically, kung dito naman sa ating electrical facilities, actually hindi ako nagre-require na kunwari 1,000 degrees Celsius makita ko. Alam ko na bumabaga na yan eh. Diba? Alam ko may problema na yan. So kahit siguro mga 500 degrees Celsius, at least for me, that is maximum siguro. So hindi naman, kasi actually for me nga, kahit pag nakita ko na 100 degrees Celsius yan, or the more pa, medyo, ano mo yan, kailangan na nating aksyonan. Okay, so hindi naman ganyan gumagana ang electrical facility or electrical equipment natin eh. No? So especially kailangan din natin tignan yung ambient temperature natin. So yung mga ganyang bagay, no, kailangan alamin natin. For the resolution naman, when we say resolution, technically ito yung mga pixels natin. No? Of course, the higher the pixel count, the better resolution. So technically, dito magmamatter naman yung digital image natin and yung thermal image natin. So basically, sa resolution, mas maganda to kasi tinitignan natin yung thermal pattern. No? So later magpapakita ako ng sample TOR na binibigay ko sa mga clients natin. And for, may reason kasi yun eh. So ito yung mga reason din na yun. No? So for the focus naman, actually ito focus, hindi siya ganun ka-importante. But basically, if you are a beginner din, mas maganda naka-autofocus ka. Okay, if you are using a camera with autofocus, parang point and shoot lang din kasi yun. So pipindutin mo, magfo-focus siya, may laser pointer kasi. And yan, magfo-focus siya. Magfo-focus yung thermal image mo and yung digital image mo, mas maganda. No? But if you are, kumbaga bihasa ka na sa paggamit ng camera natin, pwede mong i-manual focus naman yun. Again, syempre kung may digital focus or kung may automatic focus ka, mas mahal. No? So yun yung mga kailangan natin malaman din. Image fusion, ito actually standard dapat to eh. Dapat meron. No? So what is image fusion? Image fusion naman is yung thermal image mo at yung digital image mo iisa. Okay, so what do we mean by that? Meron kasi actually yung mga makalumang camera pa no, and yung sa mga may naka-experience pa ako nito. May na-witness ako, sorry. May na-witness pa ako nito. So hindi kami to. May na-witness kami nito. So may thermal camera siya, tapos may digital camera pa siya. So dalawa yung ginagamit niya. So basically, yung accuracy hindi siya ganun kaganda since point ka ng thermal camera tapos tsaka mo papalitan ng digital. So factors mo yung dapat saktong-sakto yung pag point and shoot mo. And then of course, yung time constraint mo rin, mas matagal. 'Di ba? Imbes na isang shoot tapos alis, dalawa pa yung ginagawa mo, no? So mas matrabaho pa. So for me, image fusion is standard and it is necessary. Accuracy and repeatability. Actually, this is naman more on your camera nyo na rin naman ito. No? So yung accuracy, meron kasi akong mga camera nakita last time is nangyayari pa is gusto nila bago daw gamitin is kailangan buksan mo na. So mga 10 minutes na nakabukas na. Kumbaga warm up yung tawag nila. So sabi ko hindi pala siya ganun kaganda or bakit mo kailangan pang i-warm up, parang luma di ba? So mas maganda yung alam mo yun, once na kailangan mo siyang gamitin, mas magagamit mo siya agad. So no need for warm up. So mas accurate din siya and yung repeatability, shoot pareho siya na ng binibigay, no? So battery life naman depending on your paggagamitan, no? So kung buong araw ka bang gagamit so mas maganda yung battery mo. So for us naman actually yung binibili kasi naman namin dalawa naman yung battery palagi. So naka-spare lang yung isa, once naubos na yung isa, charge na agad and then salpak dun sa isa. So continuous yung paggamit natin. So for lens option naman, actually itong lens option naman, for electrical, no, sabi ko nga for electrical application, hindi siya masyadong tinitingnan. Okay, but when it comes to other applications, tandaan nyo kasi is kung meron kang kailangan kuhanan na, for example, meron kang window, no, there is specific lenses na kailangan mong ipalit para doon sa window na yun. Okay, so especially kapag ang application mo, you're not just looking at electrical thermography, merong mga other applications na kailangan talaga magpalit ng lens. And dapat capable yung camera mo sa gagawin mo. Okay? So that is technically selecting a camera talaga. No? So for durability, syempre, technically naman mga magandang brand, of course, mas durable. Actually, yung sa akin nga, more or less, parang 5 years na. So maganda-ganda. So okay naman siya. Camera adjustments, yun nga, actually ito yung sa mga camera adjustments. Later papakita ko kung ano ba yung mga adjustments na tinutukoy ko. This is actually your ERT, no, yung concept ng camera naman. And for the software, mas maganda may software ka talaga para at least pwede mong i-change yung mga thermal images mo. Pwede mo mas ma-present ng mas maganda sa client. Okay. So kung meron pa kayong actually so hindi naman ako I don't affiliate myself with any brand. So kung meron kayong gustong itanong din sa akin na brand, pwede ka namang i-share. Hindi naman tayo yung nagbebenta dito, ano. Okay. So when is it needed? Okay. Actually ito yung additional information na medyo natutunan ko lately lang, no. Pakita ko na, no. So sabi ko nga kanina, no, I am more inclined with testing and commissioning kasi talaga. So dito, actually one of our ginagawa kasi talaga yung sa mga merchants, this is actually kakabukas pa lang ng merchant na to, no? So this is a simple application ng thermal scanning, no? Sabi ko sa thermographer ko, sige puntahan nyo kasi kakabukas lang yan. So tingnan lang natin kung ano yung kinabit nila, and then kuhanan nyo na rin ang thermal image para at least meron tayong as found at the first, no? Kumbaga commissioning natin to para sa ating client. So nung nakita namin to, sabi sa akin ng thermographer, "Sir, may hotspot, medyo mainit yung line side ng main nila." So nung parang sinabi ko kasi actually kakabukas lang yan. So parang 3-day-old pa lang yung store na yan. Ba't mo sasabihin sa akin may hotspot? No. So kasi ang usual question sa akin din talaga is, "Sir, kung meron tayong facilities, meron tayong kakabukas lang na electrical facility, substation, whatsoever, panels, kung ano man. Sir, kailangan bang patagalin a month bago tayo mag-thermal scanning? Kailangan bang patagalin a week bago tayo mag-thermal scanning?" So, wala naman din ako talaga nakikitang standard dyan, no? But when we say electrical kasi, electrical is, hindi mo kasi talaga masabi yan. Especially sa loads mo, especially sa system mo, hindi mo talaga masabi when, kailan siya bibigay. No? So, kumbaga parang sabi ko nga, the sooner the better. Diba? So pero ang mangyayari naman doon, "Sir, the sooner the better." Paano, sir, kung wala pa lang load, no? Sooner 'yon eh. So kakabukas mo pa lang, scan ka agad, hindi pala yan yung full load ko. Okay na ba 'yon, sir, for a year? Kumbaga the next year mo na kukuhanan, no? So technically ito yung mga dilemma natin as thermographer kasi walang specific answer eh, 'di ba? Kumbaga kakabukas lang yan. Sige, kuhanan mo na yan bukas. Hindi pa pala full load. So a week, sige kuhanan mo a week, yun pala meron ng hotspot na nangyayari. So yun as a thermographer, syempre kailangan yung mga judgment din natin tama, no? Hindi lang naman porket susunod tayo sa standard na ito kailangan annually yan, ganyan ganyan, no? So sa atin as thermographer, kailangan alam din natin yung ginagawa natin. So itong example ko lang na to, no. Yes, medyo kumbaga anomaly na talaga siya na 55.7. If I'm comparing this with the ambient temperature, mataas na siya, and comparing it to actually sa mga sister panels niya. So kakaiba na, no. So meron din siya kung titingnan mo in terms of the thermal pattern naman, sabi ko nga qualitative analysis. Kita mo pulado yung una, 'di ba? Pulado tapos nagkakaroon na lang, tapos saka lang siya gumaganda yung kulay, pataas, naglo-low na yung temperature. Okay. So for this, syempre actually naging problem din talaga dito, pangit yung installation, no? So hindi porket kaka-install lang yan, mahigpit yan. So nung the next day, the following day, sabi ko sige, gawin nyo agad para ma-measure din natin agad sa susunod na araw. So ginawa naman, shutdown, ginawa. Tapos then the second day, the July 30, binalikan namin. So okay naman na. Okay, so naging ito na yung temperature. So bumaba na, and actually nag-stabilize na siya. And kita mo, yung thermal pattern na tinutukoy ko kanina, so yun yung tama. Actually, yun yung tamang kulay na usually nakikita natin, no? So not basing from the temperature, basing pa lang dun sa image, dun sa thermal pattern pa lang. Kita mo na, okay siya. Okay. So yun yung mga magiging ano rin natin for thermographers, no? So sabi ko nga kanina, testing and commissioning kailangan meron talaga eh. Pero we just have to answer it when it is applicable. Parang ganun eh, no? So kailangan alam natin. The next thing naman na papakita ko dito is ito na yung actually yung full scope din kasi talaga for electrical thermography, no? So when we do electrical thermography, sabi ko nga kanina, hindi lang yan yung sa mga panels, hindi lang yan yung sa mga MCC or sa LVSG. Technically, we are doing yung buong whole electrical system natin. Okay. For this one, actually, like ko itong pinapakita sa mga talk ko, hindi naman ito yung isang facilities lang, no? So kumbaga, halo-halo na to. Kinompile ko na to basing sa mga nakikita kong images or sa thermal images na ginagawa natin. Okay. At first glance, okay na okay. Sir, walang problema. Wala naman ako nakikitang discoloration, wala akong nakikitang nagbabaga, wala naman ako nakikitang anything reported na pwede kong i-report na masama. Okay. But then again, sabi ko nga, when we have this kind of technology, yung electrical thermography natin, ang ganda, diba? So when we look at the thermal image naman, so ito na yung thermal image ng ating ginawa sa facilities natin, no? We have first private pole, we have the LA, we have the fuse, we have the transformer, primary transformer, secondary transformer, papuntang LVSG, papuntang bus duct, papuntang busbar gutter, papuntang meter gutter, papuntang breaker gutter. So technically, lahat ito pala, ibig sabihin lahat pala to, sir, kaya nating makita. Lahat pala ito is kukuhanan natin. So the basic answer is yes. Lahat yan kukuhanan natin, no? So hindi porket lagi nga nating sinasabi, no, hindi porket gumagana is okay yan, no? So we have to have our check talaga, no? Actually, itong lagi ko naman din sinasabi sa mga clients natin, annually, lagi natin tinitignan yan, yung mga thermal scanning na yan. So hindi naman porket ngayon is maganda. Of course, in time, magde-deteriorate ang ating mga equipment, no? So it's a fact, no? It's a fact. Hindi naman natin pwedeng maikaila yun kasi mangyayari yan, no? So regardless, kahit mahigpit yung ginawa mo during the commissioning, there will be time na magva-vibrate yan, especially kung may lindol or kung ano mang nangyayaring sakuna sa atin. There will be time talaga na it will loosen, no? It will loosen through time. Okay. So yun yung mga pwedeng mangyari sa ating electrical facilities, and that's why sabi ko nga itong full scope electrical thermography natin na to is ginagawa talaga natin. Okay. So siguro hindi ko na masyadong i-explain isa-isa, no? But based pa lang dun sa thermal pattern naman dito, kitang-kita mo na meron talagang abnormalities. So siguro sa next time natin, kung makapag-present pa ulit tayo, I will talk about yun, basically itong isa-isang per equipment na to. Pwede kong sabihin sa inyo remarks, findings, recommendations. So mas at least doon sa other talk natin pwedeng gawin, mas comprehensive ba. Okay. Ito yung sabi ko kanina, no. So I have a sample TOR here na yung mga usual na binibigay natin sa clients natin. Okay. So statement of purpose, actually ito pwede niyo namang basahin. No? And I think magbibigay naman kami ng copy ng presentation namin. I'll give a PDF file of this presentation para at least mapabigay din sa ating mga participants. So, yun yung kailangan picturean. Okay, so statement, blah, blah, blah. The purpose is to provide scope of works, so project overview. Project ensures working condition by analyzing thermal abnormalities. So, ano lang FYI lang ma'am sir ha. Actually, ang like ko kasing naririnig sa mga facilities, like kung naririnig sa mga, actually kahit sa mga bagong tao natin. Hotspot, yun yung unang-una kong naririnig. Sir, may hotspot. Sir, may hotspot dito. Sir, may hotspot doon. Actually, ang like kong sinasabi, it's not hotspot, it's thermal abnormality. No? So, tandaan natin, meron tayong mga bagay talaga na mainit. So, regardless that is their operation, yun yung operation nila. So, ba't mo tatawaging hotspot? So, it's parang mali. No? So, merong hotspot, merong cold spot. So, abnormality na lang. No? So, in general, that is actually a thermal abnormality. So, kumbaga, it is not functioning, it is in its right operation. No? So, umiinit siya nang hindi naman dapat. No? So, abnormal. kumbaga, no? So, may abnormality nangyayari. Okay, so thermal abnormality found during thermal inspection. As such, these anomalies will be classified by level 2 thermographer in accordance with ANSI NETA. So ito yung ginagamit namin sa amin sa standard namin. So we are using ANSI NETA for justification, for classification of our anomalies. No? So yan sa level 2 ako naman kasi nag-a-analyze talaga. So bago namin ipasa kay client, yan din naman yung tinitignan natin isa-isa. Okay, so for project analysis and methodology, so technically ito yung sinabi ko nga kanina, complete report shall be signed, blah, blah, blah. For better accuracy, ito naman yung accuracy na sinasabi ko. No? Detector, resolution, megapixel, and sensitivity. So what are these for? Bakit ko kinakailangan to? No? Bakit ko sinasabi kay client na ito yung gawin natin? Okay, for the detector, for the resolution, as I stated earlier, dito kasi makikita talaga yung thermal pattern. Okay, so kung hindi kagandahan ng resolution mo, tandaan nyo, no? Kung hindi kagandahan ng resolution nyo, of course, sasabihin nyo malabo, di ba? What if dun sa malabong yun, meron pala talagang hotspot na nangyayari or abnormality na nangyayari? So hindi natin mare-report. Sir, malabo no? So yun yung mga bagay-bagay na kumbaga as engineers, kailangan ma-cross out agad natin yan. So yung factor na yan, cross out agad, sir, hindi pwede yan. So kailangan yung binibigay din naman natin talaga is standard or ito yung dapat nating makita. Okay, for the 5 megapixel digital camera naman, actually sa mga cameras kasi naman usually makikita mo naman dyan yung thermal image resolution tapos yung digital resolution. So for the digital resolution naman, kagandahan lang kasi talaga nito is makita mo yung makita mo yung digital image talaga dun sa kinuhanan mo na thermal image. Para at least on that part naman, klaro kung ano yung nakikita mong problema. No? So kumbaga, this one is hindi lang yan basta-bastang retightening. Since meron akong nakitang corroded na, at least kita mo agad dun sa digital image mo. So may corrosion, may things like that. So nag-oxidize na, ano ba? So kung ano yung makikita mo dun sa digital image mo. So at least maganda yung digital image mo, pwede mong i-zoom. For the thermal sensitivity naman, actually ito rin kasi sa kagandahan sa sensitivity. When we say sensitivity, this is the lowest temperature that you can get in your thermal image. Okay, so when you have a sensitive camera din kasi, first and foremost, ang thermal pattern natin lalabas talaga dyan. No? For the thermal pattern, lalabas yan and syempre, yung pag-a-analyze pa lang natin din is once nag-click tayo dun nung spot measurement natin, specifically kapag naka-software ka na, makikita mo yung tamang temperature. Okay? So, mas sensitive din siya sa mga ganung bagay. Scope of works, supply, blah, 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 coordination, of course, coordinating the project with the client and kung kanino man kailangan magpaalam, di ba? So the thermal scanning report, of course, pre and post thermal, ito lagi nating sinasabi, no? Hindi tayo basta-bastang magto-thermal lang ng pre. No, when I say pre is hindi free So yung pre-thermal scanning natin before the preventive maintenance kasi once we have a preventive maintenance, laging may scanning yan laging may thermal scanning yan. So para sa mga facilities dyan, para sa mga engineers dyan or contractors whatsoever, ugaliin natin na ilagay talaga sa TOR natin yung thermal scanning. No? Ako, for me, it is kumbaga number one recommended natin kasi talaga to. Okay, this is an online monitoring na at least hindi kailangan i-shutdown. No? So online monitoring para at least kung meron talaga tayong mga nakikitang problema right then and there, sabihin mo agad. No? So dun sa sinasabi ko naman sa pre and post thermal scanning para at least makikita natin after the preventive maintenance kung na-correct natin yung abnormality na nakita natin. No? So that is why pre and post. Thermal scanning should be done during peak load. Of course, no? So basically, alam na natin to. Kumbaga common sense naman, we have to have the worst case scenario palagi. No? So worst case scenario, of course, worst case scenario is yung pinakamataas na load mo. Pinakamataas na load mo, yun yung pinakamainit na oras natin. No? So that is the worst case scenario na pwede nating makuhanan. So peak load. Okay. So binibigay naman ng client natin yan. So wala tayong problema dyan. Report shall include, of course, the infrared image, the recommendation, the digital image, ampere reading kung may hotspot, and of course, yung summary. No? So basically, yan yung mga basic na makikita natin sa reports natin. Reports must be signed by thermographer, of course, a certified thermographer, and APE. So technically, ito yung mga sinasign off kasi namin bago namin ibigay kay client. List of equipment, contractor shall provide sticker. Of course, ito yung mga usual sa audit naman nakikita natin. No? So kapag naglakad ka sa mga facilities, laging merong pass or fail na sticker na nakalagay. Contractor shall be responsible. Yan nga, katulad nga ng sabi ko kanina. Hindi lang yan basta-basta ang opening and closing ng mga panels, especially kung malapit sa bus bar mo yung mga enclosure mo, yung mga panel mo. So, ingat, no? So, I would recommend dapat talaga technician ang gagawa niyan, hindi lang yung mga kung sino-sino lang. Personnel shall sign health certificate, proper PPE. Yun. So, ito yung mga safety naman natin, no? So, I know for every contractor dyan, meron naman na kayong sarili-sariling standard na sinusunod. So, yan, let's do it. So, system approach to qualitative analysis. So, ito yung kanina kong pinakita, no? Or actually, kanina kong dinidiscuss sa inyo. When we say quantitative and infrared thermography. Wait lang, sir. Paano ba magsulat? Yan. Okay. Kita niyo naman yung drawing ko. Sir? Sige. Okay. When we say quantitative and infrared thermography, actually, ang point ko naman kasi dito naman is ito na yung mga concepts na lagi natin tinitignan sa thermographer or sa thermography na ginagawa natin. Ang IR theory kasi talaga natin is itong tatlo. E, R, T. Okay? This is what we call E plus R, sorry, pangit sulat plus T, okay, is equal to 1. Okay? So this is the Kirchhoff's law when it comes to this concept. No? So E is what we call emissivity, R is what we call reflectance, and T is yung transmittance. No? So ito yung tatlong lagi natin tinitignan. Emittance, reflectance, transmittance. Okay. So sa madaling salita na lang, no, hindi natin masyadong ma-elaborate siguro. Emittance is yung object mo kung ano yung ini-emit niyang temperature or infrared energy. Okay. So kung at a certain point dapat actually talaga mas kagandahan dito is dapat zero si reflectance natin, zero si transmittance natin. So technically ito yung lagi natin gusto. E is close to 1, no? Kumbaga yun yung sinasabi nating black body na mas magandang emittance natin is close to 1. Okay. So ano ba tong ERT na to? When we actually siguro sa mga nakakita na ng thermal scanning, ang mga usually ginagawa ng mga thermographers natin, 'di ba? Pag kumukuha, minsan yumuyuko, minsan gumigilid, minsan alam mo 'yon, parang sumasayaw during the scanning, no? So bakit? So ang tanong doon is actually ang ini-eliminate kasi nila is yung reflectivity or yung reflectance na tinutukoy natin. Okay, say for example, this is your object na kinukuhanan natin. No? Ito yung object natin. Tandaan natin, say for example, this is our camera. Yan, ito yung camera natin. Ha? Yan, maganda, yung camera natin. So, when our object emits, ito yun. So, mag-i-emit siya, pupunta sa camera natin. Mababasa niya yung temperature talaga ng object natin. For example, our temperature is, sabihin natin, ambient lang, 40 degrees Celsius. Okay. So, nakuha na natin siyang so, ibig sabihin, okay yung nakuha na natin. No? Now, what do I mean by reflectance and transmittance? Okay. First is, punta tayo sa reflectance muna. Our reflectance is what is reflectivity. So ano ba yung reflectivity dito? So for example, ang E natin hindi siya ganun, hindi siya close to 1. So sabihin natin 0.5. So technically, kung titignan natin sa formula natin, so ibig sabihin, itong R and T natin, pwedeng mag 0.5 din yan. So para mag-formulate tayo sa 1, di ba? So simple algebra. So ibig sabihin, kapag mababa ang emissivity natin, it's more on nagre-reflect din siya. Okay, nagre-reflect at nagre-reflect ang isang bagay. So yun yung pwede nating makuha dun sa object na kinukuhanan natin. So ano bang example nito? Say for example, merong tao dito. During the inspection, ikaw to, di ba? Hawak mo yung camera. Ikaw yan, sir. Hawak mo yung camera. Eh meron kang taong makulit, yung mga nag-a-assist sa atin. Pumapasok sa EE room. Yan, andyan siya. So meron siyang ini-emit din na temperature. So mag-i-emit si tao natin or si assistant natin ng temperature. Okay? Yes, yan. Nag-i-emit siya. Okay lang, no? So hindi tumama sa camera natin. So basically, okay lang kasi hindi naman tumama sa camera natin eh. Okay? So in this note, okay. So wala tayong reflectivity or wala tayong emittance na nakuha dun sa kasama natin. Pero what if sabi ko nga, reflective yung object natin. Yung temperature niya ngayon, ang nangyari, pumunta dito, nag-reflect, nag-bounce back, papunta sa camera natin. So that is what I say, reflectivity. Okay, R. So meron tayong source of heat dito, meron tayong source ng temperature dito na nag-reflect dun sa ating equipment or dun sa object na kinukuhanan natin. Magpa-plus talaga to. Plus basic R. Okay, kung ano man yung nireflect niya. So technically, yun yung mga lagi, kaya kapag makita mo, say for example, you are the assistant na may thermographer tayo, pinaalis ka. So may reason siya. Sir, nagre-reflect kasi kayo. Okay, sir, nakukuhanan ko kasi kayo. Okay, yun yung mga reasoning natin. And for example naman, dun sa thermographer natin, kung gumagalaw yan or umiikot or yumuyuko, ibig sabihin, siya naman, nakukuha niya yung sarili niya. That is reflectance. Okay, now for the transmittance naman, actually, technically, zero kasi talaga to usually, no? Or actually, sa atin, sa ating ginagawa, zero talaga ang transmissivity. Bakit? All our objects na kinukuhanan naman natin are opaque. So what do I mean by this? So, ang transmittance na tinutukoy natin is yung transmittance na mangyayari. So for example, ito nga yung camera natin, no? Ito yung camera natin. Meron kang tao dito. Yan, may tao ka dito. So for example, may transmissivity material itong object natin na kinukuhanan natin. For example lang ha, sabi ko nga kanina, pwedeng 0.5, 0.5 to. So, pag yung heat naman na inimit ng tao dyan is tumama dito, again, since unang-una, hindi yan walang transmittance na pwede mangyari, hindi tatagos, wala, zero. Pero once capable siya mag-transmit ng infrared energy, that's the time na yan, magtatransmit na yan. So, yung 40 plus R mo, magkakaroon pa ng plus T. So, yan yung magiging apparent temperature na makukuha natin sa thermal camera natin. So, technically, that is the basic concept na tinuturo natin dito sa level 2 thermography natin. No? So, we are trying to correct for R. We are also trying to correct for T. Okay. Sir, ba't mo i-correct yung T? Kakasabi mo lang, opaque object nga yan. So never tayo magkakaroon or magsusukat ng isang bagay na tatagos ang energy natin. Okay, so not necessarily na palagi, no. So we have what we call yung mga thermal or yung mga tinatawag nating infrared window No? So I guess nakakita na kayo kapag tumitingin kayo sa LBSG, sa HVSG, merong bilog. No? Merong bilog doon na window. Actually, pwede mong kuhanan kasi doon. So if your system or your design is capable of doing that, pwede mong hindi nabuksan yung enclosure mo, pwede mo nang hindi buksan yung panel mo. Doon ka kumuha. So technically, that is the purpose of our infrared window. Okay. Now, sir, di pwede pala yun, no? Yes, okay. But the thing is, you have to correct for the T. Okay. Hindi lang basta-bastang kukuhanan ka, hindi basta-bastang itututok mo yung camera mo doon. Sir, ito nakuha ko, 30 degrees Celsius, mababa lang. So, not necessarily na, ibig sabihin, not necessarily na yung temperature ng object na kinuhanan mo, transmit niya lahat dun sa term sa infrared window. So, no. Okay, you have to correct for it. So, how do we correct for it? By providing the right transmittance value. Okay. So, actually, pwede mo namang, it is not that recommended to use yung mga general values, no? Actually, sabi ng mga mentor natin, sabi rin ng nagturo din naman din sa akin, it is more recommended to calculate, no? So to calculate mo para at least kung ano talaga yung naka-install doon, kung ano talaga yung nakikita mong bagay or objects na kinukuhanan mo, correct. Hindi yung porket alam mong ito yung emissivity niyan, ito yung reflectance niyan, ito yung transmittance niyan, input agad. Kumbaga, gine-generalize mo eh. So kung on your part, hindi siya ganun ka-accurate. No? So sabihin na natin plus or minus, meron kang plus or minus percent na accuracy na hindi mo nagawa. Okay. So technically yun. No? So when we are talking about, sabi ko when we are talking about also the yung sa level 2 or yung quantitative infrared thermography, no. So yun yung mga bagay-bagay na kailangan nating i-correct, no. So actually yung atmosphere ganun din, more or less mangyayari yan sa windows and filters. Of course yung mga calibration accuracy specs, so hindi ko na masyadong matuturo sa ngayon, no. So we have very limited time. Tapos yung software naman na ginagamit natin, at least dito pwede mo kasing i-correct. So pwede mo makita dito yung mga kinuhanan mo. Sabi ko nga kanina, di ba, pinakita ko yung mga folders nung raw file nung kinukuhanan natin. So technically yun yung mga pwede nating makita. No? So actually to end my presentation, no, para at least lang, gusto kong ipakita yung software sa inyo. Wait lang sir ha. Try natin ipakita para at least magka-idea kayo. Wait lang sir. Here. Kasi ang next slide ko na kasi dito is yung electrical thermography sample. So try ko lang magpakita ng some samples na ginagawa natin. Bukas tayo ng software sir ha. Ito. Yan. Okay. So for example na lang dito sa mga ito. Actually ito yung Fluke, no. Ito yung ginagamit din kasi namin brand talaga. So Fluke thermal software. So these are the things na makikita natin sa software natin. So this is for example, this is this is a distribution transformer na kinukuha na natin. So sabi ko nga ito yung mga every floor na kinukuha na natin. So sa mga lumang design pa na walang, so may mga distribution transformer per floor and per EE room. So kinukuha na natin. So yun yung mga nakita natin. Actually for this nga hindi mo na nga kailangan kuhanan, kita mo na agad na susunog na yung kable, no? So pero kung titignan mo pa rin yung temperature, kung gusto mo pa rin talagang tignan, actually pwede mo talagang makita na talagang umiinit na. So ito rin yung kagandahan sa mga software, at least pwede mong i-analyze, no? So pwede mong ma-analyze especially sa thermal pattern. Okay. So another sample na gusto kong ipakita sa inyo is ito, for example ha. Sa transformer naman. Okay. Sige. No? Actually ito sa nakuhanan kasi namin sa isang facilities naman. Marami kasi siyang transformer. Actually 4 or 5 at 4 or 6 ata, 6 transformers. So, yan, tinan niyo yung mga una. Kumbaga ito, this is the first, say for example, this is the first transformer na kinuhanan. So, okay naman, no? So, wala ka masyadong makitang problem din. But then again, nung tinignan namin naman yung ibang transformer, actually ang tinitingnan natin dito, ma'am sir, yung terminals, no? So ito dito, wala naman tayo masyadong nakikita ang problem. So from this, actually may nakita kami dito naman. Yan. So kung titignan nyo, no? So makikita mo pa lang dito sa load break natin, no? Actually, isa to sa mga topic palagi natin nakikita ko sa IIEE, yung installation nito, no? So from here, makikita ka, what if pala na hindi kagandahan yung installation or hindi siya, pasok na pasok or anything related dyan. So makikita mo sa thermal scanning, talagang iinit yan. Actually, meron kaming sample dito na parang nasusunog na. Ito, tingnan niyo sir. Yan. So one sample to, no, talagang medyo kabado pa nga ako dito, nilapitan ko pa. No? So makita mo na agad, no, medyo umuumbok na. So since actually ang scope ko lang kasi dito more on thermal scanning lang. So right then and there, sinabi naman namin kay facilities na ito yung nangyayari sa system nila. So sinataw naman agad nila kasi fault agad yan no. So leakage agad yan, and once nag-fault na talaga yan, so to ground na agad yan. So faulted na yung system natin. Pwede na talaga silang mag-Happy New Year. So yun lang. No? So these are the things na samples na lagi din natin kinukuhanan. Actually, marami pa akong samples dito. So some other time siguro try ko pa mag-share. But for now, siguro that is my presentation. So yeah, thank you. Ma'am Gracie, any questions? So medyo sakto lang naman sa oras, 1 p.m. Yeah, actually, thanks for participating. Maraming salamat.
Okay, thank you very much, Engineer Juan Paulo Tolentino. So, sir, our delegate still has questions for you in the question and answer box and the chat box. However, due to time constraints, may we request, sir, that you reply on the questions through chat, sir, after you have your lunch. Yes, sir.
Sige ma'am. Actually ma'am, ano na lang din, no? FYI na lang for everyone. No? Actually, ito like ko rin naman sinasabi sa mga IIE members natin, participants natin. You can message me directly sa Facebook, wala namang problema. So kung may questions kayo specifically sa sa ginawa natin or sa pinag-aralan natin, message niyo ako, walang problema.
Yes, sir. Thank you very much po, Sir Juan Paulo Tolentino. And para makapag-lunch na po si Sir Juan Paulo, may we call on the President of Metro South, Engineer Frederick Calamlam, and the VP External of Metro West, Engineer John Registrosio, to award our Certificate of Appreciation. Certificate of Appreciation is presented to Juan Paulo M. Tolentino in grateful acknowledgement and appreciation of his invaluable service and professional thoughts shared as research speaker on the topic about infrared thermography, a full-scope application in electrical system during the IIEE 7th Metro Manila Regional Conference, a hybrid edition. Given the 7th day of August 2021 at the IIEE building, Cubao, Quezon City, and via Zoom cloud meetings, signed Engineer John Regis Estrosio, Vice President External of Metro West Chapter, Engineer Giovanni F. Tagatak, President Metro West Chapter, Engineer Manuel M. De Guzman, Secretary General Metro Manila Region, and Engineer Alwin M. Wagan, Governor, Metro Manila Region. Thank you very much, Sir Tolentino. And now, before we proceed with our next technical speakers, we will be having a 15-minute break. And once again, let us all watch our presentation from Crown Asia Chemical Corporation.
Electrical conduit pipes should be durable and flame retardant.
With sanitary pipes, you want no messy leaks and no costly repairs.
My family deserves a house that's durable and long-lasting.
That's why I recommend
Crown Pipes!
From the moment you're up, so are we. You don't have to look too hard. Our technology is everywhere. Because energy is a basic human right, a right we bring to places that previously had no energy. And for people on the move, we move raw data so that it becomes information for smoother running, more efficient cities. Every day, our world asks for more reliable power. But our resources are limited. That's why we make better use of what's around us, giving clean, sustainable energies a solid chance in the future. So while we help industry and productivity, we never forget what's at the end of the day. Not everyone knows us, and fewer may see us, but we are the global specialists in energy management and automation. We are Schneider Electric, and in everything we do, we make sure that even while you're asleep, life is on.
The pride comes from the idea that you know your job has a purpose.
And it's always bigger than you. Like how the mall is a customer journey.
And how it is an opportunity for people to work in their hometowns. And knowing that keeps us driven to perform every single day.
Our offices are the arenas, the theaters, the rinks, and the parks.
We bring world-class acts and shows to the country, creating lifestyle-defining experiences.
Understanding what is stake in our jobs
makes us results-oriented. Imagine one day you can just look at the horizon, point to that building and say, I am a part of that. To create with a commitment
to excellent speed and intensity. This is the key to a new chapter in their lives. Being a part of making that happen will always be a privilege. That always keeps me mindful
and accountable for the quality of my work. My pride is a daily chance to show the Filipino hospitality. So I always go above and beyond for exceptional performance.
And that's what makes us the #1 integrated property developer in Asia.
We have found our purpose. How about you? We are SM Prime.
Electrical conduit pipes should be durable and flame retardant.
With sanitary pipes, you want no messy leaks and no costly repairs.
My family deserves a house that's durable and long-lasting.
That's why I recommend
Crown Pipes!
From the moment you're up, so are we. You don't have to look too hard. Our technology is everywhere. Because energy is a basic human right, a right we bring to places that previously had no energy. And for people on the move, we move raw data so that it becomes information for smoother running, more efficient cities. Every day, our world asks for more reliable power. But our resources are limited. That's why we make better use of what's around us, giving clean, sustainable energies a solid chance in the future. So while we help industry and productivity, we never forget what's at the end of the day. Not everyone knows us, and fewer may see us, but we are the global specialists in energy management and automation. We are Schneider Electric, and in everything we do, we make sure that even while you're asleep, life is on.
The pride comes from the idea that you know your job has a purpose.
And it's always bigger than you. Like how the mall is a customer journey.
And how it is an opportunity for people to work in their hometowns. And knowing that keeps us driven
to perform every single day.
Our offices are the arenas, the theaters, the rinks, and the parks.
We bring world-class acts and shows to the country, creating lifestyle-defining experiences.
Understanding what's at stake in our jobs
makes us results-oriented. Imagine one day you can just look at the horizon, point to that building and say, I am a part of that. Create with a commitment.
to excellent speed and intensity. This is the key to a new chapter in their lives. Being a part of making that happen will always be a privilege. That always keeps me mindful
and accountable for the quality of my work. My pride is a daily chance to show the Filipino hospitality. So I always go above and beyond for exceptional performance.
And that's what makes us the #1 integrated property developer in Asia.
We have found our purpose. How about you? We are SM Prime.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
Good afternoon and welcome to our afternoon sessions. I'm sure you had your lunch already, and we will just temporarily suspend the raffle draw for the prizes for today. So we will have a raffle later on our closing ceremonies. So let's now proceed to our technical presenter. May I present to you for the topic maximizing renewable energy through great automation. He is a registered electrical engineer and a professional technical trainer. He finished his bachelor's degree in electrical engineering at Mindanao State University. He earned his master's in business administration at University of Roehampton, London, and currently completing his academic requirements for MSEE at Mapua University, Manila. He was a former instructor and campus electrical supervisor at his alma mater, Mindanao State University, General Santos City, in 2004 to 2010. He also worked as a technical trainer at Sheikh Khalifa Institute of Technology, Bahrain, in 2010 to 2012, and pursued his profession being the department head of electrical and mechatronics at Luray International University's Jeddah College of Excellence, Saudi Arabia, in 2015 to 2019. He taught at Bismarck State College, National Power Academy, Kingdom of Saudi Arabia in 2019 to 2020, and rejoined Bismarck State College, Higher Institute for Water and Power Tech last September 2020, where he once worked as technical trainer power plants in 2012 to 2015. Let us all welcome our first resource speaker for this afternoon, Engineer Celestino A. Collet Jr.
Magandang hapon po sa lahat. Before I'm going to proceed, okay po ba ang aking signal?
Hello, sir.
Yes, ma'am. Hello?
We can hardly hear you, sir.
Hello?
Okay,
Hello?
sir, you.
Hello?
Yes, you may now proceed, sir.
Okay. Thank you very much po. Okay, so magandang... Just want to share. Okay. Yeah. Okay. Thank you very much sa nagpapakilala po sa akin. Okay, so good afternoon to each and everyone. I would like to congratulate first the officers and members of IIEE MMR for this very successful event. So again, my name is Mr. Celestino Cole. And my topic for this afternoon is maximizing renewable energy through grid automation. And I'm given only 1 hour to present this topic, so I think without further ado, I'm going to begin my presentation. First, I'm going to show you the coverage of this topic.
Hello, Sir Celestino. I'm sorry to interrupt you, sir. Medyo nag-echo po yung inyong sound, yung audio.
Okay. Nasa room po, sir. So, okay na po, ma'am? Okay, wala na po bang echo?
Okay na. Hold on, sir. Our technical team is just checking.
Hello?
Meron pa din pong konti.
Wala naman po akong binuksan dito na iba pang mga gadget maliban dito sa laptop.
Hello, sir.
Hello?
Can you try again?
Yes, ma'am.
Okay, sir. You may now proceed. Thank you.
Okay, thank you very much. Okay, so these are the coverage of our topic for today. And I'm not going to read it one by one, but I'm going to highlight only some key points. Unang-una, yung renewable energy na involved sa ating discussion ngayon will be limited only to solar and wind. We're not going to cover hydroelectric because the hydroelectric is totally different from the characteristic of solar and wind. And also, I'm going to discuss technical issues related to the integration of renewable energy to our grid. But that will be contextualized into a massive integration. Kasi hindi ibig sabihin na pag tayo ay nagkabit ng renewable energy like yung mga solar panel, we can already distort the grid in this regard. So, ang consideration dito is yung massive integration na kung saan yung proportion niya sa overall capacity ng grid will be significant enough to trigger disturbance. Okay? So yan lang po ang pinakadalawang important na key points na i-consider po natin sa pagkakataon. Okay, I hope I'm clear at this point. Then I'm going also to present to you the innovation trend in the energy sector. Okay, so sagot ito sa katanungan natin na kailangan ba na talaga natin i-automate ang ating power system. Okay? So in this case, I'm going to present to you, this is from IRENA or International Renewable Energy Association. According to them, yung landscape ng ating energy sector nag-change, nag-evolve because number one, there will be a irreversible trend of the electrification using renewable energy because there are a lot of people, especially from the academic sector or academic community, scientific community, urging the policymakers of the government to reduce the harmful emission in the atmosphere. And there is no other effective way to do that other than using the renewable energy. So kung sa atin, kunti pa lang, magkakaroon din yan ng magdaragdag. Actually, kung halimbawa makikita natin sa Germany, mababasa din naman natin sa internet, meron silang mga target at certain number of years from now, like 2040 if I'm not mistaken, magkakaroon na sila ng net zero carbon emission. So for that reason, nag-develop sila ng mga wind power, mga solar power. So again, the renewable energy will be an irreversible trend. Also, there will be a decentralization of the power system. Kasi over the years, yung price ng solar panel, yung pinaka-system niya is nag-decrease. Tapos, law of supply and demand, pag mag-decrease yung price, of course, maraming tawang bibili. Kasi nakakatipid ka na sa kuryente, sa bill ng electricity, at the same time, nakakakulong ka pa sa environment. And of course, when there is already a massive integration of these renewable energy sources, then the use of digital technology will be inevitable as well. Because we need to make sure that we can monitor our assets closer to real time. So ngayon, masasagot natin na dapat kailangan ba natin i-automate yung ating grid. Okay? So ang sagot pa dyan, with the massive integration of this renewable energy because it serves the purpose. Okay? So moving forward, I'm going to discuss now the characteristic of renewable energy source. And I think the best way for me to explain this is i-discuss ko rin yung in contrast with the characteristic of yung ating conventional source of power. So marami tayong mga conventional source of power, meron tayong coal, meron tayong fuel oil, meron tayong mga gas turbine. But meron silang common ground. Ano ito? Ang common ground nilang lahat ay madali po silang i-optimize. Given na halimbawa sufficient yung kanilang capacity to meet the load demand of our customers, madali natin siyang i-optimize kasi yung kanyang characteristic is kaya natin silang, halimbawa sabihin natin doon sa mga base load natin, like ng code, na you're going to run 24/7 at 80% of your capacity, gagawin niya yan. Okay? Yun namang intermediate na mga gas turbine natin, so ini-schedule din natin. Hindi tayo pinifill. Okay? Presumably lang na hindi well-functional siya. No? Okay? Like yung intermediate natin, we're going to deploy that, start to increase during 6 a.m. in the morning. Okay? Then it will continue to increase as yung mga alas 8 na magbubukas na yung mga offices, gagamit na ng kuryente ng tao. And to address the necessity for seasons like yung mga summer. So sa summer kasi maraming mga tao na na gagamit ng air conditioning unit. Okay? For this reason, marami ding gagamit ng air conditioning unit. So malamang may mga peaking load yan. At during summer, ang productivity ng ating gas turbine is less compared doon sa mga cooler temperature season. Okay, so I hope I am clear. Then that is the characteristic of our conventional source of energy. Madali natin siya na-optimize. But here comes the renewable energy source. Ito po ay actual capture. Kinuha ko to online. Meron akong kaibigan na nagbibigay sa akin ng online data. Hindi naman online. Ako talaga mismo makakapasok sa system niya online. So doon sa kanyang installation, that was captured 4 days ago. For the last 4 days, ito August 6, August 5, 4, tsaka 3. So makikita natin, hindi siya kagaya nung sa mga base load na kung sabihin mo na you are going to run 24/7 with a 60 or 80% of your capacity, then it will continue to do that. So ito, meron siyang characteristic na intermittent, meron siyang characteristic na variable, at the same time, unpredictable. So the question now is, how are we going to optimize? How are we going to integrate these to the grid? Again, the context here is massive integration. Okay, so hindi ibig sabihin na magkaroon ka agad ng ganun pag may na-install lang tayo na halimbawa mga 5 kilowatt. So ganun na kaagad ang effect. Okay, so we establish also that this is an irreversible trend. So darating ang time na yung ganitong mga problema ma-encounter talaga natin. And here comes the wind power. Okay, so wind power, although wala akong actual capture ng kanyang data, but it seems na pareho lang sila ng solar. They share a common characteristic of being intermittent, variable, at saka unpredictable. Okay, so yan po. So ano ba ang mangyayari sa atin pag halimbawa mayroong characteristic na ganun? So this is also a actual capture. Nakuha ko itong data sa DOE. This is one of the solar power plant. Then it happened August 7, 2017. So parang coincidence kasi August 17 tayo ngayon. Okay, according to this data, with just a span of 5 minutes, the production of solar power plant fell or dropped for about 50 megawatt within just 5 minutes. So imagine, the question now is how are we going to cope up with those sudden imbalance? Ang question kasi dito, hindi yung yung amount ng energy, hindi lang yan, kundi pati yung time. Very short. Okay? So we need to remember that our thermal power plant has a limited capability to ramp up to compensate the energy imbalance. Meron talagang lag yan. So yan po ang isa sa mga issues na dapat din nating i-address. Dapat nating i-automate ng ating grid. Okay? So this is a graph of the sudden surge of electrical power. So kung makikita natin dito, merong mechanical power. Meron siyang lag in response. So hindi siya ura-urada na sumunod kaagad. So this is just an example of setup ng conventional source of electric power. So itong generator is taking power from the turbine, say steam turbine. Tapos ang turbine naman ay kumukuha ng heat energy galing sa boiler. Okay? But we have to make to remember that dito sa boiler, pinakaingat-ingatan po yan. We cannot simply induce a sudden surge of pressure or sudden drop in pressure. Kasi may interpret yan ng mga protection system sa boiler na abnormal situation. So ititrip niya yung boiler. And kung mag-trip yung boiler, so mas serious yung consequence kasi to restart a power plant, it will take hours to do that. So mako-compromise po yung ating mga consumer kasi magkakaroon ng load shedding in some part of the grid. So yan po ang isa sa mga consequence. Now, pupunta naman tayo dito sa tinatawag natin na duct curve. So duct curve, this is actually a phenomenon with the massive integration of solar panel. Yung mga nilalagay natin sa rooftop, ano ba ang posibleng mangyari pag mayroon ng massive integration? So to explain that, meron ako ditong prepare na graph. Okay? Merong tatlong curve yan, colored blue, orange at saka gray. Itong blue, ito yung total grid load. Okay? Tapos ito namang gray, ito yung solar energy production during the day. Okay? So di ba normal naman na pag meron kang solar panel sa bahay, pag araw na makasustain na siya sa iyong load, yung mga appliance natin, doon na kukuha sa solar panel, hindi na siya kukuha doon sa grid. Okay? So yan ang pinaka-purpose natin para makatipid tayo ng kuryente. Now, from the point of view sa grid, bababa yung kanyang demand. Di ba? So again, papasok dito yung ating question. Are we going to ramp down the conventional source, yung mga base load natin, yung mga intermediate power plant natin, just to accommodate the maximum production of energy coming from our solar? Yun po ang pinaka-question. Kasi ang ating nakasalalay dyan, yung what if kung biglang bababa? Again, paano hahabulin? Okay? So to discuss further, okay? So sa ngayon, meron tayong issue na na-identify, intermittency, variability, at saka unpredictability. Okay? So meron ding duct curve. Sandali, may na-chat sa akin. Baka ano. Sorry. Okay. Akala ko, please interrupt lang kung hindi maganda yung audio. Thank you very much. Thank you very much. Okay, balik po tayo sa discussion. So pagkatapos nito, meron din siyang effect sa tinatawag natin na grid balancing. Ano ba itong grid balancing? By principle, yung grid balancing simply means kung ano yung load requirement doon sa customer, dapat yun ang isusupply ng grid, both active and reactive power. So ngayon, meron tayong example na may isang building, tapos meron silang demand na 105 kVA with a power factor of 95%. Okay, so basically, trigonometric calculation, magsusupply tayo ng 100 kilowatt of active power at saka 32.9 kVAR of reactive power. Okay. It so happen na itong customer nito, meron silang installation na 60 kilowatt na solar panel. Okay? So logically, instead of getting 100 kilowatt of energy power coming from the grid, ang kukunin na lang niya is 40 kilowatt. Kasi sinagot na ng solar panel yung ating 60 kilowatt. But mapapansin natin yung reactive power niya still the same. Kasi most of the solar panel natin, meron tayong inverter na ang power factor niya is 100%. Meaning to say, yung kilowatt is equal to 60 kVA. Okay, 100%. So, balik tayo sa calculation. So, pag mabawasan pala ng 60 kilowatt, itong ang aking load from the grid at isusupply na lang niya is yung 40 kilowatt. So, ang result niyan from the point of interconnection is ito. Yung kanyang power factor angle is mag-increase from 18.3 degrees na kung saan 95% ang kanyang power factor into 39.4. The cosine of 39.4 is 77%. So ibig sabihin bababa pala siya. So magkakaroon siya ngayon ng effect sa ating power factor at the point of interconnection. Now, itong example ko ngayon is just for commercial na mga matataas yung kanyang power factor, mostly mga resistive na mga load. But what if doon sa mga industrial na maraming mga arc furnaces, maraming mga motors. So, posibleng halimbawa, 80% lang ang power factor nila. So, kinumpute ko ito at makumpute nyo rin, hindi ko na ipapakita. Yung kanyang power factor, magbababa siya sa 60%. Okay. Try nyo masolve. So, yun po yung isa sa mga issue sa grid balancing. So, sa ngayon, ano ba ang mga device level control na current technology? So, meron silang sinasuggest na tinatawag na ano ba tawag nito? Overloading, overcapacity of the inverter. Kasi yung inverter, halimbawa, instead of having 60 kVA, okay, at 100%, gagawin nilang 75 kVA at 80%. So, normally, 75 times 0.8, makukuha nila itong 60 kW. Pero in that case, overcapacity yung ang ating inverter, which is hindi masyadong maganda sa tinatawag na financial or economic point of view. Tapos, yung ganito, sa plant, siguro kung mga planta, madaling makontrol because simply we can install power factor correction capacitors doon sa ating substation. Pero, ang isa din sa mga problema dito, what if kung doon sa mga solar panel natin, na mga grid type, na kung saan kalat-kalat at kung saan-saan. So, paano i-address natin yan? Okay? So, moving forward, ang isa din sa pinakasagot dyan is yung generator natin because our synchronous generator has the capability to supply and consume reactive power. However, limited lang din ang magagawa ng ating pong generator. Kasi nagpa-follow tayo sa tinatawag natin na generator capability curve. So to interpret this, meron tayong y-axis na kung saan nagre-represent ng ating reactive power. Tapos meron din tayong active power sa x-axis. Tapos itong pinaka-radius niya, ito yung apparent power natin. So supposedly, it will follow in a perfect semicircle path. However, due to the limited capability,
Hello, Sir Cole.
Yes, ma'am.
I'm sorry to interrupt your presentation. Meron lang pong comment from some of our delegates na medyo mahina po yung sound. Opo. So, yung sa audio po, sir, pwede po nating itry yung sa may microphone po banda. Di ba may arrow po?
Yes,
Opo, yung sa Zoom po ninyo. Paki-click po yung may arrow dun sa may up, yung sa may up arrow po nung may microphone.
Yes, same
Opo,
as system.
then yung sa may select a microphone po, sir, paki-click po yung headset. Opo. Nagamit po ninyo kung ano po yung lumalabas.
Hello? Okay na po.
Hello. Hello,
Yes.
clear naman on our end, sir. Hopefully, comment na lang din po from our delegates. We will comment na lang po, sir. You can proceed with your presentation po.
Okay, but dyan po sa base, ma'am, sa inyong side, okay naman po ang aking audio?
Yes po, okay naman po dito sa end namin dito, sir.
Okay.
Malakas daw po yung echo as per one of our delegates.
Sorry, hindi ko na alam kung ano ang i-adjust dito. Kasi dalawa lang ang selection, microphone, Realtek at saka SIM assistant. So microphone, halimbawa, okay, i-change ko. Hello? Okay naman yung aking okay naman ang pagka-plug ng aking hello? Hello?
Opo. Pwede pong mag-select po kayo ng other option dyan sa select a microphone, sir.
Dalawa lang po, ma'am. Same as system, tapos microphone, Realtek audio.
Apo, unplug na lang daw po muna, sir. Yung try lang po, sir, and then replug. Oh, yes. Mic. Hello,
test
sir?
mic. Yes, ma'am. Hello, test mic.
Apo, sir, as suggested po yung laptop mic na lang daw po. Let's try, sir, kung better daw po yung sound.
Same as system yan po, laptop mic po yan.
Kung i-remove na lang po yung headset, sir, and let's try yung laptop mic na lang po.
Hindi ko marinig kayo, ma'am. Sandali. Hello.
Hello, sir. Try daw po magsalita, sir.
Hello?
Hello?
Yes, ma'am. Hello? Hello?
Okay naman daw po, sir, as per comment po sa ating chat.
Hello? Okay?
Okay, sir?
Okay, so I think itutuloy po natin, ano? Sandali. Share ako. Nawala yung presentation ko. Okay? Hello po, okay na ba?
sir. Thank you po.
Okay, thank you very much. Saan na tayo? Thank you very much. Okay, so effect on the grid. So, saan na ba tayo? Generator capability curve. Okay, kasi yung ating pong pagbabago ng ating reactive power sa grid is na-address din po ng ating generator. However, the capability of our generator is also limited due to ito, overexcitation. So if we have, by the way, in order for us to deliver reactive power, we have to increase our excitation voltage. So yan po ang nakakonect sa ating rotor. But nagkakaroon siya dito ng tinatawag na saturation line. Kasi hindi natin pwedeng i-overexcited ating generator. Otherwise, magkakaroon tayo ng burning doon sa ating pong coil, sa ating pong rotor winding. Tapos, yan allowed siya. Tapos, dito naman sa under-excitation, hindi din natin pwedeng i-under-excite ang ating pong generator kasi may risk po siya na loss of synchronism. Kakaroon ng mga reverse power. Because the voltage at that point is very low enough. Ma-overwhelm siya doon sa system. So, ayan, sa synchronous generator, sa part ng ating mga conventional power, it has limited capability. It brought the challenges by renewable energy source. At yung sa atin ng renewable energy at the what we call this the device level is a great challenge. I'm not saying na impossible kasi yung technology kasi ngayon ng mga inverters is currently evolving. So baka next year meron na silang ma-develop na magandang mga inverter. But anyway, kung pagbabasihan natin kasi yung curriculum namin sa Smart Grid last year, it is based on NERC sa US. So yung NERC, they require the RE plant, mga operator, to have a power factor at the terminal na positive 95% lagging at saka 95% leading. So doon lang nagre-range. Yan yung sa mga solar plant. Pero sa mga rooftop solar, so wala pa silang mga ruling about. So they are still doing its best to mitigate at the plant level. So kung hindi siya po pwede dito sa ating pong may limitation ng ating power plants, tapos at the device level na rin, grid challenge, so saan natin po pwede yung mitigation? So number one natin na ang pinaka-option natin sa grid, okay, i-automate natin ang grid in order to address. So yun po ang pinaka-point ng presentation ko po ngayon. Okay, let's move forward. So without grid automation, then we will be in a dilemma. Because if we are going to insist on harmful emission without grid automation, then we will be having a grid instability. That is certain with the massive integration of renewable energy. Then if we are going to choose grid stability, then dalawa ang posibleng mangyari. Okay? Pwede pang madagdagan, pero dalawa lang ang main na na-identify ko. Unang-una, curtailment of renewable energy. Ano ba yung curtailment? Ibig sabihin, hindi natin i-admit sa grid yung energy na na-produce niya. There will be an implication sa investment. Kasi pag nag-i-invest ka ng renewable energy tapos hindi naman pala gagamitin, so sayang yung investment natin. But anyway, hindi lang sa part ng investor. Kasi pag ako ang investor, I have to make sure na safe ang aking investment. I have to execute mga purchase agreement. So pag magkaroon mo ng curtailment, whether ginamit niyan, ang energy dyan o wala o hindi, magbabayad kayo ng minimum amount. So saan ngayon papasok yung minimum amount na yun? Papasok din sa transmission operator o baka sa distribution o baka kaya ipasa sa atin ng mga consumer. Okay, yun yung parang pinaka-catch doon. So right now, I don't know kung saan natin ipapasa yan, but definitely may matatamaan talaga doon sa tatlong nabanggit ko. Tapos running baseload plants at saka intermediate power plant in parallel with the solar energy or wind energy. So ma-defeat natin yung purpose for having this renewable energy kasi hindi mo rin mababawasan yung greenhouse emission mo. Kasi 'di ba, para maprotektahan mo yung grid, iraran mo rin yung yung baseload plants, which is hindi siya practical. Tapos kung magkaroon na rin ng abundance ng active power sa grid, tataas din ang ating frequency. So, I don't know, pero dito sa Saudi Arabia, ang cut-off is 61.5. Okay, 61.5, then magka-cut ka na sa grid. Okay? So, in that case. Alright. So, at this point, tapos na tayo sa mga issue. So, tatanungin natin, where are we going to start? So, we already established earlier that the power plant is limited at the device level is challenging. Hindi siya impossible. So we will start the digitization. Okay? This is the application of our digital technology. Tapos mag-i-introduce tayo ng iba't iba pang mga critical asset sa ating grid. So in terms of controlling, measuring, protecting communication device para ma-integrate natin yung ating mga different part of sa ating mga substation. So, nilagay ko dito, ginawa ko ng diagram na center yung substation kasi lahat naman talaga from the power plant going to the consumer, dadaan sa substation. Okay? So, ito yung conventional power source, tapos ito din yung renewable energy, dadaan sa substation. And then, I'm going to introduce here the energy storage system at saka itong tinatawag natin na VAR compensators. Itong mga energy storage system, matagal na itong ginagamit. But they are say for different purpose. Okay? But right now we are going to consider them as an active part sa mitigation ng impact ng renewable energy. Saan ba natin ginagamit ang energy storage system before? Yung wala pang mga lithium ion, mga BESS, di ba meron tayong mga hydro pump? Kung saan pag mababa ang price ng kuryente sa spot market, pinapaandar natin yung motor, yung pump, para mag-pump ng tubig doon sa higher reservoir. Pagkatapos, pag magkaroon naman ng mahal ang kuryente sa spot market, hindi na sila bibili doon. So, ino-optimize nila para gamitin doon sa time na yun na mahal yung. Tapos ito ding VAR compensator, ginagamit na rin yan dati. So VAR compensator, although complex yung kanyang construction at the low level, however, kung i-analyze natin yung overview at the high level, simple lang siya, capacitor or inductor. So kung magkaroon ng capacitive yung isang area, i-activate niya yung inductive part. And on the other hand, kung magkaroon ng inductive manifestation doon sa isang area, i-activate naman yung capacitive part. In that case, magkaroon ng cancellation. So magkakaroon ng stability. So dati yung mga VAR compensators, ginagamit ito sa halimbawa, nagpatayo ka ng planta this area. Tapos yung planta mo, during the completion, pagkatapos, maganda yung voltage profile, maganda yung power factor. But over the course of several years, nagkaroon ng development doon sa proximate location ng iyong planta. Tapos nasira yung voltage profile mo kasi may nagtayo ng planta sa kabila na malalaki ang motor. Tapos may nagtayo din dito na mga arc furnaces. So nasisira. So instead na lilipat ka, so hindi yung practical kasi hindi po pwedeng ililipat mo yung planta basta-basta. So in that case, nag-i-install ka ng mga VAR compensators. Although may mga automation na rin during that time, but that automation is the plant level automation. So pag magkaroon ng disturbance doon sa area na yun, automatic magko-compensate yun. However, again, I'm going to consider this bar compensator and energy storage system as an active part doon sa atin pong grid system. Okay? So moving forward, ano ba ang pinaka-basic component ng digital substation? Okay? So yung digital substation, very complex po yan. But to give you an overview, ang pinaka-difference niya with yung traditional, itong sa left traditional, ito ay sa right, ito ay modern, okay, digital. So with the presence of the process bus. Ano naman itong process bus? The process bus is, the purpose of that is to reduce itong mga copper wiring. Okay, because the copper wiring will increase the latency, measurement, and communication. So kung magkaroon ka ng controller-to-controller communication, mga relay, sa mga protection system natin, posibleng mabagal. So hindi siya po pwede doon sa grid level o tinatawag natin na wide area monitoring. So itong process bus, para lang itong PLC. Although ang logic behind, pero yung function nila is hindi magkapareho. Iba sila. So, di ba, yung PLC natin, Programmable Logic Controller, before, it was invented because to reduce the usage or utilization of industrial relay. Kasi pag meron kang control system na gusto mong magawa, gagamit ka ng mga industrial relay. So, yung industrial relay natin, meron yung isang coil, tapos dalawang normally closed, dalawang normally open. Tama po ba? Tapos kung ang ating requirement is more than that, so we have to add another relay, add another relay, and another relay. So hanggang we have this bunch of relay. So dito sa PLC, ang ginagawa natin is yung parang mga internal logical execution, ginawa na siyang soft wiring. So we may have, or we can have already, one internal relay with 100 normally open, with 100 normally closed. Depende sa ating capacity to do the programming. Okay? So ito din yung process bus. Okay, the logic behind is the same. So as a result, na-eliminate na yung 33% of breaker termination, na-eliminate din yung 40% ng cabling, tsaka na-eliminate yung 90% ng control termination. Okay? Pagkatapos sa downstream mga devices, before dito sa process, meron tayong mga switchgear, mga modern switchgear, at saka modern instrument transformer, mga CT at saka BP for our protective relaying. So ano naman ang changes? So, okay. So ang changes dito sa mga sa mga inputs doon, itong sa left, ito yung conventional. The manner on how to convert the analog to digital is over the copper wire. So ito yung ating CT, mga instrument transformer natin, di ba? Tapos ipapasa natin dito sa ating electronic device. Tapos napiperform yung kanyang function. It's either we use it for protection, we use it for controller, or mga differential protection relay. So dito naman, ang kaibahan, ang tawag dito is merging unit. Okay? Ibalik ko lang Itong dito banda sa may modern city at saka BT. Before that, meron siyang merging unit or MU. So the process is different because from the site level, kino-convert na niya into analog to digital conversion using the technology of optical communication. Tapos isi-send niya dito over fiber communication. Kaya mas mabilis. Kasi halimbawa dito, meron kang device-to-device communication. So meron kang upstream communication, tapos meron ka ring downstream communication. Upstream at saka downstream copper connection. Dito pwedeng isang fiber na lang. Okay? So yan po ang parang innovation sa mga merging unit sa kasalukuyan. Tapos meron ding okay, so paano ba ginagawa yung merging unit? So just an example, bakit napabilis? Okay? Ang ginagamit kasi na analog to digital conversion dito sa conventional is kagaya din ng mga meron tayong mga capacitive, meron tayong mga resistive sensors, di ba? So meron tayong mga LVDT, linear variable differential transformer. Okay? So ginagamit natin sa mga process control. So ito, using the optical technology. So yung sampling niya, dito, ang latency is from second to minutes. Kasi ang resolution niya is 1 to 10 seconds scan rates. Yung conventional na mga RTU, na mga copper cabling. But with the advent of merging unit, yung latency niya is less than 200 milliseconds. And even some system requires faster than the action of our circuit breaker. So ano itong sampling unit, sampling value technology. So over one cycle, meron silang over one cycle, meron silang sampling from 80 to 256 sampling time. So depende sa manufacturer. Okay, mga ABB, yung GE, so iba-iba ang kanilang ang kanilang sampling. But it ranges from 80 to 256. So therefore, sa modern grid natin, okay, ang ating basic components ito yung merging unit, okay, ito yung mga IED natin that can function as a numerical protection relay. Tapos ito ay mga PLC-based engine kasi ito ding numerical, ito ding mga IED natin sometimes. It has a limited capability to execute logical processes. So kailangan natin ng tulong ng mga PLC-based engine. So PLC-based engine meaning to say it accepts instruction from IEC 61311 yung sa mga function block diagram, sa mga ladder diagram, mga instruction list. So yun, for as long as maka-accept siya ng ganyang command, so that is a PLC-based engine. Tapos meron din tayo mga power meter. Like in this case, we have a power meter from Schneider PM8000. Okay? So kung titingnan natin yung PM8000, it has the capability to communicate over IEC 61850. So interoperable communications network. So kailangan din natin yan. Kasi in order for the devices to talk to each other in the same language, so ito sa mga plant level natin, sa mga plant level po natin, kailangan natin ng mga Profibus. Okay? Tapos sa mga station level, kailangan natin ng Ethernet. Tapos yung sa ating mga merging unit to IED at saka IED to IED, kailangan itong IEC 61850. So we need to be familiarized for this one as well. Then we need also the PTP, yung Precision Time Protocol, as defined in IEC 1588. So time synchronization. So balikan ko lang itong sampling unit, sampling measured value. So different manufacturers, halimbawa si Schneider, di ba 80 to 256. So nag-timestamp siya doon sa 150. Tapos yung iba naman nag-timestamp doon sa pang-ilang level. Okay? So nagkakaroon ng latency sa time. So para ma-synchronize siya, we have to access the GPS because the best way to synchronize clock all over the globe is through the GPS. So kaya kung sa mga modern substation, makakita tayo ng mga GPS receiver which is connected to this one. So yan po yung parang pinaka-function yan. Tapos, kailangan din natin ng software communication. Okay? Software application pala. The software will be used for optimization and wide area. Okay? So yan. Ito po ay sample. This is from Xenon software. Kinuha ko lang itong optimization. So paano natin i-optimize using these devices? Okay? So i-optimize natin siya para ma-properly schedule natin yung ating mga renewable energy. Okay? We are going to collect data through our smart metering infrastructure, yung mga power meters o di kaya doon sa mga reliable communication phone devices at control system. Doon sa ating mga PLC-based engines, sa ating mga IED, sa ating mga merging unit. Okay? Tapos, i-integrate natin siya doon sa mga weather sensors. Okay? So this is just an example doon sa automated grid. Tapos, yung lahat ng mga data will be feed into a AI platform, artificial intelligence. Then we will do the optimization. So marami tayong variable. Variable natin is yung ating conventional power, yung ating energy storage, tapos yung mga condition sa surrounding, pagkatapos mapipredict niya. So according to this software, this is actually from ABB, Xenon. So the error prediction is range only from +5 to -5. Sorry, 5 to 15% error prediction. So ibig sabihin, nababawasan yung uncertainty niya kasi yung unpredictability niya. So this is a sample graph given in the website of the presentation. Okay. So yun po ang parang pinaka-advantage. So again, the software along with the smart instruments and infrastructure will enable to collect data for artificial intelligence, then we will optimize it. And then sa ano naman itong wide area monitoring. So I created just a sample architecture. Sample lang ito. Okay, simple. So ito yung RA plant natin. Meron tayong mga solar collector, inverter, tapos transformer. Tapos ito yung ating OEM controller, data management, mga MPPT. So may mga tapos it will be connected to this Ethernet connection. Tapos ito yung substation natin, digital substation. So yung merging unit natin nandito, ang mga instrument transformer natin nandito. We will feed it to a process bus. Tapos nandito yung ating mga IED. Kung kailangan natin ng differential protection, kung kailangan natin ng distance protection, it will function similar to the conventional but faster. Okay? So walang nabago dito sa operation, kundi pinabilis lang niya with a latency of less than 1 second. So ito yung Ethernet, ito yung ating GPS system. So meron tayong gateway, nakalimutan ko lang ilagay, that will enable the wide area monitoring communication. So marami yan sa SEL na mga So yung data server, ito yung para sa SCADA natin. Okay? So meron tayong operations HMI for the operator. And in case we're going to change some parameter, we have the engineering HMI. Okay? We will proceed into the LAN. By the way, this is the remote facility that will control our BESS, that will control our VAR compensator. So this is just a sample architecture. Okay, na ipipresent ko sa inyo ngayon. Okay, moving forward. So pag ang akin palang grid is already automated, then that means I have this characteristic. Okay, 2 main characteristics. Hindi lang limited dito kasi nga, as I have said, the technology always evolve. So itong na-identify ko ngayon, posibleng madadagdagan bukas. So number 1 is enhanced optimization. So software integration from the data collection. And then the most interesting is itong measurement and latency of less than 1 second. Compared to the conventional minutes, seconds to minutes. Mababagal. Okay? So ano ang magiging capability ko para halimbawa automated na aking grid to maximize my utilization of the energy produced by my renewable energy. So we have this, and this is not just 5. Pwede pang dumami yun, yung pinaka-full extent ng infrastructure ng smart grid, posibleng ma-integrate dito. So this presentation, ayaw kong tawagin smart grid kasi yung smart grid, mas napaka-lawak ng kanyang scope. Okay? So halimbawa ito, energy storage control. Balikan natin yung duct curve na sinasabi ko kanina. So yung di ba dito, may risky yung mag-ramp down tayo dito ng mga conventional source, yung mga baseload natin. So in this case, posibleng na hindi natin i-ramp down. But the excess energy coming from the renewable energy is store natin dito sa battery. Okay? Kaya bakit kailangan din ng optimization? Kasi hindi naman din financially sound na kung gaano kalaki ang iyong renewable energy, ganon din kalaki yung battery. For sure, mas maliit dyan ang ating battery, yung BESS natin. So in that case, baka mapuno. Okay? So what if kung mapuno with this amount of renewable energy? So i-optimize natin yan using artificial intelligence against the demand. Tapos meron na tayong ganitong graph. Okay? So meron tayong peak shaving, load leveling, and other optimized control algorithm. Wherein kung ito kasi ay example na to is lang ito, frequency-based optimization. Na kung saan mag above 50.02, so we are going to instruct that this battery will absorb power, magcha-charge yan. And sometime later, magsusupply naman siya ng power sa grid. And so on and so forth. Kung ano yung result ng optimization process. In this way, we can manage to maximize the renewable energy. So meron ding demand side management. Demand side management meaning to say we are giving also the participation. We will allow the participation of the consumer. Yung mga industrial plants natin to postpone or to shift their maximum production sometime during non-peak load. Okay? So bakit kailangan natin ng smart infrastructure? Kasi baka mabago, di ba? So kailangan natin, meron tayong mga purchasing agreement. Baka hindi nila tutuparin. How are we going to capture that? Okay? And how are we going to optimize it na? Baka sa atin din naman part, on their counter argument nila, ano naman ang assurance nila na magkakaroon talaga ng ganun. Di ba? Na hindi magsasuffer yung mga consumer. So, kasi yung ating spot market at saka yung generating station at saka siguro yung may-ari ng BSS may be an independent entity, different business organizations. So the optimization will help to carry out this task. Okay? So kung lalaliman pa natin, posible na i-reach out natin yung mga individual consumers. But yung ipopostpone nila, yung magplansya ka ng alas 12 ng madaling ating gabi. Diba? So tapos magkaroon ng incentives. So posibleng mangyari yon using this automated grid. Tapos meron ding optimized algorithm using vehicle-to-grid technology. Ito, bagong technology ba ito? But this will become possible if our grid is optimized. Ano man itong vehicle-to-grid? Okay? Kasi kung meron silang study na yung daw sa isang lugar, yung lahat ng mga number ng vehicle, okay? Yung makikita mong tumatakbo sa daan, that only consists of 20%. Okay? So, ang the rest no, nakapark lang. So, ibig sabihin, kung sa isang city, merong 1,000 sasakyan, yung makikita natin na paikot-ikot na nagmumove, yun lang 200. Pero ang 800 no, nakapark. So, they propose this vehicle V2G charging infrastructure. Okay? So during the time na magkaroon ng excess, papasok siya, charge niya itong car. Ito yung pinaka-holding. Tapos during an optimum time, i-discharge naman niya sa. Again, this is a promise, hindi pa ito perfect technology. Hindi pa siguro ito na-implement practically. Nasa mga ano pa lang ito. But this is the plan. Okay? So it is our smart grid. So our smart grid, kung meron tayong digital substation, then we can implement this in the near future. Then, grid balancing. Yung grid balancing kanina, yung reactive power. So due to time limitation, I'm not going to discuss yung active power control. Kasi although mahirap siya, pero less challenging siya compare sa reactive power control. Kasi ang active power control, ang pinaka-indicator niya is yung frequency. And all over the grid, ang frequency is uniform. So madali natin siyang applyan ng mga PID control system, proportional, integral, at saka derivative controllers. But itong grid balancing na to sa reactive power, medyo mas challenging siya. So in this case, I will present to you a certain grid, okay, na merong 5 bus. So itong generator nasa bus 1. So with respect to the bus 1, yung voltage drop dito sa bus number 3, logically is higher compared dito sa bus number 2, di ba? Okay? So, normal lang na Ohm's law. Mas mahaba itong impedance dito. But for example, ang bus 2 nag-install ng renewable energy. Ano ang posibleng mangyari? Na-discuss natin kanina na posibleng bababa ang kanyang voltage due to the insufficiency of the reactive power. Okay? So parang nagkaroon ng kabaliktaran kasi dito sa bus number 2, posible pala na mas mababa ang aking voltage dito kumpara dito sa bus number 3 with the integration of renewable energy here. Okay, so ang gagawin natin is mag-install tayo ng static bar compensator. Okay. Tapos, with the, posible din na pagtaas ng voltage dito, madadamay din itong number 3. posibleng madamay siya. So maglagay din tayo ng VAR compensator. And all of them will be integrated with each other using wide area monitoring system. So ito yung parang grid automation. Okay, kasi we already found out na ito mga adjusting of OLTC or on-load tap changer, mag-request ka sa generator ng absorb VAR or produce more VAR. So limited lang ang kanilang kakayanan. So dito tayo sa grid automation. And then sa grid automation also, the static VAR compensator are also used itong sa mga wind power. Kasi sa wind power, hindi naman talaga uniform ang kanilang speed ng wind. So in case there are disturbance, ang ating static VAR compensators are ready to handle, to mitigate the changes, okay, the disturbance. Tapos ito din palang mga wind energy, palibasa meron itong mga inverter. Hindi naman ito naka-direct feed. So from the generator, papasok siya sa inverter. Okay? Tapos yung inverter, gagawin siyang DC. Tapos yung inverter na ang mag-i-interface dito sa transformer from DC to AC. So AC to DC, DC to AC. Okay? So that means itong substation na to, this is an inverter interface substation. So meron pag nagkaroon kasi ng fault dito sa ating network, kung halimbawa meron tayong sa proximate location ng power plant, siyempre ang ating power plant is magdi-disconnect kasi makasustain yun eh. Diba? Mayroong inertia ang ating mga synchronous generator to contribute at the fault point. However, pag ang ating source is inverter, wala siyang inertia para totally makakontribute doon sa fault point. So yung tinatawag nila na FRT or frequency ride through. So pero although ma-override niya yun, pero magkakaroon din rin ng disturbance somewhere here. Okay? In the point of common coupling. So yung SVC natin is ginagamit din natin para ma-compensate kung ano man yung disturbance until such time na ma-restore yung ating network into a certain, normal condition. Okay? So ito ay pinaka-example. Ito ay example installation nito. So ang situation, meron ditong hydropower plant dito sa Big Creek bus. Tapos nagsusupply sila dito sa Rector bus. Okay, over the course of many years, nagkakaroon ng problema yung voltage profile dito banda sa Rector. Okay? Kasi yung kasing proximate location ng Big Creek, marami ng mga bahay, maraming mga industrial area over the course of many years. So yun ang nakakasira ng kanilang voltage profile dito. So to mitigate the process, kailangan nilang itaas yung voltage. However, dito sa Big Creek, tataas din naman ang voltage nila. That causes a problem. So ang ginawa nila, nag-install sila ng static VAR compensator dito banda. Tapos they use the merging unit. Okay, this is actually a phasor measurement unit. So it works similarly with the technology of merging unit. Okay, the voltage is written to the gateway of this digital substation here. Okay, in the Rector bus. Tapos, in that case, meron lang total measurement and communication latency of less than 1 second. So for that reason, merong real-time communication between these two controllers. So napababa niya ang kanyang voltage. And at the same time, na-stabilize din niya at 230 kilowatts dito banda sa Rector bus. So ito yung parang, hindi naman ito related actually pala sa renewable energy. Ito example nito, but this is just a manifestation on how the technology of this merging unit works. Okay? And ito ay simulation namin. Okay? Hindi na rin ito related but sa renewable energy, but it can enable the fast response of the protection system. Okay? So this is an example. Meron tayong distance relay. Okay? Yung kasing distance relay natin before works through the principle of ohmic principle. Okay, so in this case, nung nagkaroon ng fault dito, by the way, itong substation is separated by 200 miles. So magkaroon ng fault somewhere here, then we can see that zone 1 is activated, then it's under 3 seconds, okay? Then nag-trip ang other substation at around 23 seconds. So merong difference of 20 seconds. Okay? But with the advent of automation, so meron ng communication interface, meron tayong transmitter at saka receiver. So during the time na nagkaroon ng fault dito, na-detect ng substation dito, so hindi na ang dadaloy dito na signal, ibig sabihin yung kanyang means to trip the substation is no longer the yung tinatawag natin na ohmic principle, kundi ito ng fast communication. So yung transmitter nag-send ng signal doon sa receiver ng isang substation. So that's why communication ang nag-trigger sa kanila. Then within just less than 5 seconds, nag-clear ang dalawa. Tapos magkabilang substation, they try to figure out where is the fault. Okay, so yan po ang pinaka-example. So to summarize everything, so due to our desire to reduce gas emission, renewable is no longer an option but a necessity. So we established this fact. Then the use of renewable energy changes the landscape of the power system. And due to inherent characteristic na makaka-apekto siya sa conventional load flow ng grid natin, yung mga reactive voltage profile at related din sa voltage profile. Then the grid automation can mitigate the risk of instability that cannot be solved at the device level and offers enhanced optimization like ESS control, yung software na yung example natin kanina, with less latency in terms of data transmission. For example, the use of merging unit and wide area monitoring system. And last but not the least, the grid automation through wide area monitoring can facilitate quick response against grid instability. Example, the use of static power compensators. So in this case, we can maximize the renewable energy source. So thank you po. Maraming salamat.
Ladies and gentlemen, there you have it, ladies and gentlemen. Once again, a big round of applause for Engineer College Jr. So we will now award the Certificate of Appreciation. The Certificate of Appreciation is awarded to Engineer Celestino A. College Jr. in grateful acknowledgement and appreciation of his invaluable service and professional thought shared as a research speaker on the topic about maximizing renewable energy through grid automation. During the IAE 7 Metro Manila Regional Conference, a hybrid event with the team got one IAE at 46, transcending the challenges in the new normal by embracing resiliency and complementarity. Given the 7th day of August 2021 at IAEE building, Cubao, Quezon City, and via Zoom cloud meetings. Signed by Engineer John Reyes Estrosio, Engineer Giovanni F. Tagatak, Engineer Manuel M. Guzman, and Engineer Alwin M. Wagan. Here with us is our chapter president to award the Certificate of Appreciation and Engineer Manuel M. Guzman, the Secretary General.
Thank you.
Thank you very much, Engineer Cole. And sir, we would like to request if you can answer the Q&A chat box for those members who are asking for questions regarding your topic for today.
Yes po, ma'am. Nagbabasa po.
Thank you very much, Sir Cole. And now we will now proceed to the audio-visual presentation of one of our sponsors as Emerald sponsor. We will now present the SM Engineering Design and Development Corporation.
The pride comes from the idea that you know your job has a purpose.
And it's always bigger than you. Like how the mall is a customer journey.
And how it is an opportunity for people to work in their hometowns. And knowing that keeps us driven
to perform every single day.
Our offices are the arenas, the theaters, the rinks, and the parks.
We bring world-class acts and shows to the country, creating lifestyle-defining experiences.
Understanding what's at stake in our jobs
makes us results-oriented. Imagine one day you can just look at the horizon, point to that building and say, I am a part of that. We create with a commitment
to excellent speed and intensity. This is the key to a new chapter in their lives. Being a part of making that happen will always be a privilege. That always keeps me mindful
and accountable for the quality of my work. My pride is a daily chance to show the Filipino hospitality. So I always go above and beyond for exceptional performance.
And that's what makes us the #1 integrated property developer in Asia.
We have found our purpose. How about you? We are SM Prime.
Hi, I am Camille L. Rojas, an engineering officer at SMEDB Corporation. I've been with the company for about 5 years. I handle indoor substation system of the 76 SM malls. My role is to draft guidelines, propose standardizations and improvements to electrical system, as well as the maintenance service repairs and engineering data analytics. Our team is assigned to analyze data and trends of existing repair work orders and devise improvement plans to effectively enhance our system. We are also tasked to standardize the scope of work and cost of repairs, and most importantly, streamline the process of project approvals of our 75 malls. The biggest achievement that I have acquired during my stay with SM is that I was able to draft 25 guidelines with specification and design criteria that is now being implemented to SM malls, both constructing and existing ones. Before we were able to draft guidelines, we are to check if this complies with the established codes, especially for the local and international standards, commercial impact of the proposed standard against the current setup of our existing system, and the benefits that SM could gain from it, especially for the energy-saving technologies available in the market. Even though this is the most challenging experience, there is an amplified fulfillment and feeling of accomplishment to every guidelines and standards that is approved by the management. I remember when I was interviewed by our division. He asked me to promise him 2 things: honesty and integrity. From that day on, in every work I do with SM, I always abide by these 2 virtues or 2 values. Kasi kahit anong galing natin sa workplace, if these are not done without honesty and integrity, we will never get the sense of fulfillment and success. I am grateful to SM for the management who is always giving us 100 support and challenging us to level up in everything that we do. Prior to this pandemic, I was able to enjoy the team building activities, Christmas party, and the other events that they initiate for us to become one EDP. Most especially to my colleagues who I work with and to my immediate heads who honed and mentored my skills and extended their knowledge for us to become who we are now. For us to still be the #1 project delivery company, we should aim for more or higher. As the world and technology is changing, we need to continuously improve our system as well.
Hi, my name is Mark Kevin Maligat. My colleagues call me Mark. I'm working as resident engineer at SMEDD for almost 4 years. I am assigned to do and handle new construction, renovation, and expansion SMOs. We are focused on doing and managing the MEPs from the design stage up to the bidding, installation and commissioning, testing and commissioning, up to the project closeout. Every day is different from yesterday. New problem, new learning. You'll be faced with the reality that there is so much to learn in this industry. You have to grow and adapt after each day. Either you get pulled by the trend or you just go with it at the same time at your own pace. This culture of testing your limit really produces the best professional in the field. No wonder SM Group of Companies is the leading retail group in the country. SM EDD heads are not the typical boss you'll expect. They'll give you the privilege of working freestyle. You have to be resourceful and creative in delivering or doing your job because at the end of the day, they are after the result. You have to work smart and delivering quality projects on time. They are open to ways of solving a problem, but at the same time, will advise you if they got inputs or better approach. I am grateful for the management. They make you feel they always got your back and fulfill our needs. They develop employee engagement activities where you can interact with other departments. I participated in basketball and volleyball leagues. It really helps a lot for us to have a better team coordination in any project. And also the side benefit of meeting new friends and expanding your professional network and contacts. I am grateful that I am continuing to understand engineering trades like the air conditioning and ventilation system, the fire protection system, and the plumbing and sanitary system. It's the joy of comprehending these systems and designing them to work efficiently. The experience from the design stage up to actually maintaining these items. I can say I made a great leap in my career with my competitive team and really grow more than I expected as a professional.
I'm Onofre E. Algara Jr., Engineering Operations Manager at SMEDD Corp. I've been with the company for 5 years and 8 months. I started my engineering career as a resident engineer assigned at SM City Santa Rosa way back 2015. Adjusting from being a student to a licensed electrical engineer is really intimidating. But I owe everything I learned in the world of engineering to SM. I was assigned to monitor everything about METs, how equipment operates, and how it is maintained. But now, as an operations manager handling standalone stores, I have to see through every project detail submitted by my REs for the benefit of the company and the clients. So in general, I must still have the technical knowledge as an RE and at the same time, talent in people management. The most challenging experience I have encountered where my capabilities are really tested is the electrical fault happened in one of my branches handled. So normal electrical supply have been compromised and backup power is getting out of control. But despite all of this, the show must go on or the mall must be open. But after all, hindi ko naman mabilang yung learnings and it was really worth it. I learned a lot from my boss. Multitasking, working on pressure, and most importantly, malasakit. So he used to tell me, think the company as your own. And these are my everyday guidelines every time I go to work. So sabi nga nila, if you like or love your job, you don't have to work. And for me, that's how SM keeps an employee like me. Having the mentality of keeping yourself busy can get to top. Just like any other company, SM is a continuously improving despite this pandemic that we are facing. There are still things to be standardized when it comes to cost, guidelines, and others. As a proud member of the engineering group or engineering arm of SM Group, if someone wants to prosper in their career, uh, think what you can give to the company rather than what you can get. By doing your job, you'll get to learn unexpected things, and this will be enough reason for you to stand out. SMADD have had given me the once in a lifetime opportunity to level up my skills in the field of engineering.
Hello everyone! I am Val and I am here to guide you on how you can become a member of SMEDD through our seamless talent acquisition process. In order for you to know what are the vacancies in SMEDD and select the best opportunity that suits your qualifications and experiences, please go to our website at smprimecareers.com/SMEDD or scan the QR code. When we receive your profile, our recruitment team will send you an application form. As soon as we receive and review your profile, we will contact you and conduct an online interview. Once you pass the initial interview, you will be sent a link for our tests. These tests are video proctored and can be done at the comforts of your home. Upon passing the exam, you will be scheduled for an interview. Our recruitment team will get in touch with you before sending a calendar invite for the next level interviews. Technical interviews will be conducted by our hiring managers. Once you pass, you shall be given a job offer and medical endorsement. Secure your medical clearance and complete your pre-employment requirements. You shall be given your start date and attend our onboarding program. So, what are you waiting for? Please visit our website or scan the QR code found on the screen and be one of us. This is SMEDD, proud to be the best project delivery company built by you.
Good afternoon sa ating lahat. So gising pa po ba kayo? Before po tayo magproceed to our next speaker, I will be announcing the winners of the raffle from Prisma Electric, yung mga nag-visit po sa kanilang booth. So the winner for the major prizes, Sir Jules Sir Del Rosario for a leather sling bag. For a laptop bag, Sir Ronald Proel. For the winner of the minor prizes of a USB and a foldable echo bag, Sir Mark Santiago. Francisco Chu. Mark Philip Saragena, Sir Ricky Riveza, and Sir Edgar Rasalan. For the winner of towel plus a foldable echo bag, Sir Mike Andrew Cabrera, Sir Juniel Balza, Sir Romel Nacionales, Sir Peter Daroy Magbanwa, Sir Axel Habab, and Sir Joseph Acuna. For the winners, the Prisma Electric representative just posted the names for your reference at the chat box, and also they posted the link. So please provide your contact details by messaging them at their FB page, www.facebook.com/prismaelectricalph. And now we will be presenting to you an audio-video presentation from Meralco.
I'm David Saldran. In this edition of Power Ideas, we talk to Kevin Benning, Chief Operating Officer of City of Dreams Manila, about how the integrated resort has embarked on a campaign towards sustainability. You know, in a city known for having one of the world's most spectacular sunsets, City of Dreams Manila is the first integrated resort in the country to harness solar energy in equally spectacular fashion. So, hello there, Kevin. You know, if it wasn't for the pandemic, I would have loved to see in person, physically, how City of Dreams Manila was able to transform the rooftops of your parking buildings to generate solar power. But I guess a virtual tour with you would be the best for now, right?
Hi, David. Yes, it is. You know, welcome to the new normal. We're doing our best to make it work, and I cannot wait to take you on a personal tour of our rooftop when we go back to normal.
All right, Kevin, I'm looking forward to that visit. In the meantime, let's talk about how City of Dreams Manila has made a conscious decision to reduce its carbon footprint, with solar power being one of those initiatives. You currently have, I understand, 3,120 solar panels installed in the rooftops of 2 parking buildings, right? Now, that's the record for the largest installation in Metro Manila. The amount of power produced by these solar panels is enough to light up 12,000 homes for a year, with an average monthly bill of 1,500 pesos.
That is correct. The City of Dreams Manila is extremely proud to be the first integrated resort in the country to harness solar energy. Now, this project, we invested 76 million pesos at 1.2 megawatts of solar power into this property, maximizing our car park, as we mentioned. It's an extremely important step for us to achieve our goal for carbon neutrality and becoming a zero waste resort. You know, having a clean, renewable source of energy with no waste or emissions is just the right thing to do in our world moving forward.
That sounds really fantastic, Kevin. Congratulations. But I want to know, what are we looking at in terms of savings in power costs?
Oh, we're looking at about 16 million pesos of energy savings per year. That equals about 20% of our hotel power consumption across our 940 rooms. But more than savings, we're looking at the larger picture. As an environmentally responsible business, we must do our share in the global movement to combat climate change, and we want to make a difference and fulfill our social responsibility.
Why did you choose Meralco subsidiary, Spectrum, as your partner?
I was asked this question quite a few times in December when we launched this program and implemented our solar panels. And the answer is very simple. Spectrum provides the best solutions, services, and capabilities in the Philippines in regards to solar and energy saving solutions. You know, on top of that, with Spectrum being a subsidiary of Meralco, who is somebody we've worked extremely closely with since we started City of Dreams, we have a great level of trust in the long-term vision of Spectrum. And something I continue to share with everyone is the speed and efficiency of which this project came together. You know, it was only 4 months from start to finish when we partnered with Spectrum in July of 2019 to launch this fully in December of 2019. I've been working here for 5 years, and I've yet to see a project come together as quickly and as well as this one did.
I also understand, Kevin, there are other initiatives within your resort complex which are geared towards self-sufficiency, correct? All of which fall under your Sustainable Dreams program. So tell me more about this program of yours.
Part of our overall sustainability strategy for Melco Resorts and Entertainment across all of our properties in Asia and Europe. We launched here in Manila the Sustainable Dreams program in 2018. And that's really focused on long-term sustainability initiatives across multiple channels.
Wow, that's an amazing list of programs. And the best thing about it is, these are all long-term programs with long-term effects. So whether there's a pandemic or not, Kevin, like those solar panels of yours, for example, they'll continue to generate power, whether there's a pandemic or not. You know what, as they say in your industry, the house always wins. But at City of Dreams, Manila, looks like the environment wins as well.
That's absolutely true, David. Thank you so much.
And thank you so much as well, Kevin Benning, COO of City of Dreams, Manila. Stay safe, Kevin.
You as well.
This is David Saldran for Power Ideas by Meralco.
So that was an AVP presentation from Meralco. At this point, allow me to introduce our next research speaker. He is a registered electrical engineer with 25 years of diversified experience in the field of electrical engineering. His specialization is in power quality, energy efficiency, and power systems engineering. He is a graduate of BSEE at Central Colleges of the Philippines, Quezon City. He is the CEO of RPV Electrotech Power System Inc. He was appointed as Metro Manila Regional Governor in 2019 and 2020 IIEE National Secretary. At present, he is the National Vice President for External of the Institute of Integrated Electrical Engineers of the Philippines. He is an ASEAN Certified Energy Manager and currently a Board of Trustee of ENPAP 4.0. He is also the Corporate Secretary of the Society of Philippine Electrotechnical Construction or SPECS for 2020 and 2021. He is the Manggahan Pasig member of Pasig City Development Council and the elected chairperson on Infrastructure Committee of CDC. Ladies and gentlemen, let us welcome Engineer Roland P. Vasquez.
Hi, good afternoon, everyone. Thank you, Miss Yasmin. So I will seek the assistance of our technical staff for my presentation because I'm using my mobile phone at the moment. Okay, actually my presentation is about, it's a sponsored presentation po. So so pasensya na po kayo at I'll be promoting my products and services. But as much as possible, I will be presenting po also technical solutions, no? So that we will be learning not only the products and services but as well as the application of the power equipment. Particularly po ang discussion ko will go on the power equipment solution for contestable customers in power industry. So actually ginandahan ko lang yung title, parang ang dating talagang technical, no? But actually this is a sponsored presentation po. So again, congratulations to Metro West for the success of the 7th Metro Manila Regional Conference. And thank you po for all our participants today. So please bear with me for 30 minutes for presenting our products and services. So next slide, please. So RPB Electrotech Power System Inc. core business basically is all related to power system equipment, devices, medium voltage, low voltage, power quality solution, energy efficiency solution. And also we do the installation, testing, commissioning, and maintenance of power system equipment, power quality audit and consultancy work, energy audit and consultancy work. Okay, so next slide po. So this is just basic single line diagram of a distribution system. So from the primary side up to the low voltage side, we provide the equipment solution po. Next slide please. So ito po yung mga products namin. No? So we supplied power transformer, substation, pad mount, cast resin. We also supply a load break switch, the conventional type. Ito po yung mga pole mounted, no? Conventional type. And meron na rin po kami nung electrically powered LBS. So the recloser, the current limiting power fuse, the lightning arrestor, of course the medium voltage power cable, termination kit, vacuum circuit breaker, vacuum transfer switch, vacuum contactor switch, even a medium voltage power capacitor and generator set, usually 4,160 volt, medium voltage CTPT and power relays. Next. So sa low voltage naman po, you're all familiar with this, no? The dry type transformer, air circuit breaker, MCCB, digital metering, motor protection relay, current transformer, whether it's solid, split type, flexible type, meron po tayo niyan. And we do assembly of the capacitor bank, ATS, sync panel, LBSG, panel board, MCC. So with regards to breakers po, we are using usually the known brand. So open naman po kami sa brand when it comes to breakers. So next. So this is just the brand that we carry. So next. So this is our brand for our power and distribution transformers. We also distribute the medium voltage devices from Bitstro and EnerSwitch. Next, please. Medyo maliit na po ito. Ito po yung eco load break switch namin. So medyo maliit yung presentation. Next. Next po, please. This is we can supply high voltage DTCT, no, 115 up to 240 kV. Also the medium voltage indoor outdoor and the usual low voltage CT. Next. So we supply energy metering from MicroStar, in which we have an OEM branding, as well as from Accu Energy, AccuBeam. Next. We also supply portable elite logger, portable polyphase logger, as well as power quality analyzer. Next. We also supply lightning arrestor, Bakiral, from Turkey, and Enertronics for the surge protective device. Our Enertronics is UL listed. So we also supply automatic voltage stabilizer. So we have two types of technology po. We have the static voltage, we call it SBS, static voltage stabilizer. So wala po siyang moving parts. Basically, they are using thyristor for its switching. So meron din po tayong servo type using a rolling type carbon brush. So we can also supply UPS. Next. So this is the usual generator and the synchro and the usual LBSG panel. Next. All right. So ito po 'yun, no, yung aming summary. So doon po sa topic ko, no, about power equipment solution for contestable market. So we are much familiar that due to our law of IPIRA, we were able to access now a choice of our GenCos through our COA. So yung tinatawag po nating retail competition, no, and open access. So possibly all of you are aware na ang contestable market po before is only 1 megawatt, no? So if you are a customer in which you have an average capacity of 1 megawatt, you can apply for contestability, no? So I think 5 years ago, it was reduced to 750 kilowatt. So ibig sabihin, if you are under 750 kilowatt average, you are using that capacity, the distribution utility will reflect to your bill that you are already a contestable customer. Okay. So now, very recent, this year only, I think if I'm not mistaken, February of this year, the 750 kilowatt were already reduced to 500 kilowatt capacity. So ibig pong sabihin, if you're using for the last 1 year 500 kilowatt average, you can now also avail the contestability market. So ano pong ibig sabihin nun? So once under ka na ng contestable market, you can choose your GenCo through your retail electricity supplier o yung RES natin. So of course may mga requirement po yun. So you need to get your certificate from ERC. That's one of the requirement. And of course you need to choose your RES para maka-avail ka. The good thing is you can now negotiate with your RES the rate for your generation, yung rate nyo. If you can get a magkano ba rate ngayon? If you can get lower, alam ko yata mga 4 pesos, so ganun. So you can choose for your RES, no, a better rate for the generation charge. Pero ano po 'yon? Sa ngayon, meron pong requirement 'yon. So dito po papasok yung topic ko, no, about the power equipment solution. So if you can only avail the contestability or apply for the contestability to your utility, but you must transfer your system to primary metering. Okay po. So for example, kung existing customer ka po and you already reached the limit now, no, even 500 kilowatt, you need to, and your existing metering is secondary metering, you need to transfer to primary metering. So ano pong ibig sabihin nun? So you need to provide your own transformer, you need to provide your own first private pole in order for you to avail the contestability. Okay? So yun po yun. So yun po, kaya po yung power equipment solution ko na binanggit sa presentation na to is basically to avail the primary metering solution and to match up that equipment to a smart energy metering para po maging effective and efficient po yung system mo. So, kumbaga ano yon, 2 in a row yun. So, naka-avail ka na ng ARCOA. Once you have also the smart metering, you can also comply with the latest ngayon, yung law, yung regarding naman po dun sa RA 11285. So once you have the smart metering, you were able to monitor your power and at the same time comply also with RA 11285. So basically po, I'll be discussing about transformer, siguro a bit background of first private pole and also the smart metering. So okay, so next slide po. Okay, so as I mentioned, so if you want to avail that yung ARCOA natin, so you need to transfer to primary metering. So kung for example, 750 kilowatt ka ngayon na tatlong 250 ka na naka-bank sa utility mo, so you need to get your own transformer. So mostly kapag pag privately owned na yung transformer mo, it's better if it's a pad mount, no? So within your facility na. So I'll be discussing here a pad mount transformer. So dito po we can supply even 500 kilowatt or even lower. So next slide po. So our pad mount transformer is from Korea. So we can supply up to as big as, if I'm not mistaken, they even have 10 MVA for pad mount, pero hindi pa ako nakapag-supply ng ganung kalaking pad mount, no? But our transformer is actually a UL listed pad mount transformer, no? Yung UL listing nila capacity is up to 6 MVA. So I think the biggest pad mount transformer I supplied in Philippines pad mount, yung ganito, yung compartmentalized, I think it's only 3 MVA. So usually pag mga 5 MVA kasi hindi ang popular yung hindi na pad mount type. So next slide. So basically ito lang yung sa design verification. So medyo madami yung slide ko, so skip na lang natin yung iba. So next slide po. So this is the production side ng transformer namin from Korea, the magnetic core. So next slide. So crucial po yung yung mga magnetic core, yung of course yung winding. The good thing about Korea, yung pong pinakamalaking steel company, yung POSCO, naandyan po sa Korea. Kaya even yung mga manufacturer sa Europe, even Turkey, yung pong mga core nila, most of the time galing pang Korea, no? Kaya yun ang reason kung bakit competitive si Korea sa transformer. So for the winding, so of course like any other manufacturer, they can provide both copper and aluminum. So in some manufacturers, they combine this type of winding, so because of cost, no? So next. So they are using Nomex insulation. So this is the manufacturing plant. So this is this is about their testing facility, no? So they conduct the routine test and the type test as well, and special test. So next. So this is a sample specification of a pad mount transformer. Okay, this is for a 2 MVA transformer. This is a 2 MVA 13.2 400 volts DYN11. So okay, so delta Y. So next. Okay, so here are the contents of a sample data sheet. Next po. So ang pad mount transformer po, it is actually a ANSI type standard. So pag kung makakita po kayo ng mga pad mount, yung yung usual nating nakikita like sa Meralco, yung mga green type nila na transformer, it's actually an American standard. So the standard use is ANSI IEEE C57 .12, no. So yan po ang standard niya. So yung usual po na nakikita natin na mga substation type, yung mga common na bushing nasa yung usual na nakikita natin, yung bushing nasa ibabaw, both primary and secondary, most of them po are IEC type transformer. So okay, so actually sa standard, particularly sa BPS, no. So ang karaniwan tanong diyan, ano bang difference ng American sa IEC standard? Ano ba yung mga common na difference nila, no? So una, yung construction, kasi nga itong pad mount, makikita natin ang primary bushing niya nasa compartmentalized, no, para siyang cabinet. Ang primary niya usually nasa left, ang secondary niya nasa right. So parang cabinet style lang siya. So kaya tinawag na compartmentalized. While the IEC, yun nasa top bushing. But one of the major difference of the two, no, siguro yung iba alam ito, but maybe some are not familiar with this, no. Ang one of the major difference ng American sa IEC transformer, yung rating po ng American standard is based on the secondary side, while the European side, the European standard is based on the primary side. So that's why if we are talking about 1 MVA, so an American standard 1 MVA, it's output. So ibig sabihin, you can load up to 1 MVA load, no, capacity, while the European is on the primary side. Ano pong ibig sabihin? So yung losses ng transformer mo nakakarga na agad dun sa capacity mo. So yun po yung isang difference nila. So okay, so next slide. Okay, this is just service condition, technical data. Next slide na po. Naku, maliit masyado. I'm not sure if you can see this one. So but basically this is the technical data we provide. So usually diyan po nakalagay kung pad mount yan, kung ano yung cooling method. Ang pad mount ho, meron tinatawag na loop type and radial feed, no? So ibig sabihin, kung ang load mo is mostly dedicated for one transformer lang, radial type po yan, while yung others naman nilulupid nila. So that's the two type of pad mount din, no? So okay, ano pa bang critical? So yung fluid, no, mostly po sa pad mount, usually sa pad mount, especially sa indoor, there are a lot of consultant specified the less flammable fluid, no. So usually ang in-specify nila FR3 pag indoor type. So actually po yung FR3, it's a brand of oil. So it is manufactured by Cargill. So pero ang generic name po niyan is vegetable oil actually. So in Korea, they have also equivalent for that. So we call it Biotran. So it's also a UL listed oil similar to FR3 of Cargill. So but kung outdoor naman po ang location ng pad mount nyo, you can use the mineral oil kasi medyo expensive po kasi itong vegetable oil. Medyo malaki ang impact sa cost ng transformer. Okay, so next. The construction, the core, the winding. So yung pong core natin, actually medyo ano po yan, may mga development na rin sa core, no? May tinatawag na tayo na mga amorphous core. So yung less yung pong less yung yung losses. So very common po yan ngayon sa mga pole mounted, no? So sa winding naman po, as I mentioned, copper and aluminum lang naman ang choice niyan. So mas usually ang aluminum ho, mas mura siya kung aluminum yung gagamitin nyo, but you will expect that the dimension of your transformer will also increase kasi medyo magiging bulky, a little bit bulky kapag nag-aluminum po kayo. Tanks and fittings. So next po. Of course yung radiator po, diyan nagpo-flow yung ating oil, no? O the insulating oil and the paint finish. So next po, next. So these are the tests, no, under IEEE C5712. So we have the routine test, which is the measurement of winding resistance, measurement of voltage ratio, and check of phase displacement, measurement of short circuit impedance load, measurement of no load, dielectric routine. Okay, sa type test naman po, we have the temperature rise test, the sound level test. Okay, so next po. Okay, so when you order, you can have some spare, no, if you would like, no. So next, spare part list. Kung gusto mong magsama ng spare, like for example, yung temperature gauge niya, you want to have spare. So pwede naman po 'yan. But mostly hindi na po muna kami nagsasama. So this is the nameplate. Usually sa nameplate naka-indicate po diyan yung mga specs and the vector diagram. Next po. So this is the specs for the bayonet fuse. Next. So usually we provide a drawing, no, para doon so you can have it confirmed on the location, no. So we can also provide the drawing in advance, no, even during the bidding process if it's necessary for the evaluation. Next. So ito na lang yung pinaka base, no, kung if you would for your preparation on your foundation. Next po. So this is the actual picture of the unit. So as I mentioned, the left side is the primary side and the right side is the secondary. So meron pong separator yan, no, sa gitna nila. Okay, so ganyan po yan. So in America, they call it compartmentalized type. Okay, next. So this is just the sub-vendors list, no? So we provide this. So if you will notice, dahil American style po ang pad mount, there are some component that also used from US, no? Like the elbow, the bushing, it's coming from USA. So next. So ito po yun, no? So these are American component, American source from American brand. So next po. So this is the secondary bushing. Ito po yung low voltage side natin. So next po. Bayonet fuse, these are from US. Current limiting fuse. Next. These are the elbow. So the surge arrestor or the metal oxide varistor elbow, this is an option to a pod mount transformer. So option po siya. So mostly kasi sa first private pole meron na po tayo dong surge arrestor, but if you really want to protect your transformer and your load, pwede ka pong maglagay ng surge arrestor on the primary side. Yung pong tinatawag nating SPD, yung surge protective device, which are in the low voltage, usually kinakabit natin sa low voltage side, protection din po siya. So ang sabi nung iba, masyado naman redundant. Actually, ang protection po sa surge, okay lang po yan kung redundant. Ibig pong sabihin, every time na may energy ng surge na pumasok, kasi pagdating sa first private pole, magdi-dissipate lang yan doon sa grounding wire mo sa pole, yung grounding mo sa poste mo. So meron pa rin pong energy na pumapasok dyan. So pagpasok niya sa primary side ng pad mount mo, meron kang sinamahan mo nitong primary surge arrestor, most likely kung may lulusot pa rin dyan sa secondary, may SPD ka pa rin doon, wala na talagang makakalusot sa load. So yan po ang kagalingan ng redundancy of surge protection. Next po. Okay, yung previous components are from US, but this one are all from Korea na, no? Oil level gauge, the pressure relief device, the temperature indicator, yan. Korea na po yan galing. Next. So, as I mentioned, in Korea, we can provide the vegetable oil. Our brand is Biotran, so they are also UL listed oil, no? Similar to FR3 of Cargill. Next. Ayan, yan yung kanilang certificate of compliance for the oil. Next. So this is a certificate of compliance for the and also the UL rating certificate of our pad mount transformer. Next. Masyadong maliit. Okay. Next. So ito po yung mga reference list. So right now we have an ongoing in Batangas Port for two units of 2 MVA pad mount transformer. Okay, so next po. Okay, so yun po yung sa sa primary metering. As I mentioned, so kung if you really want to avail, if you want to be in a contestable market, you need to connect in primary connection. So ngayon po 500 kilowatt na, mostly 500 kilowatt mga naka-secondary metering yan. Ang hindi ko lang ho alam sa ngayon, kasi since ang sequence kasi na nangyayari sa kung mapapansin nyo lang ho yung sequence ng pagbaba ng ng limit from 1 megawatt to 750 kilowatt to 500 kilowatt, pero mga I think 5 or 6 years nangyari yun, no? From 750 tapos itong February lang this year. So I just don't know how many years bababa po yan. Kung bababa pa yan, sabi kasi ng dyan, up to the household level daw yan. Pero kung it takes 6 years, bumaba from 750 to 500, another 6 years kaya o 5 years bago bumaba ng 250 kilowatt. So, yan po yung another question. So by that time, ang hindi ko lang humasagot, maybe we have some Meralco people here. Ang hindi ko lang masagot kung bababa ng 250 kilowatt yan, kung kailangan pa bang i-primary metering. So siguro there will be a new policy on that. So ito naman po yung mga protection sa transformer, no? Vacuum circuit breaker. Yeah, we can supply BCB. Next po. Okay, so this is an indoor load break switch. We can also supply we also use this kind of LBS for outdoor. So a mechanical type LBS. So next po. Usually po sa first private pole, we have this kind of LBS. Ito po yung common na yung mechanical type. But the problem po ng mechanical type LBS, later on ho yung maintenance, kasi yung konta kasi niyan dapat nililinis din yan on a yearly or every 2 years eh. Kasi minsan nagkakaroon ng difficulty on let's say nagkaroon kayo ng trouble, no, dinisconnect niyo yung transformer, sometimes diyan po nagkakaroon ng problema sa contact, minsan hindi magsara, minsan nagkakaroon ng arcing. So kaya may option po tayo to go on yung latest technology ngayon, yung halos maintenance free na yun eh, yung eco-friendly na yung vacuum interrupter type na LBS. Okay, so these are just the component, the fuse, current limiting fuse. Next po. Next po. Okay, so this is a vacuum transfer switch. If you have medium voltage generator, you want to transfer it to your, of course, your medium voltage utility, pwede po yan. Next. Yeah, this is so saan po namin ginagamit yung vacuum contactor? This is usually for kung meron kang sa mga motor po ito, medium voltage motor, and sometimes in medium voltage capacitor bank. Next po. Okay, so I just don't know kung meron pa akong time. Ayokong i-spoil yung oras kung sakaling do I still have time po? So sige, ituloy ko na lang muna. Just tell me kung sorry.
Yes, sir. Yung regarding sa inquiry niyo sa time, 30 minutes na po siya.
Wala nang oras. Wala na ba? Can I still have 5 minutes, ma'am?
Okay,
or wala
sir.
na
You
talaga?
may have your 5 minutes to wrap up po.
Okay, sige. Okay, so as I mentioned earlier, so doon sa power equipment solution for contestable market, no? Let's say so nag-avail ka na nga, no? You have the primary equipment, the transformer, primary first private pole, your own transformer. Ang importante po, you match it with your own smart meter. So especially now na meron din tayong bagong batas, yung RA 11285 na nagre-require po ng submittal of your energy profiling. So once you have that, two in a row na yung solution mo ngayon. So namamanage mo na yung energy profiling mo. So you can also use that in submitting your energy profiling to the utility. So yung magiging CEM mo or SECO mo can utilize that technology. So of course marami pong mga metering supplier, maraming brand, and we also have our own. So ang advantage po nung aming metering naman, you can connect it into cloud, and once you have our hardware, you can access the cloud. We can assist you on how to avail in accessing the cloud. So in the interest of time, siguro ano na lang po yung slide ko. Ano na lang po. Next slide na lang. Okay, ito po yung architecture, no? Okay, so ayan po yung architecture. So this is AccuBeam 2. So meron po kaming flexible city kung may mga challenges po, especially kung existing po yung system nyo, no, may hirapan sa split core at donut. Okay, so next po. Okay, so sige po, next po. Yun. Nawala na. O sige, next. Skip muna po. Skip muna. Punta na lang tayo ron sa ano. So this is just the RA 11285. Paki-skip na po yan. Sige pa. Okay, so yan. So usually po ang having a smart meter, kailangan po yung meter nyo must have these features, no? Una, make sure it has a very good accuracy. So point 2 is a revenue accuracy po yan. So ibig sabihin, yan po ang accuracy ng utility. Yung pong mga meter natin ng Meralco, it's class 0.2 or 0.3. So make sure if you will get a smart meter, make sure it has high accuracy. It has a memory na you can use for data logging. And of course, aside from multi-function, it has all the communication capability to connect in your system. Kumbaga added ano na lang yan kung if it's UL listed and others, no. So yun po yung mga ano. Next po. Yeah, this is just the function. Next. So yun po yung ano, no. So yung smart meter nyo po must adapt to a different platform, no. So yung one of the platform nitong namin is yung pong manufacturer, you can connect it easily on cloud. So but of course initially we can assist you on how to do it. But madali lang po siya actually. Next. So it has data logging function, time of use, waveform, power quality, blah blah blah. Next. Next po. Next, okay. So medyo maliit po siya, no? So si AccuBeam po, they have 4 variety. So the standard model, the AccuBeam 2, the AccuBeam 2R which has a memory, the AccuBeam 2, what's the other one? 2E, time of use lang yon. Yung AccuBeam 2W is a power quality meter. Basically, yun lang po yung description niya. Next. So this is a multi-circuit multifunction meter. So ibig po sabihin kung meron po kayong mga circuit na up to 18 single phase, kaya pong i-monitor ng isang meter na to. So for example, ang isang panel board mo, you have 18 branches, single phase, you want to monitor. Isang metro lang po 'yon. So kung 3 phase naman, 6 3-phase load kasi 6 times 3, di ba? Kaya po 'yan. So this one can also connect to cloud. Next po. I have only 2 minutes. So next po. So these are the accessory mostly for communication or if you want to have digital input output. So plug in lang po ito sa meter. So if you like if you need this accessory, ipa-plug in lang po natin siya. Next po. Next. Yeah, this is just specifications. And next. This is the connection. So different configuration, single phase, 2-wire, 3-wire, 3-phase, 3-phase, 3-wire, 4-wire. So universal design po siya. Next. Okay, ito po yung connection lang sa mga accessory to, sa mga module. Next po. So we also have the portable type, no? So for those who would like to avail a portable type, so meron po kami. This one is imported from Canada. Ito pong setup na to. Next. Ito naman po, locally kami na ang nag-assemble. But of course, the component is also from Canada. So we have this one kasi medyo a little bit cheaper. So we use this one for a multiple power auditing namin. So next. Okay, siguro I will end up here. So this is our current transformer. So we can have split core, solid core, flexible CT. So meron pa pong kasunod to but mostly for the communication na lang and doon sa connection sa cloud. But we can give you a copy of this presentation po, for those who are interested. Thank you very much po. Thank you, Metro South. Congratulations again to our regional governor, Gob Alwin. Congrats, ha. Salamat po.
Thank you very much, Engineer Roland P. Vasquez. So if you have any questions to Sir Roland, you may chat him at the question and answer box and the question and the chat box. So at this moment, we will now present our certificate of appreciation. May we call on stage the Secretary General of Metro Manila Region, Engineer Manny de Guzman, and the host chapter president, Engineer Giovanni F. Tagata, and also our governor for Metro Manila Region, Engineer Alwin Wagan. Certificate of Appreciation is awarded to Roland P. Vasquez in grateful acknowledgement and appreciation of his invaluable service and professional thoughts shared as a resource speaker for a sponsored technical presentation on the topic entitled Power Equipment Solutions for Contestable Customers in Power Industry during the IIEE 7th Metro Manila Regional Conference, a hybrid event with the theme Got One IIEE, transcending the challenges in the new normal by embracing resiliency and complementarity. Given the 6th day of August 2021 at the IIEE building, Cubao, Quezon City, and via Zoom cloud meetings. Signed, Engineer John Regis Estrosio, Engineer Giovanni F. Tagatak, Engineer Manuel M. de Guzman, and Engineer Alwin M. Wagan. Once again, ladies and gentlemen, let's give them a round of applause. Sir, yung salute sign daw, sir. Ayan, thank you very much, RPV.
Congrats, guys. Ibang klase talaga kayo. May saludo pa talaga.
Once again, thank you very much to our National Vice President for External Affairs, Engineer Roland P. Vasquez. And we will now proceed to our next topic for this afternoon. He is the chairman of the IIE Legislative and Legal Affairs Committee. He is very familiar with the Electric Industry Reform Act, RA 9136, the Philippine Grid and Distribution Codes, and WESM rules. He was the former national president of the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, in 2006. He has been a recipient of various recognition awards and citations, including Presidential and Philippines Civil Service Commission Awards. He is currently employed with the National Grid Corporation of the Philippines as Chief Engineer for Substations, North Central Mindanao Area, Mindanao Operations and Maintenance. Let us all welcome for the topic the proposed new EE law, no other than Engineer Leo S. Cabasag.
Hello.
Good afternoon, sir.
Good afternoon. How's my audio?
It's clear, sir.
Okay. First and foremost, I would like to express my gratitude for the invitation of Metro West for the 7th Metro Manila Regional Conference hosted by Metro West Chapter. And of course, my congratulations also to the host chapter. for a successful virtual conference. So, did you see my presentation already?
Yes, sir. We have it now on screen.
Okay, thank you.
Thank you.
So greetings from the Institute of Integrated Electrical Engineers of the Philippines, the sole national organization for licensed electrical practitioners, duly recognized and accredited by the Professional Regulation Commission. IIE has been existing as a national organization since 1975 as a result of the merger of the then PSCE, or the Philippine Society of Electrical Engineers, and the PIEE, Philippine Institute of Electrical Engineers. IIE is in its 46th year and counting. With more than 55,000 active membership, we are one of the strongest amongst the accredited professional organizations of the country and have been conferred twice as the most outstanding PRC accredited professional organization. So let's go back to history. From Republic Act 184, then going to RS 2920, and this new proposed electrical engineering law. What's next? Would it be better or worse? Republic 184 has been a law since 1947. This is the first electrical engineering regulatory law of the Republic that was enacted last 1947, the time immediately after the World War II. RA 184 lasted for 48 years, covering 2 generations. History has it that the original electrical engineering law, known as Republic Act 184, was enacted in 1947, the time immediately after the World War II. The Republic was then young, a fledgling nation struggling to recover from the ravages of war, and where, for the first time in its history, a regulatory law made mandatory to electrical engineering as a profession. As an infantile profession, RA 184 served its very purpose. Yes, most significant of which was the assembling, synthesizing, and licensing of the scattered but qualified individuals, whether they were electrical engineering graduates from a handful colleges or universities at that time, or those who were non-graduates but skilled experts whose capabilities and competencies were derived from mentors during the then American regime. As called for, RA 184 succeeded in professionalizing the practice of the profession, its scope and limitations, and other professional necessities for a society that fits that time. For 48 years, in 2 generations, RA 184 was the electrical engineering law of the country, and it served well. Now, the RA 7920, or known as the new electrical engineering law, was enacted last 1995. The entry of Republic Act 184, like any other laws, RA 184 outlived its usefulness, and in 1995, RA 7920 came to replace and repeal RA 184. The salient point of Republic Act 7920 brought was the licensing of electrical engineers, limiting only to persons who have completed Bachelor of Science degree in electrical engineering. This was appropriate for the time because since 1947, a good number of electrical engineering graduates had already become available for the board examinations, along with the fact that original non-graduates who were conferred licenses as electrical engineers of circa RA 184 have already been fading out of this world. For almost 20 years and up to the present, RA 7920 has been EA's regulatory law. Compared to RA 184, there were changes focused particularly on the provisions specific to the practice of the profession. RA 7920 at the outset was an improvement over RA 184, but along its strengths, there were also lies more weaknesses. Amongst its weaknesses, RA 7920, albeit unintentional, imprints a question mark on the issue of employability. That is one thing amongst these licensed electrical engineers. In RA 7920, the REE, notwithstanding fresh and young or heavily experienced, whatever he may be or she may be, can practice the whole scope of that profession except signing and sealing. So then, in effect, if the condition of the employment does not require signing and sealing, there's no need for the PEE to be around. To repeat, the only difference between the PE and REE is signing and sealing. That is in Republic Act 7920. In further effect, should there be any vacant position in the industries previously requiring PE in circa RA 184, the PE is no longer necessary in Republic Act 7920. In other words, a huge plant does not require any more PEs, but one REE can stand for the entire plant as an overall engineer in charge. Fact is, since the specific or unique role of the PE from that of the REE is now only signing and sealing, then a PE somewhere in the neighborhood can fill in the job of just affixing his signature and stamping his seal on documents required of him. If there is only one PE left alive in this country, RA 7920 still works. The thin line between PE from that of the REE somehow made the PE less or no longer employable in establishment. Now, drifting out of the wings of the industry, this unfortunate condition had inadvertently caused to develop a culture of signing and sealing for a fee. This culture made many PEs relegated to become paralegal public engineers, signing and sealing plans and documents made by whoever comes. Without any personal interest, let us look deeper. However, it is not worthy to say that signing and sealing as a job never was the intent of the law. Why? Because signing and sealing is never a job. Because it is not a job, signing and sealing must not be remunerated for. Isn't it? Signing and sealing is the ultimate part of the PE's responsibility and accountability. In designing electrical systems, and that the signature and the stamp of the seal is meant that the plans and designs reflected on the documents are professionally done by him or under his strict supervision and is guaranteed by him to be safe to humanity and properties for the next 15 years. Again, is signing and selling a job to make money for? Is signing and selling a scope of work? Is the culture of signing and selling plans for a fee the intent of the law? Let's mirror the United States of America. Relative to ours, it is always reinforcing to mirror at how the advanced countries are doing their licensure processes. For engineers in the USA, there are only two grades, namely the EIT and the PE. The EIT, the EIT is the engineer in training. Licensure in the USA can only be availed by the graduates from an ABET accredited four-year college or university program. ABET is Accreditation Board for Engineering and Technology with a degree in engineering. For example, Bachelor of Engineering, Bachelor of Science in Engineering, Master of Science in Engineering, Master of Engineering, or Doctorate in Engineering. The engineering training for the EIT licensed applicant, he has to pass the so-called fundamentals of engineering written examination, which tests the applicants on the breadth of his understanding of basic engineering principles and the elements of an engineering specialty practices. Completion of the first two steps qualifies applicants for certification as engineer in training, also known as the engineer intern. The PE, the professional engineer, the EIT licensee, upon accumulating a certain amount of engineering experience, in most states 4 years, can submit himself to a written principles and practices in engineering PE examination, which tests the applicant's knowledge and skills in their chosen engineering discipline, civil, electrical, industrial, mechanical, and others. Passing the PE exam will qualify the EIT to next level license of professional engineer or PE. The PEs in the USA are the only ones authorized to design, sign, and seal plans and specifications. In the Philippines scenario, looking at both processes of licensure, the EIT is the RE and the PE is the PE in the Philippines. The big difference in the EIT or EI in the USA is only licensed to be trained or licensed as an intern under the official mentorship of a PE. In the Philippines, the REE is licensed to practice the full scope of the profession, where signing and sealing is not required, and thus is permitted to handle an entire huge industrial complex for as long as there is no signing and sealing of plans involved. So then, what does it mean? Isn't it that REE has the best in the world under RE 7920? Under the present law, it seems that the REEs have the edge in employability over any other grades. But then no, since RA 7920 has no mention about capacity, levels, nor voltage limitations. The scope of the RE, except for signing and sealing, appears to be limitless. It sounds awesomely good tidings to the REEs, but it is the same advantage that renders it disadvantageous. Without any personal interest, let us look deeper. A very huge industrial complex composing of a power plant with clusters of manufacturing plants of different voltages under RA 720 only needs one fresh from school RE per shift for the entire complex. That brings the required complement of the electrical engineers to the very impractical minimum, but still lawfully compliant. But note that the overwhelming majority of the electrical engineering community are employed in the industries and in large commercial complexes. If a good RE in a good industrial or commercial establishment happens to become a PE, his stock rises, and thus the new PE becomes expectant of a good raise in salary. But the position of a PE in that company is not mandatory. That's not necessary under the present law. So then same RE who now is a PE would soon be promoting himself out of the bounds of the company's willingness to employ. Sadly, he may end up into the target candidate for early retirement. In RA 7920, is the PE employable? Is the REE employable? Is the RME employable? Of course, RA 7920 calls for REE per shift, but then again, because there is no mention of capacity or voltage levels, one RE per shift is still low compliant, even if the capacity is so large that in many cases becomes impractical. About the RME, the RME seemed left behind in RA 7920. This, therefore, is one of the highlights of the proposed new EE law that IIE focuses to improve. Republic Act 7920 in 1995, RA 184 was replaced with RA 7920. RA 7920 was perceived as an improvement of over RA 184 and served as the EE regulatory for 22 years. At present, RA 7920 is still in effect. But along its strengths, there also lies a number of weaknesses. Weaknesses that are no longer responsive to today's realities. So today's realities, there emerge new demands calling for a culture of quality alongside with accountabilities and practice of responsible character. Summarized as follows: the consciousness on quality standards of electrical materials and resources to fit into new creations. The consciousness to the quality of installation and construction methods. Third, the need for quality of electrical plans and designs. Fourth, the need for real tests in the enforcement of electrical practice in the pursuit of public safety and preservation of properties. Fifth, the globalization of professional practice of the Filipino practitioners as demanded by international accords. These are some of the many that have put due pressures to the need to revisit the relevance of our outdated EE law. Given these realities, the proposed new EE law seeks to be responsive, furthermore motivating and more compelling to achieve growth in the profession. That is why we need a fresh electrical engineering law. A law that strengthens the value of the profession as a dignified institution by cultivating a professional practice that is honest, honorable, and of high integrity in the service to society and mankind. A law that seeks a profession of continuing growth and proficiency and competence by promoting a culture of quality and global competitiveness amongst electrical practitioners. A law that addresses the wide gap between the academic output with the realities in the industry as well as pragmatisms inherent in modern practice. A law that advances a profession of high employability that is conducive to work life, to growth in work life and in any local or international arena. A law that guarantees full respect to human safety and preservation of properties by driving a culture of responsibility, liability, and accountability in the practice of the profession. A law that promotes a profession of value and worth to the practitioners, to their employers, to the country and internationally, and a law that ensures the achievement of the fundamental intent of licensing professionals. So this was the first House Bill being filed by IAE. House Bill number 6314 and Senate Bill 1210. This seeks to introduce into the EE law several new substances as follows. One of the highlights number 1, declaration of policy. Note that in Republic Act 7920, there is no declaration of policy. In this bill, declaration of policy states that the state recognizes the importance of electrical practitioners in nation building. Towards this end, the state fosters, develops, and nurtures a pool of proficient and quality electrical engineering practitioners whose standards of practice shall be outstanding, honorable, and globally competitive. The state shall provide rational regulatory measures that are responsive to the growing needs of the electrical engineering professions, considering the advances in technology and globalization. So another highlights number 2, wider definition of terms used as reference in regulating the practice of the electrical profession. The proposed new EE law manifests more comprehensive definition of terms surrounding the profession. From 15 terms defined in RA 7920 to 59 in this new proposed law. The new set of definition of terms will help clear the ambiguity of scopes, coverage of practice, specific systems or processes to differentiate other disciplines and to eliminate misinterpretation. This is on sections 3A to 3SS. So these are the terms, definition of terms, and we will not go one by one. So these are electrical engineering, practice of electrical engineering, electrical practice of responsible character, authorized electrical engineering practitioners, consulting electrical engineer, electrical system designer, electrical engineer in charge, electrical project engineer in charge, electrical systems, so on and so forth. So these are well defined in our proposed law. So this is up to number 59, definition of terms. So the third highlight, more substantive provisions for the field of practice of responsible character of electrical practitioners. The practice of electrical engineering refers to the professional act of responsible character of performing electrical engineering services in the forms of consultancy services, professional design services, management, supervision, or taking charge of electrical construction or projects, operation, maintenance of electrical systems and processes, manufacture, fabrication, and repair of electrical equipment, sale, supply, and distribution of electrical equipment and components. The number 4, teaching of electrical engineering subjects in colleges and universities. Number 5, employment and government offices as electrical engineers. By responsible character, the provision on the fields of practice are enhanced with the civil accountabilities as follows. As professional EE, who authored the plans and designs as electrical system designer on record with the office of the building official shall have full civil liability over the plans, designs, specifications, and contract documents bearing his signature and seal for a period of 15 years. A professional electrical engineer or registered electrical engineer who is directly responsible in the supervision of an electrical construction in compliance of the plans and designs on record with the office of the building official shall have full civil liability over the quality workmanship of the installation process for a period of 15 years. Moreover, the proposed law requires the faithful compliance to the Philippine Electrical Code and Philippine recognized international standards for system designs and installation methods and processes. So that is by responsible character. The fourth highlights clearer mandate on who are authorized to practice electrical technology and electrical engineering professions. A more purposive characterization on who are authorized to practice electrical engineering is better defined. Note that passing the board examination, registration with a PRC as professionals, and taking the professional oath are not enough. In this proposed law, the professional is not allowed to practice unless his professional ID is valid. They may have the license for a lifetime, but without his valid identification, his practice would be a violation. That is on section 3D of the proposed EE law. Who are authorized to practice electrical engineering? Authorized electrical engineering practitioners refers to a person professionally and academically qualified, registered and licensed to practice in any grade of electrical engineering as defined in this Act, with a certificate of registration by the Professional Regulatory Board of Electrical Engineering and a valid identification card issued by the Commission as Professional Electrical Engineer, Registered Electrical Engineer, or Registered Master Electrician. That is on section 3D also. The fifth highlight, clearer mandate on who are authorized to teach electrical engineering courses in colleges and universities. More purposive characterization on who are authorized to teach in the electrical engineering course. Teaching electrical engineering is one of the scope of practice of electrical engineering since history, even in circa 184. Teaching without the authority to practice electrical engineering, as defined in this proposed law, would be a violation. See sections 3B7. In this proposed law, the minimum requirements for the field of practice of teaching electrical engineering shall be for basic electrical engineering subjects and allied sciences, registered EE or PE. For professional electrical engineering subjects, professional EE or registered EE with a master or doctorate degree related to electrical engineering. For basic electrical technology subjects, REE can teach. RME can teach. So highlights number 6. The much improved employability amongst licensed electrical practitioners as embodied in the provision for minimum complement licensed practitioners in power plants, industrial plants, transmission by distribution systems, and commercial complexes. A wider and more comprehensive field and coverage of the practice of the profession, introducing the concept of KVA capacities as a measurable reference for the minimum requirement of complement of licensed personnel is one of the highlights of this proposed law. Note that the reference to KVA or MVA capacities as vis-a-vis requirements of complement of personnel is not covered by both RA 184 and RA 7920. Please note that in Republic Act 7920, the RA is allowed to practice the full scope of the profession without limits as to voltage and capacity, including designing, except selling. This means that regardless how small or how enormous the power plant or the grid or the industrial or commercial complexes is, RA 7920 only requires one REE per shift. In several instances of reality, this proposed provision is physically and technically illogical or impractical, but sadly compliant to the law. That is why, in this proposed law, the concept of KVA capacities as measurable reference vis-a-vis the field and coverage of resident manning complement of electrical practitioners inside the industry, utility, grid, commercial complexes, and other establishments is one of the major features of this proposed law. By capacity, this means capacity of industrial plant, commercial establishment, process work, or project refers to the rated capacity in kilovolt amperes or megavolt amperes of electrical works or projects or industrial or commercial establishment for the purpose of this act shall be the total KVA or MVA rating of all generators and transformers wherein which are installed to make available the capability to provide certain amount of power for use as electric supply equipment in such work, projects, or plants, or establishments, whether in operation or not, and without regard to the connected loads requiring power from the power source. The extensive focus on the minimum personnel requirement has been broadened in more specific terms to include that of the registered master electricians. The complement of authorized electrical practitioners will not only help ensure public safety and preservation of lives and properties inside public or private establishment, but also enhances and strengthens the employability and dignity of the profession. Section 35A, minimum personnel required. So in industrial and commercial complexes, capacities 150 kVA up to 300 kVA, one resident registered master electrician as authorized electrical practitioners responsible and civilly liable as to the integrity and safety of the electrical system to include any changes, alteration, addition, subtraction of any parts of the electrical systems thereof, provided that every factory, building, or commercial complex in this category operating in more than one shift every 24 hours shall have the minimum personnel of 1 RME per shift. That is on the capacities of 150 kVA to up to 300 kVA. So about 300 kVA to 750 kVA. So there is another requirement. One resident RME as authorized electrical practitioner responsible and civilly liable as to the integrity and safety of the electrical systems to include any changes, alteration, addition, subtraction of any parts of the electrical systems thereof. But for shifting, there is one RME, resident RME per shift, and one resident RME or one resident REE as head whose scope of responsibilities include operation and maintenance. So from above 750 kVA up to 5,000 kVA, the number of required minimum personnel increases. So here, it's already 2. If shifting, 2 resident RME per shift, 1 resident REE, or 1 resident PE in charge as managing electrical engineer whose scope of responsibilities includes overall operation and maintenance. So from 5,000 kVA to 20,000 kVA, so the number of personnel required increases. So 20,000 kVA to 60,000 kVA, again, it requires this number of minimum personnel. So what 60,000 kVA, it already needs 5 resident registered master electricians and 3 resident electrical engineers and 1 PE. If operating in 24 hours, 5 RME and 3 REE per shift and 1 resident PE in charge as managing electrical engineer whose scope of responsibility includes overall operation and maintenance. So for power plants, up to 20,000 kVA. So this is the minimum personnel required. From 20,000, above 20,000 to 60,000 kVA, the minimum number of minimum personnel required increases. above 60,000 kVA to 200,000 kVA. Again, it increases. Then above 200,000 kVA for power plants operating more than one shift. 6 registered master electrician and 3 registered electrical engineers and 1 professional electrical engineer as head of shift operation per shift as resident complement, and 1 resident professional electrical engineers in charge as managing electrical engineer whose scope of responsibility includes overall operation and maintenance. So that is for power plant under section 36D. For section 37A, power substations of grid and distribution utilities. For single or clusters of manned substation, grid or distribution utilities, up to 75 MVA in specific inclusive area or location. So these are the required minimum personnel. So above 75 MVA to 200 MVA, the minimum personnel required increases. Above 200 MVA in specific inclusive or location area, please take note this is manned substation. So as resident complement, there will be 3 registered master electricians, 2 REE per shift, and 1 PE as head of the shift operations, and 1 resident professional electrical engineers in charge as managing electrical engineer whose scope of responsibility includes overall operation and maintenance. So, Section 38, grid system operations. Regardless of the size and complexity of the grid system operations, all resident authorized electrical practitioner in this category shall have a minimum requirement of at least registered electrical engineers or professional electrical engineers during shift operations and 1 professional electrical engineer as head for managing electrical engineers for every department, division, or section as the case may be. Further, that the grid system operations shall have operational control over unmanned automated substations of all types and sizes under its control. Furthermore, that additional qualified personnel shall be employed to ensure safe operation and safeguard public welfare commensurate to the size and complexity of operation. Section 39. This is for the distribution system operation. This is more or less the same as the grid distribution system operation. Section 40A, minimum personnel required. Electrical construction works or projects. For electrical works or projects under construction, the installation, erection, wiring, and an electrical system in residential, institutional, commercial, and industrial buildings, power plants, substations, shipbuilding, and other electrical projects. 150 kVA up to 750 kVA. 1 registered master electrician as electrician in charge, and 1 registered electrical engineer as project engineer in charge, and 1 professional electrical engineer as project manager or consultant. For over 750 kVA up to 5,000 kVA capacity, again, the minimum personnel required increases. Over 5,000 kVA capacity, there will be 3 registered master electricians as electrician in charge, and 2 REE as project in charge, project engineer in charge, and 1 PE as project manager, and 1 professional EE as consultant. So that is over 5,000 kVA capacities. On sections 41A and B, minimum personnel required for electrical equipment manufacturing plant. In 41A, the minimum personnel requirement for this type of plant shall be covered under Section 35 of this Act. For Section 42B, provided, however, that full-time professional electrical engineers shall be mandatory for the designing section of the plant, overseeing, supervising, and ensuring over the design of special equipment as transformers, motors, switchboards, control gears, motor control centers, power panels, or panel boards, and the like. For watercrafts and electric locomotives, watercrafts or electric locomotives operating with installed generating capacity up to the maximum size and voltage available for these units shall have the following complement of authorized electrical engineering practitioners. Up to 750 kVA with voltages not exceeding 600, 1 registered master electrician or 1 registered electrical engineer. In this law, we consider watercrafts and electric locomotives as power plants. Above 750 kVA, up to 5,000 kVA. So there is 1 registered master electrician and 1 REE or 1 professional electrical engineer. Above 5,000 kVA. So the number of minimum personnel required increases also. So on section 43, minimum personnel required. Other provisions for complement of electrical practitioners. For section 43A, provided, however, that in all the aforementioned cases, to include the case of clusters of buildings or factories or facilities, grid or distribution utilities, substations, or switching stations, where physical presence and supervision of the minimum personnel required is impossible for reasons of geography, distance, and or density of electrical equipment, additional qualified personnel shall be employed to ensure safe operations and maintenance of the electrical system and to safeguard public welfare, lives, and properties. Other provisions for complement of electrical practitioners, 43B, provided further that in the case of operation, maintenance, or construction projects, a registered master electrician can technically supervise the activities of fellow registered master electricians or non-licensed personnel, but assumes the full responsibilities and accountabilities as to the scope and limitations mandated in this Act. Number 2, a registered electrical engineer can technically supervise fellow REAs and RMS or non-licensed personnel, but assumes the full responsibilities and accountabilities as to the scope and limitations mandated in this Act. Number 3, a professional electrical engineer can technically supervise fellow PEs, RES, RMS, or non-licensed personnel, but assumes the full responsibilities and accountabilities as to the scope of and limitations as mandated in this Act. 43C. This section shall not apply to any installation which has a connected capacity of less than 100 kVA and employ voltages not more than 250 volts. And for installation that do not require resident personnel for their safe operations. Provided, however, that for every changes, alteration, revisions, addition, and as-built plans of any parts of the electrical system, the plans and design shall bear the signature and seal of an authorized professional electrical engineer. Provided further that a yearly assessment will be conducted and certified to be in a safe operating conditions as professional electrical engineers or registered electrical engineer or registered master electrician. So highlight number 11, new provisions for foreigner practitioners authorized to practice in the country. More provisions for the practice of foreign professionals, especially for project consultants and or installers involved in technology transfer and in the mutual internationalization accords. Highlight number 12, new provisions for prohibitions relative to the practice of electrical engineering. Highlights number 13, new provisions for prohibitions relative to the practice of electrical engineering involving others. Highlights number 14, more substance in the licensure examinations to ensure a pool of quality licensed electrical professionals. Notes, the role of licensure examinations is supposed to screen candidate professionals for quality output. Thus, the examination shall not only cover theories, but also technical applications of the profession. Reality is that whatever is the fabric of the board exam, the preparation of the schools and learning centers follows. In fact, the nature of the board examination will also trigger the change in the curriculum of more relevance. Note on the improvements on the qualifications of the would-be licensee professionals. This way, it can help bridge the gap between the academe and the industry. This will also make the young engineers worthy of their licenses and be near to be internationally ready. Note also that the licensure examination in this proposed new law had considered the effects of the K-12 program of the government. Examination and registration. Certificates of registration for the practice of electrical engineering shall be of 3 grades or categories as follows. So from RA 7920, these are still the levels of grades of licensure examination. Professional electrical engineer, registered electrical engineer, registered master electrician. So these are the grade, these are the qualification on section 17A to 17G and the scope of exam on sections 2AI to 20AV. So we will not be discussing one by one for this qualification and scope of exam. We only intend to give you on what sections you can find this qualification and scope of examination. Highlights number 15, imposition of penal provisions to violators of this law. to include violations by the impostors of the profession. On penal provisions, the penalty clause, any person, whether private or public, Filipino or foreigner, who shall violate any of the provisions of this act shall be guilty of misdemeanor and shall upon conviction be sentenced to a fine of not less than 10,000 or more than 50,000 pesos or imprisonment for a period of not less than 6 months and more than 5 years or both at the discretion of the court. These penalties during our latest public consultation increases. I could not remember, but this really increases. Probably the minimum is 50 and the maximum is 500, and the number of years imprisonment was also increased. Penalties for violation of any person in the roster of licensed electrical engineers of the Commission who shall violate any of the provisions of this Act shall be guilty of misdemeanor and shall upon conviction be removed from the registry, its license revoked, and shall be sentenced to a fine of not less than 10,000 or more than 50,000 for imprisonment of a period of not less than 6 months, nor more than 5 years, or both at the discretion of the court. This figure also increases in our latest revision of this law. Penalties for violations of sections 35, 36, 37, 38, 39, 40, 41, 42, and 43 by heads of government agencies or officers of private institutions. Any head of a government agency or officers of a private firm, institution who violates these sections of the Act shall be punished by imprisonment of not less than 6 months and 1 day to not more than 6 years, or a fine of not less than 50,000, not more than 500,000, or both at the discretion of the court. This figure also increases in our latest proposal. Gross, deliberate, and repetitive violation of this Act or its rules and regulations by entities, government offices or agencies, private companies or establishments or operators. The Commission, through the Board of Electrical Engineering, shall impose a maximum fine of not more than 500,000 annually until the time that the Act has been complied with. Further, that for purposes of the application of the fines, the BE shall prepare a system of penalties based on the violator's ability to pay, degree of willfulness, degree of negligence, history of non-compliance, and degree of recalcitrance. Provided further that in the case of negligence with mitigating circumstances, the first-time offender, to the discretion of the board, may only be imposed with stern warning. So again, the figure on our latest proposal increases. What are the benefits expected or derived from this proposed EE law, the new electrical engineering law? Benefits of the proposed new EE law: it will generate more jobs and more meaningful opportunities amongst electrical practitioners. It will strengthen the assurance of public safety and industry and the preservation of lives and properties. It will enhance the quality of Filipino electrical practitioners to international standards. It will promote the culture of responsible practice, honesty, and accountability. It will address the gap between the academe and the industry. and will produce better graduates for licensure examinations. It will create a pool of proficient and quality electrical engineering practitioners whose standards of practice shall be outstanding, honorable, and globally competitive. It will promote the value of the professions that are responsible to continue the growth and competence, continuing growth of competence. How far we go? Through the efforts of the team, we have successfully filed the bill in both houses of the Congress of the 16th Congress. This was House Bill 5826, sponsored by then Honorable Ricardo Masungsong, Peter Onabia, and Rinaldo Mali. Then at the Senate, it was Senate Bill 2963, sponsored by Honorable Senator Paulo Benigno IV. Where are we in 2016? The team again successfully refiled our bill of the proposed new electrical engineering law in both houses of the 17th Congress. Dahil yung first filing natin, the second, that was the second filing, again, inabutan ng election. So nag-refile tayo ng bago during the 17th Congress. This was House Bill 1622, sponsored by Congressman Eugene Michael De Vera, filed last July 2016 in the 17th Congress, and Senate Bill 1127, sponsored again by Honorable Senator Benigno Aquino IV, last September 6, 2016. But again, inabutan ng another election process. So, nabauna na naman because of the campaign period. Where are we in 2020? With our continuing consultations and committee public hearings to the stakeholders, we have again submitted a consolidated substitute bill with the same title and content to both houses under the 18th Congress. This is House Bill 6314, sponsored by Honorable Congressman Jolien Jambarunda, filed last February 18, 2020. And Senate Bill 1210, sponsored by Honorable Senator Panpiluping Lacson, filed last September 27, 2019, during the 18th Congress. And those bills are still pending. And those bills, the two bills, are still pending on the Committee on Civil Service at inabutan ng pandemic, and we are still keep on following it up through communications, letters, that they will give attention also to our proposed ELO. But until as of this time, this is still under, on the Senate side, the Committee on Civil Service is, the chairman is, I think, Senator Bong Revilla, while on the Congress, it's Congressman Freddy Xiao is the chairman on the Committee on Civil Service. So, nandun sa kanila, pending. We say that we need a law that ensures the achievement of the fundamental intent of licensing professionals. Why do government impose licensing to individuals in the practice of a trade, a skill, or professions like drivers, pilots, watercraft officers, nurses, midwives, doctors, engineers, etc. Why are they licensed? When lives, properties, and public safety are at stake, resulting from acts of an individual in the performance of his trade. We need a purposive licensing of responsible professionals who are allowed and permitted by law to perform as such. We pray for your support on this bill. We really need it. Very respectfully yours, IIEE. May God bless us. Daghang salamat. Thank you very much. Moderator, please take over.
Thank you very much, Engineer Leo Cabasag, for updating us on the proposed new EE law and to present our certificate of appreciation. May we call on the chapter president of Metro Central, Engineer Arwin De Jesus, to present our certificate of appreciation. And also Engineer Leody Diaz. Certificate of Appreciation is awarded to Leo S. Cabasag in grateful acknowledgement and appreciation of his invaluable service and professional thoughts shared as a research speaker on the topic about the proposed new EE law during the IIEE 7th Metro Manila Regional Conference, a hybrid event, given the 6th day of August 2021 at the IIEE building and via Zoom cloud meetings, signed by Engineer John Regis Estrosio, Engineer Giovanni F. Tagatak, Engineer Manuel M. De Guzman, and Engineer Alwin M. Wagan. Let us all give them a round of applause.
Thank you.
Thank you very much, Sir Leo.
Thank you, MMR.
As we move along, we would like to call on Engineer John Regis Estrosio, Vice President External Affairs of Metro West Chapter, to introduce our esteemed keynote speaker.
Thank you, Yasmin. Our keynote speaker for this afternoon, he's the chairman of the Professional Regulatory Board of Electrical Engineering. He obtained his Bachelor of Science in Electrical Engineering at Pamantasan ng Lungsod ng Manila. In the long run of his profession, he has performed executive functions of various organizations and companies. 2002 IIEE National President, 1996 to 1997, the President of SPECS, 2005 to 2008, Chapter Head of Brotherhood of Christian Businessmen and Professionals, 2008 to 2010, Chapter Head of PCA, 2011 to 2014, Business and Professionals Manila Chapter Mancom Director for Women, Youth, Seniors, and Singles Ministry. His contributions to the profession earned him the Most Outstanding Professional in the field of electrical engineering, awarded by the Philippine awarded by the Philippine Professional Regulatory Commission in 2009, and Gintong Ani Award by Pamantasan ng Lungsod ng Manila in 2010, to name a few. He is the president of the Sidelco Tech and FB Mapile Incorporated. To all the delegates, IIE Metro Manila Region, help me welcome our keynote speaker for this afternoon, Honorable Francis V. Mapile.
Thank you so much, John, Engineer John. Thank you so much. And again, good afternoon to everybody, to our distinguished guests, and to the Governor of Metro Manila Region, Engineer Alvin Wagan, to the Chapter President, Giovanni Tagata, to John Regis, to Engineer Manny de Guzman, and to everyone who are here right now, to the officers of our distinguished IIEE, national officers, and everybody who is in the room right now. And of course, I'd like to give acknowledgement to the very active former President Leo Cabasag. And I was listening to his discussion on the amendment of Republic Act 7920. And previously, we were discussing about this over this committee. But nonetheless, I will explain later. Magandang hapon po sa inyong lahat ulit. This is indeed a very nice afternoon for all of us. The weather is nice. And you have been working so hard for the past 3 days. And to be honest with you, this is the first time that I have been with a webinar for 3 long days. I was invited by some group about 5-day seminar, but I was not able to keep up with the number of days. But I really cannot understand that my heart really is for the Metro Manila, whose I am a member of the Metro West without jeopardy, of course, not being prejudicial to other chapter. But nonetheless, I'd like to give my sincerest congratulations to every one of you. Even in the impact of the crisis and the slowdown of the economic due to the country's lockdown, it has resulted in large companies and small business to halt the production of our goods, our services, due to the concern and safety of the people. And as I listened to all of the presentation, I was so amazed, and I am so happy that I get to see you guys and all of you here in IIEE trying to navigate the new normal. And most of us, I know, everyone living through this period of history really are eager to return to this normal. All of us, and I hope that this can be a lesson to all of us, that as soon as all of this is clear, you just don't simply forget about it. This is a sort of a memorable thing for all of us. And we find a new ways of working and living in this pandemic. For many, the teleworking like this one, work at home, webinar, among others, is gaining popularity. And in fact, because of that, the employees and the employers alike quickly recognize the productivity and flexibility we gain from working at home and doing what we do right now in the webcam. But there are also setbacks on all of this. According to a French study, about 41% of those doing teleworking or work from home miss the exchanges with their colleagues I'm sure some of you miss your exchanges with the colleagues already because we are always working at home. And about 51% appreciates the saving the time when you commute from your work, from your home to the office. So this is study, statistical study from a French group. But my message to you right now is while we are now in our safety of our homes, please continue to maintain the high standards for productivity, for efficiency, and for the quality. The quality we have to, we should not be disturbed by the pandemic so that we just simply say, this is pwede na to. It shouldn't be that way. We should aspire for more quality as far as all webinars are concerned. And as part of our being the leader in the industry, being leaders in the electrical engineering industry, I would like to give you some of my sort of personal suggestion and recommendation as leaders so that our members would be able to appreciate what you're doing. You are indeed raising the bar of excellence as far as what you are doing right now, as far as giving more information to your educating our members. And as they expect from this webinars and all seminars that we do, I am sure that all the members who are watching us right now, that they would have in the back of their mind that we are in a very uncertain, complex, volatile situation, but still we wanted to deliver the best services for each and every one. This is your mission and vision, as what you have read a while ago during the opening of the conferences. And to further assist you in achieving your goal, there are only 4 things that I wanted you to follow. These 4 things that to keep you growing and rising on the right path. Okay. Number 1, you need to set best practices. I've seen that you are now setting up best practices. You have identified what are the best things that has to be done. I was listening to Manny de Guzman on his report on the manner by which you make an assessment, pre-plan, making a checklist, and all those things. This is setting a best practices. This is also aligning the practice that we will have to make use of as soon as we go back to normal. We will be learning a lot from a very good people in relation to the codes and the standards that I have been using, because you are setting these best practices. You set the best practices. And setting the best practices is also endorsing the highest standard in ethical business practices. It goes hand in hand. Kaya nga nung may nakikinggan ko si Manny, how can you possibly make daya to your client if you have this kind of list that you have to check and then say, this we have done with diligence, all the checklist that is required in reviewing a plan, an electrical engineering design and plan. That is setting the best practices. So the number 2 would be capacity building. You facilitate the adoption and implementation of this kind of high standard. What do we mean by this? Move on to a lot of trainings, a lot of discussion on this, and so that you implement. You do this in the field. You do what you learn from all of these best people. Implement that, enforce that, because it's your way of building the capacity as far as the electrical engineering is concerned. You adopt these best practices. As you set it, second, you adopt. Then, the third one is you monitor and you evaluate. Do we need to improve? Do we need to remove those things that are necessary? Or do we need to come up with a tweak a bit and then say that, you know, this is much better? So we need some indicators. So to quantify progress in number one, in code adoption, and the implementation across all discipline. We had these questions previously a while ago, wherein sabi niya, is it okay if the architect will just have to do the drawings and then give it to the electrical engineer and make the design, and then that's it? This is one way of trying to monitor and evaluating if you're setting the best practices and you're adapting that practices. You will have an indicator if the architect stops, and if the civil engineer will stop doing this for you, then you now have a very good indication that you have adopted all these best practices across all disciplines. So that no architect will do the design for you, no civil engineer will do the design for you, no whoever would like to do the design for you. So you have set the best practices. You were able to train people to do that and adapt these practices, and then come up with indicators by monitoring and evaluating. Have we done right? Just like what you guys are doing. And finally, all of these things, as we continue to raise the bar of excellence, we leaders must endorse this kind of best practices, ethical practices, complete with integrity, and endorse this to the ILG, to DOE, Energy Regulatory Commission, DPWS, and now it's timely we endorse all of these best practices to the Department of Health, because we now have this health emergent crisis. So we are now in the new normal. And I know that most of us, as I have said, is really very eager to go back to our normal life. But, you know, we need to continue to find ways of working in living in this new normal. And once we are back to normal, I hope we do not simply forget all those experiences. All experiences we learn from this. Our resilience, our struggles and pains that we are experiencing right now. Let us continue to be productive, efficient, set a high standards of quality in everything that we do, and put integrity in all those work. In closing, I'd like to congratulate again all the organizers of the 7th Metro Manila Regional Conference. Let us give them a round of applause. Raise our hands to them. I salute them. I will start my salute with them and say, I am proud to be an electrical engineering practitioner. Mabuhay kayong lahat. Mabuhay kayo. Salamat po.
Thank you, Chairman.
We heard it right, and thank you very much for your words of inspiration to us, Honorable Francis Mapile. And now to present our certificate of appreciation. To award the Certificate of Appreciation, may we request Engineer Giovanni F. Takata, Host Chapter President, and Engineer Alwin M. Wagan, the Metro Manila Governor on stage, while Engineer Manuel M. de Guzman, Metro Manila Secretary General, will read the citation.
Okay. This certificate of appreciation is presented to Honorable Francis B. Mabile in honor and grateful appreciation for sharing his words of wisdom, time, and support during the IITE 7 Metro Manila Regional Conference, a hybrid event as guest speaker with the theme Got One IIE at 46. Transcending the challenges by embracing resiliency and complementarity. Given the 7th day of August 2021 at the IIE building, Cubao, Quezon City, by a Zoom cloud meeting, signed by Engineer John Regis S. Proscio, Vice President for External Affairs of Metro West Chapter, signed by Engineer Giovanni F. Tagata, President of the Metro West Chapter, signed by yours truly, Engineer Manuel M. de Guzman, Secretary General of the Metro Manila Region, and signed by our Governor, Engineer Alwin M. Waga, Governor of the Metro Manila Region. Thank you, Sir Francis.
Thank you, Manny. And thank you also to Chi. Chi was there. Hi, Chi. Thank you. And to everybody, to all by the way, Leo, perhaps we need to talk about the amendment, especially only on the scope of examination, so that I can give my my idea on the scope of examination. The rest would be okay.
We'll be inviting you, Mr. Chairman, on our next meeting.
Sige. Doon lang sa doon lang sa scope
specific discussion.
I-tweak lang natin ng konti doon sa scope examination, lalo na doon sa RME.
Okay. Noted.
Right.
Thanks.
Thank you. Thank you, everybody.
Thank you, sir.
Si Lindon. Thank you, Lindon.
Thank you very much, Honorable Mapili. So after hearing those words of inspiration from our keynote speaker,
excuse me, hindi ko lang makita lahat. I'd like to acknowledge all of them because from time to time, I really, this is the problem with the internet.
Thank you, partner.
Oh, thank you, partner.
Hi, Sir Jimmy.
Ito mo, hindi ko tuloy na-acknowledge yung aking
Honorable Jaime V. Mendoza is also here with us.
Kanina pa ako umaga eh. Hindi ako ina-acknowledge.
Acknowledging the Honorable Jaime Mendoza. Yan ang ating focal person sa DBSP. Go na yun, go na, approve na. Ang tatrabuhin niya na lang yung specialization level 8. Congratulations to Engineer Mendoza and to the team, of course. Sino pa ba? Ang dali lang Yasmin I'd just like to greet some of those who are here right now. Yung mga officers natin, si me check. Si RPB, I think nakita ko siya kanina, RPB. RPB, pagka secondary voltage household level sa ARCOA, hindi mo kailangan ng primary metering. Anyway, yes, si Lea de la Cruz is here. Some of the presidents and officers of the Metro Manila, I mean, this is the last day, so I would like lang to give me a few seconds, Yasmin, just to greet some of our good friends here. We have not been seeing them for so long a time, and this is just a virtual meeting. I cannot even hug or kiss them. Maybe just a. Oh, si Lodi is here. Huh? Okay. Thank you. That's it. Thank you very much.
Thank you, Sir Francis.
Thank you, Sir Francis. Stay well.
Thank you, Sir
So
Francis.
salute to you, engineer.
Thank you, Chief.
Salute to our Honorable Francis Mapili for gracing us his very precious time this afternoon. So once again, a round of applause. And also to Honorable Jaime V. Mendoza. So after hearing those words of inspiration from our keynote speaker, it is now high time we introduce our last, but definitely not the least, research speaker for one more relevant topic. He obtained his Bachelor of Science in Electrical Engineer at Isabela State University, Ilagan City. He previously worked as electrical project engineer at Dyna Power Corporation from 2011 to 2012. He is a resident engineer at SM Supermalls, SM City Sukat, SM Center Las Piñas, SM Hypermarket Sukat, and SM City South Mall from 2014 to 2017. He is an assistant facility manager at Jones Lang LaSalle, Philippines from 2014 to 2016, an electrical design engineer at Eco Solutions from 2016 to 2017, Faculty of Electrical Engineering Department at the University of Perpetual Health System, Delta from 2015 to 2017, the Senior Planning Engineer at National Grid Corporation of the Philippines from 2017 to 2020, a part-time faculty at Electrical Engineering Department at Technological Institute of the Philippines from 2018 to present. At Isabela State University, Ilagan City from 2020 to present. At this moment, we will be pausing momentarily the introduction of our next research speaker. So may we call on to give us an honor for another special message, Honorable Jaime V. Mendoza.
But it's not just for them. What's amazing is just
Hello once again, Honorable Mendoza. Good afternoon, Sir Jaime. Okay, you're still
Si
muted,
Raime,
sir.
naka-mute po kayo. Si Raime, naka-mute po.
Yes, you're still muted, sir. Paki-unmute po. Ayan, nakikita na po namin kayo, sir.
Ay, congrats sa inyo lahat ha.
Ayan.
So, dito sa inyong 7 Metro Manila seminar. So, kanina pa ako umaga eh. Tsaka no isang araw. Kaya lang, meron kasing committee meeting sa ng last Thursday tsaka Friday. So, committee meeting sa energy. So, dun sa proposed underground system. So, inaabot din ang maghapon. And of course, congrats doon sa 7 Metro Manila, sa host, sa governor. So, just listening sa mga kanina pa umaga. So, hopefully, with 3 days, ang haba, ano? Maghapon tayo nagse-seminar. So, marami na nga nagre-reklamo rin minsan. Parang magkakaroon ng subpating, no? Sa Zoom. Kasi every now and then, meron Zoom, no? Even sa office. So, hindi ka pwede magsabi na you are not available. No? Lagi rin may mga meeting. No? And of course, sometimes may meeting ka na 2 or 3 times magkasabay. No? So, kala ko yung 2 laptop, okay na eh. No? Maghahanap ka pa na isa, then minsan 3. And mas mahirap kung ikaw ang isang presiding dun sa isang meeting. So, yan ang new technology natin. We have to adjust to new normal. And of course, be safe. No? So, be safe tayo lahat. Lalo tayo mag-ingat kasi as of now, 11,000 yung new COVID cases natin. So, medyo ingat tayo do sa Delta variant. So, be careful. Just follow strictly the healthy protocol. No? Be safe. So, yun ang importante, no? Kasi as of now, sa lung center, puno na sila. So, ingat lang tayo. Yun lang masasabi ko. Lalo na yan dyan sa IE, pag-uwi nyo. Ingat po kayo. So, make yourself na huwag kayong mag-relax. Ano? Mahirap itong Delta variant. So, ingat lang. With that, good afternoon po sa inyong lahat. Maraming salamat po sa inyong lahat.
Thank you very much, Honorable Jaime. Thank you very much, Honorable Jaime V. Mendoza. We are very grateful for your message to us this afternoon. And with that, we would like to call on Engineer Alwin M. Wagan, the Governor of Metro Manila Region, Secretary General Manuel de Guzman, and Engineer Juveni F. Tagatak to honor you with an officer's salute. Yes! So let's give them a round of applause. So yung mga panelists natin dyan, baka gusto ding mag-salute. Ayan.
Para pati sa tata.
Isa pa daw. Salute. And thumbs up. Okay na. Once again, may we request another salute po daw, Sir Jaime, for the photo op. Salute po.
Yan ang bago ngayon eh.
Yung ating CPS na approve na yung PE na equivalent to level 7.
Pasado na, approve na.
Effective August 17.
Thank you very much, Sir Jaime, for your time. And now we will proceed to the introduction of our next speaker. Once again, he obtained his Bachelor of Science in Electrical Engineering at Isabela State University in Lagan City. He previously worked as electrical project engineer at Dyna Power Corporation from 2011 to 2012, a resident engineer at SM Supermalls, SM City Sukat, SM Center Las Piñas, SM Hypermarket Sukat, and SM City South Mall from 2012 to 2014. An assistant facility manager at Jones Lang LaSalle, Philippines from 2014 to 2016, an electrical design engineer at Eco Solutions from 2016 to 2017, Faculty of Electrical Engineering Department at the University of Perpetual Help System Delta from 2015 to 2017, a senior planning engineer at National Grid Corporation of the Philippines from 2017 to 2020, a part-time faculty at the Electrical Engineering Department at the Technological University of the Philippines from 2018 to present, and Isabela State University, Ilagan City from 2020 to present, and the General Manager of 120 Vector Electrical Consultancy. He has sufficient exposure in unit substation, asset management, MEPF design and commissioning, data center management, academe, electrical network analysis, and power grid operations. At present, he is a member of the Board of Directors of IIEE Metro South Chapter and the National Secretary of the United Professional Electrical Engineers of the Philippines. Ladies and gentlemen, to discuss power system harmonics, let us all welcome Engineer Julius O. Salaco.
Good afternoon, everyone. Thank you, Asmin, for that wonderful introduction. I just want to correct na I'm no longer connected to TIP. Hindi na po ako faculty ng engineering. Anyway, proceed na po tayo sa lecture para po hindi tayo gabihin. Share ko lang po yung screen.
Hello, Sir Julius. Medyo may noise po galing sa audio po ninyo, sir.
Ayan.
Ayan, sir. Okay na po.
Okay. So, our topic for this afternoon is power system harmonics. These are the content of the topic 1. If possible, kung may time pa, we shall discuss the application. But for this time, I think we shall focus on the theory, no, in order for us to understand yung concept ng power system harmonics. So we shall talk about the facts about the non-sinusoidal wave, the Fourier series, non-sinusoidal wave expressed by Fourier series, harmonics in three-phase system, the concept of symmetrical components, harmonics and symmetrical components, the relation of these two, harmonics in delta three-phase, harmonics in Y three-phase system, transformer sequence connection, the graphical analysis of non-sinusoidal wave, sample analysis, the total harmonic distortion, and the total demand distortion. You cannot manage what you cannot measure. I just want to emphasize this one. Kasi in order for us to understand yung complex concept ng harmonics, or enable for us to manage, we need to understand it first, no? Or we need to measure it in order to manage. So these are the fundamental facts of non-sinusoidal wave. Non-sinusoidal wave can be expressed mathematically by summation of sine wave components at different frequency. The dominant sinusoidal component is called the fundamental frequency. The signal at higher frequency and considerably lower magnitude are called harmonics. The harmonics act to distort the basic sine wave by the amount that are determined by the relative magnitude. Odd harmonics distorted the sinusoidal variation without disturbing the symmetry between positive and negative lobes of the cycle. Even harmonics tend to cause dissymmetry between alteration as well as distortion. And the other factors causing the dissymmetry and distortion are the DC component and out of phase even harmonics. Okay. So this is the Fourier series representing the harmonics. Yan. So if you will observe, no, the blue one is the fundamental, yung red and green are the harmonics component in the system. In this video, they are rotating independently at their own frequency level. Okay, so this is the fundamentals and the harmonics rotating independently. Now, if we shall add the signals, no, makikita natin mamaya how the harmonic component distorted the fundamentals. The second part of this video, this is how the harmonic component distorted the fundamental by adding the higher order frequency to the fundamental. So, and po, nakikita nyo yung total ng signals when we have harmonics in the component is not perfect sine wave already, no? So itong color magenta na to is already a distorted signal caused by the harmonics components, which is yung red, green, and blue dun sa other side ng video. Okay. So non-sinusoidal wave expressed by a Fourier series, dito sa left side ng presentation is the graphical presentation of distorted waveform. Kung makikita nyo, if we shall add the higher order of harmonics like the 180 Hertz, 300, 420, 540, and so on and so forth, this is the equivalent signals, no, of the harmonics, no, equivalent total signals, adding the fundamental frequency and the harmonics component na present sa system. Ito po yun. While the right side ng presentation, this is the mathematical representation of distorted waveform. So pag inad natin to, yung 60 Hertz mo representing this function representing the this graph and so on and so forth, the result will be this equation, no? And this is called Fourier series. So magandang tignan yung graphical representation, no? Pero yung mathematical expression medyo it's kind complicated. This is the general expression for a non-sinusoidal wave, which can be represented by Fourier series. So try natin to understand, no, the component of this equation. Isa-isahin po natin. So this is the general formula. Function of x is equal to a sub o plus summation of an cosine n pi x over L plus bn sine n pi x over L. So yung components of nth order harmonics po is comprised of cosine and sine. And yung mga constant natin like a sub o can be expressed with this sub-equation below. Example, yung a sub o is equal to 1 over 2 to 1 half L integration of function of x dx. A sub n, 1 over L integration of function of x cosine n pi x over L. And yung b sub n is equal to 1 over L integration of function of x sine n pi over L, n pi x over L from negative L to L. So i-discuss po natin ito in detail paano nagkaroon ng ganitong equation. For the A sub o, this represent the DC component dun sa system natin. And the behavior of that DC component is a linear function. Yun po yung A sub o natin. While this part, yung second term ng equation, yung summation of an cosine n pi x over L plus bn sine n pi x over L is representing the odd and even function, no? So for example, yung sine x natin, this one represent the odd function while the cosine is an even function. To capture that, we need to represent the cosine and sine dun sa general equation ng Fourier series to capture the odd and even function dun sa system. Kasi kapag mayroon kang electrical system, mayroon kang sa even function na nanggagaling sa power electronics natin na connected dun sa network element. So now, i-discuss naman natin kung saan nanggaling itong mga sub-equation natin. This one. A sub was equal to 1 over 2 pi L integration of function of x dx. Okay? And A sub n is equal to 1 over L integration of function of x cosine n pi x over L. And lastly, B sub n is equal to 1 over L integration of function of x sine n pi x over L. Okay? So, ulitin natin itong general equation ng Fourier series, yung A sub O representing the DC component and the second term that has a cosine and sine representing the odd and even function to capture the all function dun sa system natin. I mean to capture all the signals na even or odd dun sa system natin. So, we have another formula, the orthogonality of set of sine and cosine, which is ito. Okay? So sine k pi x over L, cosine n pi x over L is equal to 0. If we multiply the cosine kx k pi x over L to the Fourier series, we can able to determine the solution which is a sub 0 is equal to 1 over 2L function of x dx. So dyan po nanggaling yung formula natin kung saan nanggaling yung a sub 0. Kasi po yung this one, this portion kasi, in this portion, pag binultiply natin yan, that is already the orthogonality set of sine and cosine, no? Which is equal to 0. And performing the operation, makukuha po natin to. Okay, at k is equal to 0. Okay? The same approach, para makuha natin yung solution for a sub n, we multiply the cosine k pi x over L dito sa Fourier series equation. Then, part of the original Fourier series will become orthogonality set of sine and cosine, which is equal to 0 at n is equal to k. Then we can able to determine yung a sub n, which is ito na 1 over L integration of function of x cosine n pi x over L. The same approach dun sa last step to determine the value of B sub n. So you may take photo dito sa presentation natin and try to perform the mathematical operation and you will arrive po sa the same solution. Okay? So balikan natin yung general expression for a non-sinusoidal wave, which is yung a sub 0 representing the DC component, no? And we try to multiply the orthogonality function to this Fourier series. Nagkaroon tayo ng solution for the value of a sub 0. Ganun din yung a sub n, minultiply natin yung cosine to have a orthogonality equation and we can able to determine yung value ng an dun sa Fourier series. The same approach to determine the Bn. Okay? So ito yung solution kanina. Now, if we shall add all the harmonics component from fundamental, which is the 6/3 or the first order, to infinite, the result is close to square wave. So pag pinagsama-sama po natin yon, lahat ng harmonics doon sa system, ano po, mayroon, ang result po nung signal natin is square wave po. Okay? Next slide. So, na-determine natin kanina yung solution sa mga constant natin, which is yung A sub O, AN, and BN. Now, let's try to perform the operation. No? Kasi we need to determine the value of its constant, yung A sub O, AN, and BN. So, performing the operation for A sub O, we shall arrive to this solution. No? So, magiging value ng A sub O natin is equal to 0. The same approach, no? We shall perform the operation dito sa equation na to. Ang magiging sagot natin na value ng AN is 2C over N pi sin N pi. Okay? For BN naman, 2C over N pi quantity 1 less cosine N. Let me check, no? Alam ko may solution ako dito. I will try to share, no, separate presentation. Ayan, nakita nyo po ba? So, ipakita ko lang yung solution, no? Paano nakuha yung value. Ito po.
Yes, sir, we can see it.
Yan, ito po yung solution na why we have a AN 2C over N pi sin N pi, no? And for BN, ito yung solution. Okay? So, balik ko na sa presentation materials. Ayan. So, kanina, pinakita ko yung solution para nakuha yung AN is equal to 2C over N pi sin N pi. Now, no, if we shall substitute the order of harmonics, kasi yung N natin representing the order of harmonics, yung 1 for the fundamental, 2 for the second order harmonics, and so on and so forth. The value of AN is equal to 0. Okay? Kung may calculator ka dyan with you, try to substitute yung value ng 1 on this formula. Then makukuha mo ng lahat ng value ng AN from fundamental to infinite is equal to 0. For BN, if we shall substitute the order of harmonics from fundamental to second, third, fourth orders until infinite, there's a pattern, no? For odd harmonics starting from fundamental, meron tayong value ng Bn for C over pi. For second, or the first even harmonic is equal to 0. For the third, meron tayong value for C over 3 pi. And for the fourth, 0, and so on and so forth. So may pattern siya, lahat ng even harmonics dito sa Bn is equal to 0. Okay, yun o. So, next slide. Ayan, no? Let's try to understand, no, yung ginawa natin kanina. Konting recap lang. This is the general expression for Fourier series, no? Representing the DC component, yung A sub O. And the second term is composed of cosine and the third term is sine, no? We have cosine kasi to capture yung balikan lang natin yung cosine kasi to capture the even function dun sa system. It is normally coming from mga power electronics yan . Okay? While the sine function or the sine component representing the odd function. So our goal is to capture all these signals, harmonic signals in power system network. That's why we have a cosine and sine. But the problem is we have a constant, yung A sub O, AN, and BN. Next step na ginawa natin, we introduced a new equation, which is the orthogonality function. And we multiply cosine for the original Fourier series, and we arrive for the value of AN by manipulating the original Fourier series at k is equal to 0. At the same time, we multiply cosine again dun sa Fourier series, and portion of the original equation become orthogonality function of set of cosine and sine, which is equal to 0 at k is equal to n. Diba? Ito kanina. Yan. Yun yung binabanggit ko. No? And for the Bn, we multiply sine, and part of the original Fourier series is equal to orthogonality set of sine and cosine and equal to 0. And we can able to determine the value of B sub n. Okay? So, kaya mayroon tayong equation for the general equation ng Fourier series. Then we perform the integration for a sub series equal to 1 over 2 pi L. Balik ko lang sa slide. Ito. Ginawa natin ito. Then, the same approach for AN and BN. Then, na-determine natin yung value. Okay? Now, since if we substitute all the harmonics component at A sub O, lahat ng value ng A sub O from fundamental to infinite order of harmonics is equal to 0, as proven dun sa calculations natin. For AN naman, we observe na if we substitute the order of harmonics in this equation, ito yung result ng mathematical operation for A sub n. Nakita natin na yung value ng AN is equal to 0 from fundamental to infinite order. No? Ngayon, kung isa-substitute natin to AN dito sa original Fourier series, kita nyo? Kasi may value yung AN at fundamental is equal to 0, at second order 0, third order 0, fourth order 0, and so on and so forth. I-substitute mo dito. So, ang value ng A sub n mo from fundamental, second, third, to infinite order of harmonics is equal to 0. So, anong ibig sabihin nun? 0 din yung cosine mo, di ba? Kasi lahat ng order nun, 0 value yung AN mo. So, 0 times any number is 0. So, this term of the Fourier series is equal to 0. Okay? For Bn, may pattern siya eh. Yung value ng Bn mo is only 0 at even harmonics, di ba? Yung 2, 4, 6, no? So pag multiply natin yung value ng Bn on this term of the Fourier series, lahat ng even order is equal to 0. Ang meron lang value dyan is yung odd harmonics, no? Yung 1, 3, 5, 7, and so on and so forth. So by substituting these values sa general concept ng harmonic natin or Fourier series, wala tayong value ng A sub O from fundamental to higher order ng harmonic. So, cancel na yan. For the cosine naman, cancel na rin to kasi yung value ng A sub n mo from fundamental to higher order is 0 as proven sa calculations natin. Wala na rin to. Okay? For the last term, which is the Bn, na-observe natin na for the even harmonics, no? 0 na yan. So, wala lang value yung, or walang sign component yung even harmonics natin. Ang maiiwan lang is yung odd natin sa third term ng Fourier series is the Bn. Okay? So, at even number, Bn sin n pi x over L is equal to 0. So, substituting this output or result to the general Fourier series, ito yung pinaka-representation or general representation ng Fourier series natin sa power system, which is composed of odd harmonics. Okay?
So next slide. May question sa internet, no? So maraming sumasagot dito eh. Kanya-kanyang explanation. Why are not even harmonics significant when compared to odd harmonics in power system? No? The answer to this is because the components of even harmonics is equal to 0 at the cosine component of Fourier series. Okay? At the same time, yung component ng even harmonics sa sine element ng Fourier series is equal to 0 as proven in these calculations. So ang sagot dito, yes, they are not significant kasi they don't even exist, no? Kaya nga yung binabanggit ng ibang power system analysts, they tend to cancel each other, yung term nila. Pero the mathematical proof is ito. Okay? Wala talagang, zero yung result if we substitute this order of harmonics. So ang sagot doon, all even and odd cosine components, ito yung tinutukoy ko. Balik natin. Ito kasi yung cosine ay yung may an, ito yung tinutukoy ko. Dito, no? Is equal to 0. Yung cosine components of harmonic order n and all sine even components, no? Yung sine even components naman, ang tinutukoy ko doon is this one, no? Yan, kasi ito yung bn cosine component is equal to 0. That's why yung even harmonics sa power system is considered na not significant because of the substitution na ginawa natin. Nakita natin na 0 yung mga value na yon pag substitute natin yung order of harmonics. Okay, medyo madugo, no? I mean, medyo complex, no? Yung harmonics. But this explanation is for single phase, no? Tignan naman natin yung harmonic system sa three-phase, which is more complex, no? So meron tayong general equation dito o formula for three-phase harmonic system. Okay? And we have a statement here, no, at balance condition. The H harmonic of phase B lags H times 120 behind that of same harmonics in phase A. And the H harmonic of phase C, if we said H, we're talking about the order of harmonics, no, is H times 240 behind that of the same harmonics in phase A. The triple harmonics, 3 by 120 or 3 by 240 are cofacial vectors, no? We'll try to prove this na mamaya after yung next slide. Ipo-prove natin to. Harmonics of the third order or 3H plus 1 are positive sequence. Yun yung 1, 4, 7, 10, 3H plus 1. Harmonics order 3H plus 2 are the negative sequence. Harmonic order of 3H are zeros, no? Zero sequence or triple harmonics. So we can express, no, yung triple harmonics by this harmonic progression general equation. So let's try to interpret this statement, no? I will stop my PowerPoint presentation. I will try to share an Excel file. Ayan. Nakita niyo po ba yung Excel file po natin? Hello?
Yes, sir. Nakikita po, sir.
Okay. So let's try to interpret yung condition for three-phase harmonics, no? Okay. Before I will proceed, no, meron tayong standard sa IEEE na if we shall analyze a harmonic system, it should be at least at 50th order. And kung titignan yung data natin, hanggang 49 lang tayo kasi na-prove natin na even harmonics are not existing or they are equating to zero dun sa calculations natin recently. So hanggang 49 lang to, wala po tayong even harmonics na kinonsider. No? Balik ko lang para maintindihan natin. Ayun po, no? So na-prove kasi natin dito before, yan, na walang value yung even harmonics natin. So yung pinaka-general formula is all odd harmonics component. Kaya sa Excel file natin, balik ko lang. Yan, yung Excel file natin is only odd harmonics component. I will try to capture its equivalent frequency. I'm sorry. Yan yung equivalent frequency for its corresponding harmonic order. So I will place in this row the phase A, phase A, phase B, and phase C. So let's try to interpret yung statement. Ito, its harmonic order. Ito muna. H is representing the order of harmonics, no? The H harmonic of phase B is lags each time the 120 behind that same harmonic in phase A. Okay. So we have a 120 here. It's representing this statement. Then ito multiplied by this one. Let me check. Okay. So, i-ano ko lang po di dollar sign ko lang po para hindi ko bala yung formula natin. Yan, no? So, another thing, yung second statement, ito, yung dito na tayo. Kasi ito yung kanina for phase B, no? Yan. For phase C naman, ito naman is, yung gagawin natin ngayon is for phase C, no? Ibahin ko lang yung kulay. So we have 240. It is representing this one. And yung 120 ito. And let's multiply. Okay. So yan na po yung position ng harmonics natin with respect to polar coordinates and to their order of with respect to their harmonic order. Yan, okay. Ayan po, no? But ito kasing data na to, I'll try to color it. Ito, no? That's the exact location, but nakaano kasi yan I mean, we need to capture the exact location yan kasi sa polar coordinates naman natin, the maximum angle is 360, di ba? Or the maximum rotation. So let's try to divide to 360 para makuha natin yung exact position ng harmonic order na to for its spaces in per unit, which is per unit angle to, no, dun sa polar coordinates natin. So yan na po sila, no? The same approach to 360. Sorry. Ayan. Sorry. Divide lang natin to. Divide. Divide ano? F17. Okay. So ito na po yung position ng harmonics component natin sa polar coordinates but in per unit, no? Kasi divide natin ng 360 eh. Yung, if you observe, we have whole numbers here, yung 2, 3, okay? This number is representing the revolution ng harmonics component na yun dun sa polar coordinates. And yung revolution na yun, yung whole number natin dyan. Halimbawa ito, 7, no? For the phase B at 21 order. 7 times siyang nag-rotate dun sa polar coordinates natin, which is meron tayong maximum na 360 angle. That's not the point of interest. Kasi kailangan natin yung exact location ng harmonics component na yun dun sa polar coordinates. Hindi ko kailangan yung revolution. Ang extract lang natin na data is yung exact position ng harmonic na yun dun sa polar coordinates at 1 revolution. So tanggalin lang natin yon. Yan. Kukunin kasi natin yung exact location ng harmonic component na yun sa polar coordinates. Ayan, nakita nyo? Nawala tong revolution na to. Ibig sabihin, nag-terminate siya dun sa zero angle reference. I'm talking with this one. No? Ayan. The same approach dun sa phase C natin. Okay. So this is now the actual location of harmonics component natin dun sa polar coordinates but in per unit. Kasi divide natin ng base na 360. Di ba? So para makuha yung actual location niyan in degree, isa pang manipulation, i-multiply natin to kasi naka per unit yan dun sa base natin. Which is F17, no? F17. Ayan, no? I will try to highlight lang to. Okay? Then for phase B, multiply by F17. Then let's put the dollar sign para hindi po gumalaw. Okay? For phase C naman, F17. Ayan, okay? So this is the final position of harmonics component natin with respect to polar coordinates. No? Ito po yun. So kung mapapansin nyo, bigyan ko lang ng remarks dito. Yung position ng first order natin, which is the fundamental, is ito, no? So, let's try to graph the vectorial diagram of these fundamentals na hindi pa siya harmonic eh. Fundamental pa siya. This one, no, representing the, check ko lang yung color, no, ng ng ano natin. Tawag dito, blue. Positive sequence kasi yan eh, so blue. Okay, yan. Nakita niyo po ba? Representing the phase A for fundamental. For phase B, 120 lagging. So, ito yung position niya. Ganyan. Okay? Phase B. For phase C, 240. Ito. Yan. Okay. Ito yung phase natin. Okay? So, anong mapapansin niyo, sir, dun sa position ng harmonic component natin sa, or yung fundamental natin? Yung position ng vector na to is a positive sequence. This one, no? Yung angle position na to or yung vectorial position na to is positive sequence. Excuse me. Ayan, di ba? Kasi laging yung phase B by 240, yung phase B by 120, then laging yung phase C by 240, no? So, check naman natin yung yung next is yung anong order po itong gusto nun? Third order, no? So, this one, yung position ng angle mo, okay, is copy ko lang yung arrow. Ito po, no? Yan. Ito po yung phase A natin. Ayan po. Nasa 0 po siya eh. Okay? So for phase B, anong position niya? 0 din, di ba? Ayan, no? Okay. For phase C, ayan. Ito naman yung phase C natin. What is the position of this angle? 0 din, di ba? So, what is this position of vectors? These are zero sequence. They are zero sequence. Okay? Kaya nga binabanggit niya dito, they are copaysal eh. Sorry. Ito. Triplet harmonics, no, are copaysal. Ito na yung proof po natin na copaysal sila. So anyway, balikan natin yan. Tapusin lang muna natin lahat. No? Next order is yung flip, no? So copy, sige, sisayin natin. Ang color kasi is green naman, no? I-plot ko lang to, no? Green. So yung phase A natin sa fifth order natin is nasa 0 siya, no? So copy ko lang to. Extend ko lang to. That is for negative sequence kasi yan. Yan. This one. This is the phase A. Okay? Ito yung green. Yung susunod, 240 yung phase B natin, no? So ilagay natin dito. Medyo ilayo ko na. Phase A. This is the phase B. Okay? Let me try to change the color. Ayan. Palitan ko lang para mas clear ko, no? And this is phase A is green. Okay? So for phase C, anong value ng phase C po natin? Ito, 120. Okay? So ito yung phase C natin. Phase C. And what is with these vectors position at this angle separation, this is representing the negative sequence. Phase A, then followed by phase B at 240 lagging, followed by phase C at 120 lagging. Therefore, that is a negative sequence. Okay, so lagyan natin ng arrow para makita. Yan. Ito green. Yan. Okay? So let's try to filter, no? Kasi may pattern na to eh. Okay. Let's try to filter for lahat ng 120. Ayan. So these are all positive sequence, no? Let me check. Ano ba yung mga order na yan? Kung positive sequence sila. Let's hide these columns, no? Hindi na to significant kasi process natin yan to determine the yan, okay? So kung itong mga order na to, 1, 7, order of harmonics are positive sequence, no? So we already proved this statement. Ito, harmonics order of 3H plus 1 are positive sequence, no? Oh, wala dapat 4 to. Kasi na-cancel yan eh, walang even. Okay? So, approve natin sa calculations natin. So, balik natin. Unfilter natin. Let's try to filter naman yung 240. Yan. So, which is green, no? So, ano naman to? They are the negative sequences, no? Yung mga harmonic order na to, negative sequences, yung 5, 11, 17, 23, and so on and so forth. So, na-prove naman natin itong statement na to. Yan. Sorry. Okay, and I just want to correct, wala itong, kasi na-prove natin na walang even eh. Yan, okay? Ito rin pala. Yan. So, next naman is yung 0, which is representing the 0 sequence. Yan. Okay? So, ano napapansin nyo sa, ano muna yung order na 0 sequence? That are the 3, 9, 15, 21, 17, 33 order of harmonics are 0 sequence. Anong na-prove natin? This statement. Okay? Harmonics of the order 3H are 0 sequence, which ito na yon. We call them triplen harmonics, another term, no? Triplen harmonics. And they are copaysal. Bakit? Nakita yung vector nila. Position at 0 angle. Okay? Ayan. So, ang nagawa po natin sa exercises na to is na-prove na yung group of harmonics na to, yung blue, are the positive sequences. And yung yellow are the triplen harmonics, which is copaysal. Kasi nasa 0 angle sila, position dun sa 0 angle natin. And the green, highlighted by green, are the negative sequence, which is 5, 11, 15, 17. Walang even kasi na-discuss kanina na nagka-cancel out yung even component. So balik ko sa slide. Ayan, kita po ba yung slide natin? Hello?
Yes, sir. Kita po, sir.
Okay. So, balikan natin to yung last slide.
we try to understand the concept of this statement for the harmonics system or harmonics in three-phase system. And the result of this interpretation is ito po, no? So, meron tayong groupings ngayon ng harmonics, which is the yung blue, highlighted by blue, are the positive sequence harmonics component. Yung yellow are the zero sequence, and they are copaysal. And we call them, another term is triplen harmonics. And the green are the negative sequence harmonics, no? This is true for balanced system, but in unbalanced system, which is common case, no? Harmonics current shall contain phase sequence different from this table. Pero this is a good reference, no? So the process to approach and analyze line to ground fault is the same process somehow to analyze the behavior of different harmonics because both are zero sequence in nature. No? Wait lang po ah.